Oh, just live stream is popping. We need some glow proofs in here. I don't know.
All right.
Some of the other roles too might work, like space crab, space herpes.
Space AIDS.
Herpes.
Because they where's CB? He normally drops in about now. I'm just waiting for him. Holy, it's still on. Holy, you guys are still in here?
Mm-hmm. I'm wondering why you guys should have never left this one. It's almost 9/11, guys. It's almost 9/11.
Yeah, I think about that every year.
So I was watching this video the other day, and they brought something to my attention that I hadn't realized before. I always knew that 9/11 was if you put a line right down the middle of the Freemason symbol, like with the pillars, you have the 1XX1. But I didn't realize that they get that from the what's it called, what are those things called with those bundles of sticks that are like tied up, the
Fascies.
yeah, okay, so they get that from that, the way the rope is tied around the bundles of sticks, it appears to be like a 1X, and then you put them together, it's like the 1XX1.
Yeah, coincidences only go so far. At some point, you got to realize that you're seeing something deeper.
Right.
It doesn't mean you know what it is or you know exactly what's working, but you can see it.
Yeah, for sure. Yeah.
Yesterday, Jedi was talking about this weird interstellar object coming in the sky, and just how we've had all these weird things going on the past few years with these sky phenomena. Now we've got like interesting eclipse timings and places, occurrences happening.
Right.
The sun has been an absolute raging, angry fire god in the sky. It's been super active. We're going to get some auroral activity today or this weekend, potentially at lower latitudes. Again.
Right. You see the aurora borealis they were showing on the news the other day is white for the first time?
Stuff like that, right? Yeah.
Yeah. Dude, weird, dude.
There's strange activity in the oceans too. Oh, go ahead.
Oh, strange activity in the ocean?
Yeah, the oceans are getting really inexplicably cooler for some reason. And like around this time of year, off the coast of Panama, happening every year going back hundreds of years, like all these krill or shrimp or something like die off or something. Or no, it's like plankton blooming. The plankton blooms around this time of year down there, and this is like the first year on record that it didn't happen.
Oh shit.
Right. So you got like the ocean acidification happening too. Like there's just a lot of weird trouble looming under the surface everywhere you look.
Yeah.
So
In
Jedi's
Poland?
point is, yeah, go ahead.
Yeah, just in Poland where I'm at, like they had like summer almost didn't happen. Like usually it's freaking hot in summer. This year it started really, really late, right? And all these farmers lost record amounts of crops. Were getting frost when they all planted their crops because they know there's never frost after this certain date. And then all of a sudden there was just like weeks of frost. And so all these farmers lost their crops and it just hasn't got hot. And then in winter, right, it doesn't really get cold like it used to. Right, it hardly snowed all winter, and then it didn't really get hot all summer.
It
Something
almost
weird's going
seems
on.
like it's shifting because I remember, like, I actually remember this happening. I must have been in high school. We're talking about like 10 years ago or so. That the coast of the Mexican coast down there, that they stopped getting a current, so you weren't seeing waves at the beach anymore, and it was actually starting to get colder down there. Which, in return, that current is now bringing that warmer air up here or something. I heard. I heard that's
Yeah,
the
that's
reason
part of the
for it.
same
I don't
thing.
know.
Yeah, the ocean's getting cooler is part of that same thing. Gulf Stream jets are reconfiguring where they're blowing.
Hmm.
I mean, it's like the magnetic field is weakening. The magnetic pole has started to pick up velocity and just like moving faster than people recall it ever happening. I mean, I don't know how much of this is like extrapolated observations and how much of it's actually true, but
Yeah, I mean, if it's climate change, I mean, I'm really not too worried about it because I mean, the climate's ever changing. You know, it's in its name.
also like there's interesting stuff in like some of the geological records showing that at one point it seemed like the magnetic field was aligned more or less 90 degrees from where it is now. So I think like the North Pole would have been like by Madagascar if Earth is a globe.
I'm
And
geographically
so
almost.
You know how they
right,
say
some people think that the crust of the Earth, like the globe Earth, becomes detached and physically shifts. But from a flat Earth perspective, it's more like maybe the sky just like reorients 90 degrees, and so you've got like sun up in the north and sunset in the south at some point.
Yeah.
The sky does, or just the magnetic field itself does a whoopsie do? It detaches itself from the rest of reality and just does a spin. Because if everything else stayed the same and the magnetic pattern or flux pattern just does a backflip, then yeah, I could get behind that.
Right. So during that transition time, there's going to be a period where like crops are going to die and people are going to starve. Like that's the worry.
Have you guys ever I'm going to say this have you guys ever known anybody or not just heard the slogan or the phrase starving to death, but really I don't think anybody has ever known anybody who's literally starved to death, But we've been hearing that expression since we were little, but we don't really have eyewitness accountability. If someone were to fast for an undetermined amount of time, would they eventually die,
Well, yeah, like I mean, I used to watch a lot of those shows. Like I forget exactly what it was called, right? Just like a survival show. They put people out, like, and this was like a genuine one, right? Not those bullshit ones, right? They put people out, and whoever can they'll put a whole bunch of people on an island in different locations, and whoever can last the longest gets like $1 million or whatever. Right, and it's like a bunch of them have to get you see them, they get thinner and thinner and thinner and thinner, And then they get to a point where they don't have any fat left, and then their body starts using their muscles as fuel instead of their fat reserves. And then once their muscles like run out, then it starts using organs. The body starts using like devouring the organs basically as food, and that's when they have to call in medical teams, and they basically say like, yeah, like you can die like super quick. And the people look like they're about to freaking die too, right? They look like they're about to die. They can hardly move, they can hardly walk around, and then they look like they're on death's doorstep. But that seems to be what happens eventually.
Is that the
right?
Alone series?
I think it might have been Alone. Yeah, I think so.
That's some crazy shit in there. They get
Yeah.
what is it, weekly medical checkups, and some of them just can't find food. They're in just nasty spots, whether there's animals competing for it or whatever. But I've seen some of them episodes. They're pretty hardcore.
Oh man, yeah. You know, and that guy I was just talking about specifically that happened to, right? He had tons and tons of fish, and he was like hoarding it, and he was trying to save it. But he got to a point where he there was some psychological condition can happen where you get this like weird hoarding syndrome, and he wouldn't eat any of the fish even though he was dying. And then the medical team had to come out and check on him, because they come and do checks on them every now and then. And they're like, you got to leave, right? And he's like, but I've got all this fish, I've got all this food. They're like, it's too late. You're in too bad of a state now. You can't just start eating the fish. We got to take you in. We got to put you on drips and shit like that, right? To slowly like work your digestive system back into order again. He was devastated.
You guys ever heard of breatharians?
Yeah, I've heard about it, but I have to call bullshit on it.
Yeah, bullshit.
Yeah,
Total bullshit.
Yeah.
You think so? I mean, I don't know. I'm just asking. You know what I mean? I don't know one way or the other. I do. My personal belief is though that I think people can go without food, possibly indefinitely. I know you need liquid, but you know that's just my opinion. I'm too weak to try it. Hopefully, one day I will.
That's like when people were telling flat earthers that they could stare at the sun and not damage their eyes. You just got to try it.
I mean, I do sun gaze too, but I think that's just something that somebody. Well, it's like an individual thing. You know what I mean? Like if you have faith in it and you think it helps your eyes, you know what I mean. And if not, if you're afraid of something, you think
Yeah.
it's going to damage, then it could. I don't know.
I think globe earthers came up with it to troll flat earthers with.
Really? I mean, people have been sun
Yeah,
gazing.
like there's a lot of that.
So do you think the sun's bad to stare at then?
Well,
Yeah.
speaking of the sun, I'm not. You guys were just talking about coincidences. You know, the alien spacecraft that's meant to be approaching Earth. So it's going to cross the sun on Halloween afternoon. You
Oh
know,
shit!
Satan's
Yeah,
it's crossing the sun on Halloween. So
you seen that
it's
in the
pretty
news?
crazy. I've watched this guy called Moon Harvey on Facebook, and he reveals
You're breaking up.
all these, all these crazy events that are happening around the world. All these, mate, it's a lot of biblical stuff, yeah. And apparently, true this is, but did the blood moon? It changed right above Israel. I'm pretty sure when it turned into blood red as it was crossing.
Oh shit!
Right after Halloween begins the Tard meteor stream too.
I'm a firm believer now in everything we've ever been told as kids, like growing up, from the media, from teachers, just from the mainstream. I'm a firm believer that the exact opposite is the truth. And if we were actually going to do the opposite of everything we've been taught up to this point, we'd probably be a lot better off. But that's not medical advice, that's just for entertainment purposes.
Yeah, dude, I remember them teaching me crazy stuff like that eggs are bad for you and stuff like that. Eggs.
Yeah, bro.
Look,
And to drink milk, like, you know,
I've been crossing a lot of.
strong to grow your bones strong to drink milk. You
Sorry.
know what I mean?
Oh, don't hate on milk. I love
I've
milk.
been crossing. I've been
Yeah,
crossing a lot of information.
You go ahead. Sorry, Shaggy, go ahead, man.
Like, what do you guys think of that? Yeah, right, that our thoughts, like our imagination, can determine our future. Like,
Yeah, I think that's true.
if you believe in it strong enough, you know, because if you think you're going to have a bad outcome, usually that's going to happen. It
Yeah.
provokes it, and can we really shape our future, like with our thoughts, with our mind,
Yeah, I think it's possible.
with our dedication?
You know, we've been
It's
specifically
pretty
trained.
revealing stuff. Like, I keep coming across this information. It's just like you're shoving it right in my face, really. Like, like it's like trying to listen for it. Just all of a sudden started popping up on my feeds. Yeah, you need.
Ever since we were little kids, we've been taught and trained under a certain like a certain method, and so it's kind of hard, even once you become a flat earther, to kind of like get your mind out of like that mainstream thought process. You know, I mean, it's been ingrained in us for so long.
Yeah, I catch people all the time, like even myself, like contradicting myself, like, oh shit, no, that's not true. Actually, I've proven that. Why am I still thinking that?
Right?
Yeah, that's true. And all of these bad events that are happening around the world, like, it's good to acknowledge what's happening, but if you get fixated on it, that's kind of like a scary thought. Are you provoking it if you get fixated on the idea of it?
I went over to Jim Panda's server like an hour or two ago, and nobody was saying anything on there. And then finally, somebody said something, and I'm like, "Well, I'm gonna get going now. I'm gonna go make a plate of spaghetti." And all just insults. They're like, "Oh, you're gonna have trouble opening the can." I don't eat spaghetti out of a can. They're like, all flat earthers eat stuff out of cans. They're like just totally just like trying to talk shit. I was like, whatever.
Yeah, that's what you get for going there.
Yeah. Yeah.
It's pretty funny.
I know a little poem about cans.
Yeah, my internet
Before I
sucks
go
right
to
now, so
wow, you're lagging hard, bro. I saw your light flash on, your light flashed off, and then you spoke. But anyways, I'll rip
yeah,
this little poem out
I'll
and then I'm
probably
going to go
drop
to
out in
bed.
a minute.
Because oh mate, talking about cans just reminded me. I've got this friend and we call him Tim. It's fun to throw tomatoes at him. Tomatoes are soft and don't bruise the skin, but these bastards do because they're still in the tin.
Yeah.
Anyways, I'll catch us later, guys. Peace.
Funny, see you, Matrix. I got to go into the office, so I'll be listening, and I'll follow the herd wherever it goes.
Right. kind of work you do?
Market and econ analysis.
I'll pretend I know what that means.
Same.
Is it working now? Hello. It's still not working.
What up?
Damn Discord shit.
What's up?
Is my mic working? Sorry.
Yeah.
Okay. Probably barely.
No,
I was
it's
just
good,
saying
Dave.
hi. And
There's nothing wrong with it.
cool.
Loud and
Just
clear.
saying hi. Just wanted to check and see if y'all got anything for this globe thing. I know you don't, but go ahead.
No, it gets worse. It just keeps getting worse for the globe side. Yeah. Yeah, their arguments are getting worse and worse and worse.
So even after another PhD came in and told us what's what, we're still here. What's going on? No curvature.
All that came from that was the no hands joke. And now we ask everyone if they know that they have hands, and most of them say, no, I'm not sure that I have hands. And then everyone laughs, and we don't take them seriously anymore.
That's the level of intellect that they're at. They reduce everything to absurdity, so they don't have to actually prove anything, right?
Yeah. They don't even know if they have hands. So how can they trust all of the proofs that show that there's no curvature, right? If they don't even know they have hands.
I have no hands. I have no hands.
Yo, that was from Kids, right?
Yeah.
Oh no, legs. I have no legs.
I have no legs. I have no legs.
Dude, that was messed up. Don't watch it. Seriously, don't watch it.
Man,
That
ain't you
was a messed up movie, but it was actually a pretty good movie.
I know it was.
No,
Yeah.
but
I can't believe you guys know about that. That's funny.
Well, listen, I'm not a young dude, so
All right, fair enough.
Man, ain't you ever seen that one movie?
One movie, kids, nah, but I seen that one with Sam Doobie is. That was just in my fucking head.
Right? You want to know some Eminem trivia, bro? So, do you remember in the Eminem show how he had a skit before the song Soldier where he's driving with Gary and he's going to pull up at the club and he jumps out and pistol whips the bouncer?
I don't, but I'm
No.
sure maybe someone else does. I'm a metalhead, dog.
Oh, you are? Okay. See, I'm like
watching Headbangers Ball.
Eminem.
I can't remember my childhood, but actually I did listen to Eminem when I was younger. I just definitely don't remember that.
Yeah. A lot of his things, he'll make a song, right? And then he'll come out with part 2 to that
Oh my
song.
god, I'm about to see an accident. Fuck. Sorry.
Huh?
Go ahead. Thought I was just going to see a head-on collision. Sorry, what'd you say?
So he'll make a song, like, for instance, he'll make a song called 3 a.m., right? And then
Yes.
on his next album, he'll make a song that's like the same type of beat and everything, and it'll be the first part to the song that he already made. So everything's like in reverse. You know what I mean? Kind of.
I never noticed that, no.
Yeah. Okay, so in his album, the Slim Shady LP, he has a song with him and his daughter, just the two of us, and you can hear
Yep.
gravel. They're walking through gravel, right?
Yep.
Well, that's part 2 to the next song in his next album that came out called Kim, which is actually part one.
Yeah, it's when it brings her to the lake.
Yeah. So like you could put both of the songs together and loop them together, and it just plays continually. You know,
Lyrical genius.
right?
I never noticed that though. Did you notice that on your own, or you just like picked up on it, or you read that or something?
Because I used to obsessively, I like memorize all his albums and everything. You know.
Oh, shit, that's pretty cool. Yeah, I like music to that extent as well, so it's pretty cool that you noticed that.
Yeah, it was like Rain Man kind of.
What's today's false flag? Let me look it up. Bill Clinton's letter and Epstein birthday book among new files released.
My God. So many distractions though.
Yeah.
You know what I love doing is every time there's a mass shooting, I love to I go through YouTube and I try to watch as many like eyewitness accounts as possible. And like from doing that over the years, I've picked up people that have been in multiple mass events and they all play different roles and characters. Dude, it's such a trip. I even got David Hogg playing a different role. I don't know if you guys remember David Hogg.
No, but I'm gonna Google him now.
I even made a song called David Hoggy Style. David Hoggy Style.
Oh, okay, I know who that is. Yeah, I've seen him
Yeah,
videos online.
yeah. So I actually found a video from a shooting that took place like a year ago. Where he's an
Let me
eyewitness.
guess. Let me guess. It was Sam Hyde.
Close, very close, bro. Very close.
But yeah, you're saying he was like the eyewitness account or something.
Yeah, I'm gonna post it. I'll post the video right now. Hold on. Let me see. I mean, I back when I really didn't have a life. Not that I have one now, but I spent weeks and weeks and months, dude, just scouring through YouTube, just pouring through comments. Even you know what I mean? And I'd hit little jewels every now and again. You know?
Yeah, you be hitting jewels, dog.
Yeah,
Maybe
jewels,
it's not good for you, dog.
bro. Right? Mm. I'm
You
gonna
notice how
post.
that smoke goes up, man? Where's that gravity?
I know, right? Okay, I'm gonna post this. Dee-dee-dee-dee-dee-dee. Okay, where should I post this in? Let's see. Where should I post this? Live stream voice text, I guess. Would that be
Yeah,
the? Okay.
I think it like auto like removes your stuff after a little bit if it's not like pinned or something. I'm not
Okay.
sure, but
Let's see. All right, I just posted it right now. Is David Hogg reporter Eric Vienna?
oh shit, that's who I thought you were when you showed me the when I googled the name. That's who I thought it was.
Who? Eric Vienna?
Yeah,
You've heard of him before?
isn't that the reporter that I always see in the online videos? Not this David Hogg.
No. David Hogg is the one you see in the online videos.
Okay.
David Hogg is the
David
one
Hogg,
who.
a reporter as well.
No, David Hogg was one of the students who was at the Marjorie Stoneman Douglas shooting in
Oh
Florida.
yes, okay.
Yeah,
Hmm.
he's the one who created like March for Our Lives and all that. I gotta post the song now. The song that I made about him for entertainment purposes only. Mhm. There we go. There we go. All right. Let the good times roll.
Time.
Mhm.
All right, I'm about to be pulling up to my first job site in a couple minutes here, so I'll be
All right.
definitely not the. I'll be muted and gone.
All right, bro.
the experimenter. That's why we have double-blind placebo studies, right? So most people, I don't know if you know what a double-blind is. So the people that are administering the tests don't know what they're administering to the people, right? So say you're giving them, yeah, exactly. So like, what you would have is you'd have a group tell another group, hey, give this to this third group, right? Give this, this pill. They don't know if they're giving the person a medication or a placebo. They have no idea what they're giving the person. But the first group does. But the group that's actually administering the test has no idea what's going on. So that's a double blind, right? The people actually administering the test have no idea what the test is actually of. Right? So their bias can't even enter into it because they don't know what they're doing.
Yeah.
It's like hiring an outside company to do an investigation on like your own research, your own evidence, your own information.
Now imagine someone setting up a Foucault's pendulum like this, right? You take people that have no idea of anything about the Foucault's pendulum, rotation of the Earth, none of this crap, right? You go into the Amazon rainforest, grab some freaking, some natives, right? We're like, hey, tie a coconut to this string, tie it up in this tree, and swing it back and forth, and we want you to record like how this coconut turns, right? The swinging coconut. You think they're going to get back 15 degrees times the sign of the latitude? Hell no. They're not going to get back anything like that.
Yeah.
They probably just laugh at you.
Yeah, they probably just spear you and be like, you're stupid. Get out of here.
They roast people in here. They'd be like, you think you smart. We eat you, we get smarter.
Right.
Like, why use coconut? Let's use his head.
Yeah, it was just interesting, man. The guy came in yesterday and he was acting like it was just same old shit.
Yeah, man. Instant Glober, or Instant Globe expert, just add Google.
Just add Google, yeah.
He wasn't even Googling it.
Just add Google, I'm just an expert.
Oh, somebody dumped him in Cog Dis again, huh? He's in Cog Dis.
Last night.
No, he's in there now. Like he's typing right now. Yeah.
I think Heretic might have put him in Cog Dis.
To bring his ass out. I'm serious. Like I do it for the people, man. They need
I know you do.
They need to know. I don't know if Indio doesn't want to do it because I'm in and out.
I don't care.
I'm gonna fucking wind up leaving him with you guys.
I don't think Indio's tested him yet.
Yeah, I don't know if I'm gonna be dragged down to that level, man.
You should, dude.
Oh,
Here,
please.
let me get him out. Let me get him out of there.
I'm gonna be on mute for a minute. I'm cooking.
You can always toss his ass back in there.
Who was in there last night when Jedi kept asking him what 1 mile times 1 mile is, and he kept converting miles to meters, 1609, then multiplying that, and he couldn't admit that 1 times 1 was 1. I mean, for like an hour straight.
I was there for that. That shit was hilarious.
That was hilarious.
I was actually like pissing my pants.
First, you have to convert the mile.
Well, again,
y'all are biased. Dude, that's like crazy bias. Like, I'm so biased, I'm going to deny like basic unit conversion.
I think QE got him. Like before I came in, QE said that he was asking, "What's 1 mile times 1 kilometer?"
Yeah, he tried to multiply miles times kilometers. That's what QE was saying.
Yeah. Well, like so he's like, "Oh, you got to convert it to like, for a meter, like 1 meter times 1 meter, you got to convert it to decimeters or centimeters." And then even that math was wrong. He was like, well, it's 10 decimeters times 10 decimeters equals 100 decimeters, and that's 100 meters. Like that. Like it was really fucking weird. And he's like, the same thing with centimeters. 100 centimeters times 100 centimeters is 10,000 centimeters, and that's 100 meters. And I'm like, like the math wasn't adding up.
What?
And then so I asked him, I said, so what's so if you got 1 meter, right? So what's 0.01 what's 0.001 kilometers times 0.001 kilometers? And he just shut the fuck up after that.
Maybe he lost his calculator.
Bro, I did the math. Like, if you converted it that way, right? Because 0.001 kilometers, the same thing as saying 1 meter, right? But if you multiply 0.001 kilometers times 0.001 kilometers, it comes out to being 1 millimeter.
Oh. Oh, that would have been good. I mean, I get what he was trying to say, but I don't know why he was pushing it as if like that was some way of proving us wrong or something. That's the part I didn't get.
Right.
I mean, he's right. I mean, you can put X in there. I mean, you can put any number in there if, for the miles or whatever. He's right about that, but it's just like he tried to make it, I don't know. I just don't get why he thought that was somehow some kind of evidence or something.
Right. Well, I mean, even if you did, let's say you did 1,000 millimeters, right? Same as 1 meter. 1,000 millimeters times 1,000 millimeters is a million millimeters, and then if you convert that back to meters, it's 1,000 meters. Like the fucking, it was an unnecessary conversion.
Right.
Yeah.
Usually we simplify. In math, we simplify. We don't make it more complicated.
Good. I kept saying, what's 1 times 1?
And besides that, if you were going to convert, if you're going to multiply miles times kilometers, first you'd have to convert the miles to kilometers, then you could multiply them. Otherwise, you can't figure that out.
Right. He's like, what's 1 times 1?
Wrong.
Like,
I mean, I only went to high school math and all, but.
And he's like, what's 1 squared? Like, he just kept like finding different ways to like say 1 times 1. It was fucking hilarious.
Oh yeah, the square thing was getting me. He was like, "No, something squared by something is the same as 1 squared." I'm like, "No, dummy. When you square something by the height of the observer, it's different. It multiplies. It becomes. It's not a slope." And he's like, "What?"
And this all started because of 8 inches per mile squared. Wasn't that how that worked?
Yeah, that's what triggered him.
Is he here?
Yep.
All right, he just joined. Yeah.
That's a perfect storm.
Let me unmute him.
So here we go again. Am I going to get muted? Am I speak again?
Well, if you talk over us.
You're speaking.
I mean, only if you talk over us, except that you guys can talk over me.
Yeah, pretty much. But check this out.
That's not very appropriate to me.
Yeah, it is. Check this out.
Yeah.
What information do you have?
Biased.
Okay, whatever. What information do you have to bring the Earth being a globe today? Because you were chirping in the Cogdis channel. What do you have today to bring?
I was talking about how the moon reflects sunlight and does not emit its own light, and the angles on how that works, and how you can see the moon reflects sunlight on the side of Earth that faces away from the sun, which would only be possible if all three are spheres. Just saying. And so far, no counter argument has been sent. I posted five sources of it, and I can get 5 more others and 10 more others after that. Let me finish. I posted 5 sources.
Back to the beginning, though. So, like, why? Like, why? You said all 3 would have to be spheres. Why would the Earth have to be a sphere for the sun, for the moon to reflect sunlight?
For the moon to reflect sunlight on the face of Earth that faces away from the sun.
What are you talking
about? There's a difference. It's not just for the moon to reflect sunlight, the Earth, everything must be a globe. No. Everything must be a sphere for that sunlight to be reflected specifically on the side that faces away from the light. So when it's nighttime on Earth, okay, you're facing away from the sun, you're facing away from the light. Yet the light still reaches the moon that you see above you, which emits all light back to you reflected from that sun. How is this possible on a flat Earth? Please explain that to me.
Okay. You can't
Does
see
light
the
travel
sun.
forever?
That's the only thing you can actually say, is that you can't see the sun, but the moon is lit up by the sun. This is what you're saying.
No, that's like you're pretty much downplaying. I'm putting more factors than that in play so that you can understand how and why these dynamics work. Do you not understand how lighting works with spheres? Yeah. So, thanks, Rusby, for posting the image. Yes, that is exactly the visual representation of it. Now, explain how this sun could light the moon halfway through like that and have it reflect onto the dark side of Earth. If the Earth is flat, if the Earth is not a sphere, okay? If the Earth is not a sphere, how is this going to work? If you had the sun and the moon floating on top of this flat Earth that is not a sphere there, we would see the moon and the sun from the nighttime and from the daytime.
Okay, first of all, stop eating your fucking
It's really
mic,
big,
dude. Okay, stop eating your mic, dude. You're way too loud.
I'm not eating my mic, dude. I've explained to you why I have to talk loudly to speak, okay? I have medical issues that are physical, and you would have to understand that. So, no, I'm not agitated. I'm not angry. I'm not aggressive. I do have to push my voice because otherwise there's no sound that comes
Sound very emotional.
voice.
I don't know why you're carrying the water for other people.
Because I have a pretty broken voice. That's when I'm not
Hey, dude. What the fuck is melodrama, dude? You like a chick?
You understand
fucking
that?
chill, dude.
You understand now? So can I actually use my voice now, please? Sorry,
dude.
I understand I'm a bit loud. You can probably reduce my volume a little bit to adjust your ears. I'm not emotional, my friend.
Conversation.
Well, why do you always have to say you have to be emotional? Like, what's this code that I must be emotional for you to? I don't know what.
I've never talked to you before in your entire fucking life.
Okay, then why are you calling me emotional, man? I'm literally just speaking normally here. Bro, if I were, I'm not sad. I'm not angry. I'm pretty neutral. I'm not feeling bad or ill or anything like that. Sure, it hurts to speak, but that's a normal symptom of my physical ailments, and that's why I'm speaking loudly. I'm sorry.
Dude, I'm not. Listen, I'm not trying to like handicap shame you or whatever the fuck they call it nowadays.
Yeah. I mean, I'm trying to make you understand. I'm not being emotional. It's just that yes, I have to speak loudly. Like I said, I'm not pretending.
It's not really the loudness. It's more like your tone and inflection. But
I mean,
your problem too.
I guess my voice is pretty much broken from all my smoking as well. So yeah, the tone might also be off and on.
But anyway, let's get to the point. Let's get back to the topic.
Yeah.
Enough about you.
I mean,
so
if I'm emotional, I'll say it.
So if you see the moon, right, like that Terminator line where the moon is, the sun has to be 90 degrees from that Terminator line. Is that how it should be? If the sun is illuminating the moon? Like if I look up the moon and I see a Terminator line, the sun should be 90 degrees, right? So Terminator is a line that goes across the moon, right? Touch the moon.
I mean, for this, let's say
90 degrees from that, right? It should be able to
for the 90-degree half moon. I see a half moon is not the only time that we see the moon lit. The moon can be crescent lit. It can be half lit. It can be full lit.
I know.
Okay. So yes, for this half lit, I would say that yes, you probably need this 90-degree angle. It's probably not always going to be 90-degree angle because we don't have a half moon every night.
No, what I'm saying is, right. So the moon, whatever it is, the sun is lighting up one side of the moon, right?
Yep.
And the sun has to be on that side, the lit side.
Well, I mean, the moon side must at least be facing the sun. So it's the same way that Earth side, the day side of Earth, has to be facing the sun. Basic lighting here. Basic lighting with spheres.
So if we observe that not happening, what would you say about that?
Huh?
If we observe that not happening, right? If the sun and the phase of the moon don't align geometrically, what would you say about that?
Well, I would say that that's a very compelling counter argument, but you would have to make sure that this is the case. Please.
Yeah, it is the case.
Oh, is it?
Yeah, I'm going to show you. Hold on.
I mean, okay, to according to like worldview, you have the sun and the moon on top. Oh, you're gonna
according to Oxford. It's not according to me. Oxford University.
Okay.
Hold on. What's in the chat?
And also, given the, let's say, is your Oxford giving? Oh yeah, of course. So this is working with a half moon. So as you can see, when you have the first quarter here, take the first quarter, the moon is directly facing the sun, right?
Yeah, but if
and as you can see here, so this is supporting my point. The every lit point of the moon here is facing the sun.
Yeah,
I don't see the issue.
No, it's not facing the sun.
It is facing the sun.
It's not facing.
How about you try reading the text that's there?
Okay, so you're telling me that the sun is always at that position
I'm not
while
telling you.
Dude.
I'm not
What he's trying to explain to you is that there's a known phenomenon within like the globe lore that's called the moon tilt illusion or moon terminator illusion, whatever, where when you observe the sun and the moon in the sky at the same time, then the part of the moon that would be lit by the sun doesn't match up with where you actually see the sun in the sky. It can be off by a lot of degrees.
Hey, let's go to the waxing crescents here. Can you explain to me why it's like
overhead with the term, but the.
Can you explain to me why the light side on the crescent appears to be spherical?
He's going to pretend that didn't happen.
That what didn't happen?
What the whole conversation just happened? You're going to pretend it didn't happen, and you're going to whistle past the graveyard.
No, I'm not. I'm actually asking you about.
Hold on.
Oh yeah, you see, I can't talk again.
You said that it would be compelling evidence if we showed you that that was not the case. So we're trying to show you that this is not the case, and you're just barging through with more questions.
That it's not the case.
So can you calm down a bit? Stick to the topic. We're talking about the moon and the sun, right? And the lit part not matching where the sun is. This is a known phenomenon even within the globe story. So why are you denying this?
You're just under the bus, though.
I wonder if he heard you guys.
I'm actually just reading your post because figure 1131.3 that you just posted. I'm actually just reading that, and it's not saying anything on the contrary to what I posted at all. In fact, it is supporting it, but of course you don't see that.
Okay, yeah. So the whole article. Okay, so I'll post the source. They say that this is a visual illusion, right? Because it doesn't match the geometry. It's the same way as like the Selenoid eclipse.
Oh, I mean,
an optical or the horizon or any number of globe things that. Okay, so the horizon's here. It's not supposed to be there, so that's an optical illusion. The base is supposed to be looking this way, but it looks
the moon's path depends on the season and most crucially on the observer's latitude and the equator at the time of the equinox.
That ain't your voice, okay? That ain't your handicap, dude. Sorry. Good try, though.
I think that's a mental handicap.
Maybe. That's fucked up, dude. What a spaz. You guys dealt with this yesterday?
Well, he wasn't like this yesterday, but...
Oh, yeah, he was in here. Yeah, it might have been because of yesterday, because he was in here and we put him through the ringer for a couple of hours.
Was he acting like that? Man, that's fucking sad.
So, sometimes. He wasn't really going off the rails too much, but he's biting up a little bit more than he was yesterday, though. I'll tell you that much.
Dude, he just did his like the Linda Lovelace on his fucking microphone.
Now, I came in at the end yesterday, and they were muting him before he got to this stage. He was like, just as he was building up to this little meltdown, they'd mute him. I think they've been sick of dealing with him all day.
Yeah.
It was funny though because he'd get muted, and then we would make our point, and we'd unmute, and he'd still be in his fucking conversation.
He thought he didn't mute.
Sheepdog's just rolling back there. He's like,
"Bro, I'm."
Because he doesn't know what he's dealing with. That's why
he doesn't even understand his own argument. Yeah. Like he doesn't even understand his own argument about the phases of the moon. He doesn't even understand it.
Yeah.
Based on what he just, there's nothing about the light reflected to Earth. Do you understand your own argument? Like, dumbass. Like, bro.
Nope.
Moving on.
I love it though.
So, Sheepdog, you know how on Twitter we were talking about that dumb shit? Remember I was talking about like people like posting in this weird way?
Mm-hmm.
Conspiracy Smasher. You know who that is?
Mm-hmm.
Yeah, he's one of the
affiliate.
Yeah, one of the tards that posts this way, right? They take a flat earther post and say one sentence, then say something dumb about it.
Yeah, they twist it around.
Orbital Brain does the same thing. Slice Arcane does the same thing. By the way, Slice Arcane says that
Simon Dan does the same thing too. That's what's fucked up. That's what's fucked up because I never like saw any of these like big Glober posts until like Musk did whatever he changed on Twitter. So now I get like Fight the Flat Earth crap, frickin' Simon Dan crap, Professor Dave crap. And Simon Dan and Conspiracy Smasher and all these other random anti-flat earthers on Twitter, just lately, they all started posting the same way. They go find a flat earther post, try to find especially a particular dumb one, and then post it and say like one, look at this dumb flat earther doesn't understand. And it's always the same thing. The flat earther doesn't understand X, whatever the meme is about.
Mm-hmm.
It just over and over again. But this dude, Conspiracy Smasher, embarrassed himself this time to the point where I had to like call him out because he said someone posted a meme about Coriolis effect, airplanes and all that crap.
Mm-hmm.
And this asshat said he thinks the Coriolis effect has something to do with conservation of momentum.
What?
Saying that listen, yeah. And calling him dumb because the person, well, the meme didn't explicitly say it, but he was saying that conservation is not the reason for the Coriolis effect, which is stupid, right? Rigidity in space, right? The plane of the pendulum. Like, dude, man, like, in Glober's, like, dude, it's just like frustrating because some random person's going to read that and be like, yeah, it has nothing to do with it, and think the Coriolis effect is an actual force, right? And not an apparent, a pseudo force or whatever they call it. It's crazy the shit that they post and get away with. That's just nonsense.
Well, the random person that reads shit like that, I point him to Neil deGrasse Tyson because he said the same fucking thing. And look how stupid he sounds.
But it is conservation of angular momentum. That's what they say. That's what it is. Right. The plane, right? He said, Doofus equates Coriolis effect with conservation of momentum, thinks he's brilliant. The meme was, if Earth was spinning under a pendulum, why doesn't it spin under a plane? So I literally just went, and it took me 2 seconds. You just type in Coriolis, pendulum, conservation of momentum, bam, you get like 20,000 fucking citations from universities, right? That's saying the Coriolis force, the pendulum's swinging, and its momentum is conserved because it's swimming in a plane, and the Earth is rotating underneath it, right? That's the idea. Fucking dude saying that that's wrong. Like, these dudes don't even understand their own shit. It blows me away. Like, how the... Imagine, I think of it like this. Imagine, like, not knowing something about something and arguing it.
Mm-hmm.
Right? I mean, I don't know, like, very much about, like, say, think of something. It's Shakespeare, really hard. Right? I know, like, jack shit about Shakespeare. Imagine me arguing with somebody that studied Shakespeare and telling them they're fucking wrong about certain freaking roles or acts or parts in it. Right? And arguing it over and over and over again and making, like, spamming accounts. And, like, dude, like, are you kidding me? Like, these guys are psychos, man.
Yeah. No, I was going to say earlier, you remember how, like, we had Slice Arcane in here a few days ago? I don't even know if he's still in, like, Cogdis or Heliocult or anything like that, but...
He denied it was him.
Yeah, he denied it was him.
I think it was him.
I think it was him, too. I think he was just being a troll.
I think it was him for a bunch of reasons. He kept saying I, right? He kept like referring to himself. I did this. I did that. I did the other thing. Even a LARPer is gonna screw that up.
Mm-hmm. But yeah, it's a weird, different, like, even with TikTok. I don't know. I don't know if Alpha is still on TikTok. But like even TikTok's different than Twitter as far as that monster goes. It's almost like TikTok is like the like 12, 13, 14 year olds mindset and everything, and then Twitter is like that adolescent, that 17, 16, 17, 18 year old mindset. But I like Twitter or X, because people don't shut the fuck up. Like they expose themselves every single moment of the day. So that's why I've always stayed on there.
Twitter to me is like adult children. Like some people are.
No, you get a 50-year-old person. It's like, how old are you? I'm 50. You fucking sound like you're 19.
They have the emotional stability of like teenagers. That's the thing, is that they're all so fragile. It's hilarious.
Yeah, they're fragile. That's why they can bring. That's right.
What's up, rookie?
I said, you say they're fragile, but oops.
I think a lot of them just pretend to be fragile just because it's their troll.
Yeah, of course. It's that defeatism shit, like, oh, you guys mean to me, you're just being rude, and you won't let me talk, and you cut me off. It's all the same crap, Even though they don't really say anything once you give them a chance to speak. They just talk about how we didn't let them speak, which doesn't make any sense.
Yeah, also, this dude is like constantly over talking. Like he'll ask a question and like a couple of words into answering it, he'll already be talking, which means he's not even listening.
Right.
Well, I do that too. I think that's probably just a mental thing, but I mean,
Well, yeah, I mean, like
rhetorical questions.
But I mean, like we've all been there where, like, any good person who's going to be honest about like the back and forth conversation, you're going to realize, like, I've interjected this person long enough, let them get their shit out, so that way we can dissect it one by one. And then they get mad because, like, as you're dissecting it one by one, they have to like refute every dissection, and they keep interrupting you. It's like, dude, I just let you go on for 5 minutes. Let's get through these 10 things that you brought up one by one. So once I've dissected this and you see that it's bullshit, now we can move on to the next thing. But they don't want to concede that loss. That's the problem.
They just want you to not work that way. They don't want you to eliminate all their arguments.
And I hope NPC or Perfect Storm, whatever you go by, I hope you're listening, even though you're muted. I hope you're listening, because listen to how we talk to each other. Yeah, we walk on each other, and you just have to have courtesy to let the person finish. We don't mind letting you finish, bro, but we're gonna address what you say, and until it's addressed, you don't get to refute or rebut. You got to let us get our shit out too. That's how back and forth conversation goes, man.
Well, there's also that, the server is, we're running the server, so we kind of have sort of command over it. Like, I mean, I know that's not necessarily fair, but it's true. I mean,
right. I mean, there is a 24/7 globe.
Then why would we let some argument that doesn't make a lot of sense?
Well, the guy can barely form a coherent freaking sentence.
It's a handicap, man.
That's being generous. But
I think the fact that he's so triggered about this is probably telling.
that's why I want to ask him about. I don't even want to talk about like flat Earth versus globe. He obviously doesn't know anything. I want to know why he's here, like fucking carrying the water for something he doesn't understand. That's what I want to know. What's motivating him to come in here and like be here for like 24 hours, going nuts, defending something he's learning about right now. He doesn't know anything about it. He's learning the globe actively right now. He knew nothing about it till he came in here, other than some diagrams, maybe like a Netflix, documentary or something.
I think he might be right.
But he's not emotional.
He saw one of those Nat Geo, like Animals in the Wild Earth series.
He was like, "Yeah, these guys are stupid. Let's go."
I'm gonna unmute this guy.
I love it.
Hey, NPC, you're unmuted. We're not gonna talk about. We're gonna talk about you. Okay, so why are you here for the last 24 hours, throwing your body into the gears of something you don't understand?
I understand the gears. It's just that you guys think I'm wrong. I get it. You guys think I'm wrong. And look,
is it all right for us to think wrong?
You're not even letting me answer your question. What's the point of asking me a question if you're not going to let me answer?
The question I asked, dumbass.
I am answering it.
You're asking a question you made up in your fucking head. The question I asked was, how come you've been here for the last 24 hours defending something you don't understand? You don't understand the globe.
I do understand it. You just think I'm wrong.
To the sun? How did they get the distance to the sun?
We've been through this so many times, and you do not accept the answer. I don't care. I don't care to repeat the same argument that you just refuse to accept.
You said you understand the globe model. I want to know, in the globe model, how did they get the distance to the sun? Tell me. Educate us.
They did the experiments that I mentioned yesterday.
How did they get the distance to the sun?
Use the radius.
No, they didn't.
No.
How do you get the distance of the sun? You have the speed of light, and you measure how much time it takes the light to reach Earth. 8 minutes, 90 million miles. Simple as 1, 2, 3. But of course, you need to know this constant and this constant. And how did you get this constant? And then you're going to loop that infinitely. How did you know a millimeter is a millimeter? How do you know a second is a second?
Holy
seriously, dude, it doesn't work like that.
How did they get this?
How did you know? Listen, how did you know it took 8 minutes to get from the sun to Earth? You would already need to know the distance.
Bingo.
You have to know when it left the sun, right? Some photon that you're going to detect on Earth, right? You have to know when it left the sun, and that you picked it up 8 minutes later, right? You need a time. Right? So at time 0 leaves the sun. We're going to we got a stopwatch. Boom, rise of Earth. Boom, 8 minutes. How did you do that?
How about you?
You don't know the whole model. And they don't even claim they did that.
It must be Icarus. He flew to the sun.
Okay.
You need a priori knowledge of the
How did you do that? They have actual tools to measure these things. But these tools are fake. These scientists are fake. They're lying. No, conspiracy theory A, conspiracy theory B. Yeah, conspiracy.
You know,
every tool that they use to measure things is fake. It's all faked, right?
Well, how about you tell us some of those tools?
Yeah. Like so straw manning is the
best.
If
you could trust that it's not, we might.
Tell us the tools.
Which tool? Which device?
Where can we get these tools?
Okay, so you don't even know the devices that exist on planet Earth? Congratulations.
Okay.
So we don't have satellites. We have no satellites. We have no spectrometers. We have nothing to detect light or to calculate light. We have nothing to do radiometric dating. We have nothing to detect atoms. We have nothing to do quantum mechanics. We don't have a Large Hadron Collider. All of those things are fake. Of course, yes. Keep living in dreamland. Denial of everything.
Why are you just making shit up that nobody actually said?
I didn't make anything up. You're just denying things that are real because these real things violate what you want to be true.
No, everything you just said in the last minute is completely wrong. Nobody said nobody said anything isn't real. Right? We can observe the things in the sky. We can, measure stuff. The issue is that this globe model has a bunch of assumptions and calculations built into it. that you never looked at, that you don't know about, that we have to educate you about. So how about you calm down and, we can actually discuss this. Or if you just want to shout at someone, you might want to just go elsewhere.
So if
we understand you're angry, because you're going to realize soon not what you're thinking is not true. But you got to do it.
That's you. You're
Hey, just by the way, I personally don't care if the Earth would be a globe or flat. If it hey,
then why have you been here?
Okay, look. I'm not even going to entertain you guys anymore. I'm muting myself. I'm not going to speak until I'm allowed to actually speak until I'm done.
You didn't answer it. You're the globe expert.
He just wants to be able to monologue.
Yeah, so you're the globe expert. I want you to tell us, right, why you've been here shilling for something you don't even understand at all, dude. You don't even understand it at all.
Why am I... Look, saying you don't even understand your own thing, that's poisoning the well, all right? You can ask me a question without being insulting.
No, I'm asking you about you.
Okay. Why are you debating flat Earth when you don't know shit about flat Earth? That's the same question, by the way.
I do, though.
You don't, though.
What don't I know?
Okay. So you saying that I don't know my globe model, and then me saying that I do, and then you saying I don't is valid.
I just
but if we reverse the roles and you say that you do know your flat Earth model, and I say that you don't, and you say you do, it doesn't fly though. So tell me this double standard, how it works. Why are you right suddenly when you deny something without substance, but if I deny something with the same argument, it doesn't fly? Explain that.
Because I provided evidence that you don't know the globe model.
You didn't provide any fucking evidence of anything.
How did they get the distance of the sun?
How did they get the distance of the sun?
You don't
By
know,
many fucking ways that you can fucking look up.
But guess what, dude? I know all the claimed globe ways they got the distance of the sun, and you know none.
You know
why are I defending the globe? And why are
you should know that the claims are consistent with reality then.
No, they're not. The distance of the sun has changed like 20 fucking times in the last 100 years. What the fuck are you talking about?
Okay, so they have measurements that are 99.9%
because you know the globe's so good.
They have measurements that are 99.9%.
You're just making up numbers, dude.
No, I'm not making up shit. I'm actually explaining to you how fucking science works because you clearly have no fucking idea of it. So,
I don't think you know how science works.
When they have data on something, suppose they are 99.9% accurate, this little 1.1% of margin of error, which let's say they say the sun is 90 million miles, and then they have more accurate data that says 91 million miles. That doesn't mean that it was all false. They're still correct. They're still more accurate. That's how science progresses. It adjusts its beliefs according to truth. As soon as something is falsified, they drop it.
No, that's not how the distance has changed.
If the globe Earth was falsified, they would drop it, my friend.
The distance has changed by a lot more than that. If you knew the globe model, you would actually know that. But you don't know anything about it, which makes me wonder why you're here shilling for something you don't even fucking know.
I don't know anything about my planet.
No, you don't know. No, you don't know this topic. That's for fucking sure. You might know a lot about masturbating, but you don't know anything about this topic.
Yeah, nice poison the well, buddy. You don't know anything about this topic yourself, so keep projecting.
Okay, ask me a question then.
Okay, how did they get the size of the sun on flat Earth?
Okay, so in 1637...
I'm not talking about globe Earth here. I'm talking flat Earth. For flat Earth, how do you get the size of the sun on a flat Earth?
The size of the sun's not measurable.
The size of the sun is unmeasurable. Oh, look. So on flat Earth, your model...
Why?
Wait. For flat Earth, you can't measure the size of the sun. But when we use spheres and globes and etc. and have a globe model, we can actually determine the size of the sun and its mass. Wow. So right there, you don't know what you're talking about. I know what I'm talking about.
You just believe that. But if I ask you how they did that, you don't know.
That. Oh, yeah.
Right? You were just told the sun is this big.
Oh, yeah. I was
this far away. The sun is this mass.
Yes,
and you're like, I
listen to mass, all right?
Just tell me. Just tell me. But the reality is, just tell me. I don't need to know how
this is actually the most entertaining one.
So there's something called this. How do you measure the distance? How do you know the distance of an object just by looking? Do you know how you figure that out? Do you know the methodology for that?
Okay, I just told you.
You use trigonometry, right?
There are factors that you can use.
They use trigonometry, right?
Trigonometry?
Use trigonometry to figure out the distance of something.
If you would know how to use trigonometry actually correctly, if you would know anything about that, because I'm not really good in trigonometry. That was really one of my
but you do know it exists.
I can admit that. But if you would have any knowledge in trigonometry, you would know that it debunks flat Earth.
Okay, bullshit. Okay, you don't know what you're talking about. That's crazy, man. You said I don't understand trigonometry, but I know it debunks flat Earth.
I didn't say that I don't understand trigonometry. I said I'm not good at it.
What does that mean?
That means that even with a calculator with the cosinus and tangents, I would have to think a long time to get my accurate results using trigonometry. I'm very slow with it.
Okay, so let's get back to the point. If I see something in the distance, I'm just looking at it, right? And I just see something. I don't know how big it is.
Trigonometry.
No, listen, stupid. Listen. Shut your fucking pie hole.
Why would I?
Because I'm going to kick you off the fucking server. That's why. I don't have to. You ran away. This dude is not going to talk about anything of substance. Obviously, if you try to get down into it, he's just going to fucking fail.
Well, I think right now he's in like a really bad case of cogdis because he's triggered, but. I don't know. I'm starting to think maybe there's a little bit of genuine in it because most people don't get angry about it. You know what I mean? Like usually you get angry because it really does matter to you. You know what I mean? So I tend not to think that he's a troll. He's more like he just doesn't know what the arguments are. Maybe if we slowed it down a little bit, let him into it a little better.
He's reacting like his whole identity is under attack.
Right. Well, yeah. And that might be he doesn't listen. We slow it down and he won't listen.
I know, but I'm saying you hear what I'm saying though. Like, I think that maybe somebody could reach him. I just don't know if we could do it.
I think he's just a troll.
I know. I think at the moment he's like past the point of even trying to have a conversation with him because he's not listening.
Yeah,
or responding.
Right. He's upset.
Or like addressing anything you say.
He thinks we're ganging up on. I don't.
Yeah, he's arguing with his own imagination at this point. Like, oh, so you're saying this is fake and that's fake and that's fake and that doesn't exist and this never happened. Oh my god.
He's not listening at all. All he's doing is trying to obfuscate and yell over people. He's a waste of time. That's just my opinion.
Because I bet if we analyze something else that they claim in history is true, like let's say George Washington chopping down a cherry tree, I'm sure we could all come to the right conclusion, right? That obviously George Washington didn't grow cherries. He grew marijuana, right? We all know that. So the fact that they teach our children that George Washington chopped down a cherry tree is kind of stupid, isn't it? But we all know they lie about that, but we still let them teach our kids that, and we don't think anything of it. That's the kind of stuff I'm talking about. Why do we accept that, but we don't accept... I mean, it doesn't make any sense. Why do we accept the ball earth thing when we all know it doesn't make any sense, and then we let them teach our kids this? It just doesn't make sense to me. To me, I'd be more angry if they're teaching my kids lies. If you can't prove something, then why are you teaching it to our children? That's my issue with it.
Columbus Day.
Yeah, right. Columbus, my bum. Aristophanes. Why do all these guys' names have to like end with E's? It's like so dumb. They made this shit up, bro. It's just.
All right. Well, Indio, Homewrecker Phil's here if you want to hit the other side of the spectrum.
What's up, guys?
Homewrecker Phil.
It's the same spectrum.
That was an interesting exchange. That dude was really upset.
Oh, you should have seen yesterday. I wasn't here, but apparently
I saw some of his messages, and you know, it's the same. I don't know. I first time I was in here, I guess I kind of covered this. Is that it's like it's really difficult for like an individual to you know confidently upend a flat Earth position, especially because it's like there's a convergence of sciences. So. You know,
there's a taboo. Yeah,
you need to know your own position to upend somebody else's position because he doesn't even know his own position.
Well, I mean that's right.
He doesn't have a position, but he's under the assumption that everybody else does and that they're right. See, that's the problem. Is that he doesn't realize he's just assuming. Right?
Well, yeah, and there's also like this the very cursory understanding, like okay, like trigonometry. Figuring out the size of the sun. You also way before you even try to figure out the size of the sun, you have to understand a lot more about Earth's orbit, and you also have to have some other data points from astronomical bodies in order to form any kind of astronomical unit in order to measure the sun. Like it's not just a straightforward, oh, you look at the thing and you do a squared plus b squared equals c squared, and then suddenly you have a good idea of the distance to the sun or the size of the sun or anything like that. Like it's and if you asked me to do it today, I wouldn't be able to do
something if you don't even know it's solid, though. I just don't understand.
Wait, say that again.
Like with the sun, obviously the sun does things, and it augments, and there's all these anomalies about light, right? So obviously we're not seeing all of whatever it is that's out there, right? Obviously there's light our eyes can't see, and that's probably what's obfuscating us from understanding what's really going on, right? I mean, that would be the honest explanation from science on what we have above our heads, right? Because we can't really nail anything down until we actually get there, right? Or until we can draw a line from here to there, or take measure, right? But I don't know. I just don't get how you can make something so complicated out of something it's just so dumb. It's like they claim that the stars are going in all directions, but yet we see them going around in a circle every day. I mean, it's like they don't ever change, bro. It's like it's really obvious that if we were on a planet, if we were going in a circle, if we were three-dimensional, a ball, that we would be seeing stars going all directions, right? But we don't see that. That alone tells me that something's not right about what they told us about what is coming from the sky, which means that why would I take any of that? I mean, if we can't really know it and can't understand it, then why would we even assume it or use it as an explanation for something that we have down here that's physical? That's my big argument. It just doesn't make sense.
Yeah, the whole space expanding, everything moving thing is like it's like an extreme oversimplification that you hear people say a lot. Like, I mean, you'll hear, of course, Neil deGrasse Tyson you'd say it on a talk show or whatever. Like if you actually read Hubble's publication on whether celestial bodies or the universe is expanding or not, it's way less conclusive than you hear people say. Like there's like if I recall, guys, I looked at this when I was maybe like 23 or 24, so close to 10 years ago now. And I think this publication was made in the 70s, or maybe even earlier. It was that it was like, hey, I took long-term measurements, angular measurements of all these celestial bodies, and I found that 51% of them were moving away, and 49% of them weren't. So it's like, does that mean that the universe is expanding? That's certainly what you hear it means. I don't know enough to say whether or not that's a good conclusion or not, but it doesn't sound like it, right?
Hey, what happened to the guy that was here? Sorry,
NPC. I think he left.
Right the fuck out of here. He's in Cogdis now.
Oh, you went back to Cog? Okay, I just left for a moment.
Well, I don't know how he ended up back there, but he quit the chat and then spiraled somehow ended up in Cogdis.
Oh yeah. Apologies, I didn't mean to interrupt. I didn't see him in here and saw somebody else talking. So
I was trying to get him to just like have a just a good keep it simple, stupid. That principle. Try to drill it down to something simple that he could like have a normal conversation about. And like when I did that, he quit the chat. So.
Oh, okay. Homewrecker Phil is a new guy.
So Homewrecker, well, hold on. I want to say something about what he just said. Sorry to cut you off. Homewrecker Phil. Look up Halton Arp. He was an astronomer. He was Hubble's PhD student. He wrote something called Atlas of Unusual and Peculiar Galaxies and Quasars. He wrote that back in the 70s. And he showed that things in the sky that are blue shifted and red shifted simultaneously. When he published this book and said Hubble expansion's bullshit, he was no longer allowed to use the telescope at where he was employed at Mount Wilson Observatory. They said, go kick fucking rocks. So it's kind of hard to be an astronomer if you can't use the telescope.
Right. What's this dude's name? I gotta find that because that sounds interesting. Because when I read Hubble's shit, I was like, this doesn't make any sense.
It's HALTONARP. Halton Art. He's dead now, but there's New York Times art. There's even a New York Times article about it. It's probably like if you Google his name, that's usually the first thing that pops up is a New York Times article about his. Yeah, Halton.
Interesting.
Yeah.
Redshift. It's funny. It's interesting because actually, when I the thing that triggered me to actually look into Hubble's data, well, to try to figure out if the universe is expanding or whatever. When I was a youngin, I read Hubble's data and I was like, that doesn't quite fucking add up to me. Not being an astrophysicist.
You know what's even worse? They say that the universe is expanding into itself.
Yeah, I've heard.
It's not expanding. It's not expanding into nothing. It's expanding into itself. So it's expanding into something, not nothing. How about that?
Yeah, it's like pulling yourself up by your own bootstraps.
Wait, so there are two edges of the universe?
Yeah, it's like they're telling you that the universe is expanding into nothing. No, it's not. It's expanding into itself.
Yeah, what you gotta ask is it an innie or outie?
Both.
Yeah, there's like no. As far as I understand, there's not really a concept of an edge of the universe.
Yeah, not the way they describe.
Right. It's not like this is the end of where all. I don't know. This is a wall, or it's some other. And
there's nothing out there. There's just only this, and then there's that, which is nothing. There's only what we have is something, and then out there is nothing. Like they're not saying that.
And
well,
of course,
what I heard.
It has to have an edge, right? It has to have a boundary, right? Because like the speed of light and Big Bang, all that crap, right? Like if the Big Bang happened X amount of time ago, the universe can only expand some amount. So that sphere of Big Bang explosion universe has to have a leading edge somewhere.
Yeah, I think that gets into philosophy of like does the universe encompass everything and nothing? Or is it
a lot of philosophy?
Or is there? Or do we get? And I'm sure that there is a agreed upon philosophical answer for that, but I don't know what it is.
They just kick the can down the road. The same thing we do when we're asked, like, where's the edge, right? We do that is an infinite regression fallacy.
But are you of the mind that
in my opinion, but
are you of the mind that the Earth is an ever expanding universe? Well, in the sense that they're saying that the cosmos.
No, I mean I have my own theory that it is certainly it doesn't line up with the common ever expanding universe theory, but it's not validated. It's gone under no rigor,
You know what's weird though is that how come we have people that can propose ideas of what they think the cosmos are, but there are no collective understanding of what people would say is like, well, we come to a decision. This is what we're all saying together. So it's what every man can think of in his own mind. Your conception would be, we'll run with that until the next better conceivable understanding of the cosmos comes in, and then we'll think about that one. It's like, why do we have to do that if we can't ever? I'm just saying because I don't know what your position is on this whole topic. I don't know. You might think that the Earth is a globe, in the vacuum of space and all that. So, but if that is the case, then it's funny how there is no consensus, because you can make the universe whatever you want it to be, right? It's like it can be whatever. You could be the next guy who proposed the next, information that you'll be on the next TED Talk talking about like how you conceptualize the cosmos. Like your theory may be the newest, hottest thing. Why? Why isn't there something that we can all go by? It's got to always be changing, ever changing. And I guess it's rhetorical because the answer would be because that's how science works, right? That's how everybody says, well, that's how science works. We're standing on the shoulders of giants and we're on top of other giants, and then we just go ahead and build off of their work.
Right.
So, I mean, nobody ever has a beat on what's going on except for whatever you think is right. And so if you say so, well, I guess you say so. Like, who's going to argue with you? Because it's your own, whatever you thought of. So your imagination, you thought of some, cockamamie idea. The other guy thought of another cockamamie idea. And then you guys are just challenging your own. You're just in a fucking, intellectual masturbation contest. You know what I'm saying? Like, who the fuck gives a fuck? Because at the end of the day, none of you are correct. How the fuck are you going to prove the shit that you're saying? Well, that's a great idea, man. Nice pats on the back, nice claps from the audience. But then at the end of the day, nobody fucking gets anywhere. It's just like, I don't know, man.
Why? We hope that there's a march towards truth, but also like the reality is, like you said, like the people develop a theory, they test it against the observations and the math, and if it fits, then it's a valid possibility, but it's not necessarily a great explanation. It's not even necessarily remotely true, because if in the case of something as big as the universe, there's probably 1,500, 1,000, 2,000, a million theories that would fit the math and fit the observations.
Well, so then, I mean,
so what's the point? I don't know, dude.
well, the thing is, there's whole fucking schools of thought built on this, isn't there? And there's people that are fucking getting paid and getting tenure for shit like this. And to me, it's like a fruitless endeavor, because it's like, and yeah, I did say that, because the thing is, people are gonna be like, well, what the fuck? We're gonna just stop thinking altogether? No, that's not what I'm saying. But the fucking thing that we're doing is a exercise in futility. What the fuck are we gonna do after the fact that we've developed some new fucking way of thinking? Oh, I didn't think about, it's not the universe that's moving, it's the fucking fabric of reality that's moving. It's like, what the fuck, dude? Like, and then you're not gonna be able to pit that against anything you can test, because it's all fucking like space and time. Those are constructs, bro. You can't bend that shit. You can't turn that into fucking mold it into some fucking clay man or some shit. Like, it's just, they're concepts. And then at the end of the day, you're just gonna sound like you thought of something brand new because you sound intellectual, but there's nothing you can do to ever test what you said. So it's never. And but to the unassumed, people are just gonna stumble upon this information like, man, these guys are fucking smart. You hear them? That guy said that it takes a parsec to actually travel from this star to that one. And then you're like, it's all fucking razzle dazzle, bro. There's never gonna be somebody that's gonna be like, I'm gonna call this fucker out on his bullshit. How does he fucking know for that star to that star that's a distance? And he's throwing some math here, but nobody's gonna be able to verify it. And so it's to like I said, the unassumed, we're just all listening to this shit and watching it on Discovery Channel, going like, ooh, we're fucking 5 light years away from the nearest habitable planet. So then what? Like, it's frustrating, man, because a lot of people, it's critical thinking has gone by the wayside because of this intellectual masturbation bullshit. Everybody's just coming in here thinking that they're smarter than the next guy because they thought of something a little bit deeper, more fucking lore into the fantasy idea that the Earth is a ever expanding cosmos, bro. It's like, yeah, I'm ranting, but at the same time, it's all to a point, because it's like, it doesn't get us anywhere. It's never gonna fucking point us to like the fact that we understand shit. It's always gonna point us to the fact that we say better stories than the next guy. I got a better one than that. You like to hear mine? Here it goes. Like, fucking shit, dude. That's what's frustrating. It's like nobody. And then I don't know. Maybe it's because the human nature is we love to hear stories. That's probably what it is. We like to sit starry-eyed and listen to some guy tell us about some shit that we can't comprehend. Then we fucking go, dude, that's fucking deep. It's like nobody fucking knows. Like, we're just, how are you gonna test that shit, bro? Like, it's really. I have had a show called the Flat Earth Initiative, and we fucking had articles on there, like fucking stupid articles about space and shit. And these guys had an article about 2 black holes colliding sounds like fucking birds chirping, dude. I'm not kidding you. That's what they said. You could probably type that in. Does 2 black holes colliding sound like birds chirping? You're gonna find the article. And yeah, that's what it sounds like. And then you're just like,
that doesn't make any fucking sense. And also, also, like, who gives a shit?
Well, they do. And it's like, that's the more people you can get to think about dumb shit, dark matter bullets, all this shit, bro. Like, fucking landing on fucking asteroids and extracting minerals from them, and like the fucking Roadrunner and Coyote bullshit, like, like straps a rocket to its back. Dude, I'm telling you, it is so far out and it's so weird that people think that's the norm. And when you bring them back to reality, you're like, dude, none of that All that's bullshit, dude. And you're like, no, man, we got all this fuck. What are you saying? We're not smart enough to think that. Like, no, it's not fucking possible in reality. Are you gonna send a vehicle going at the rate and speed that they say these fucking things are flying around in the cosmos, right? However many thousands of miles are going, and then land a fucking thing on it, and then take off from that fucking thing. And it's like, I mean, you got that what's that movie with Bruce Willis and they land on the asteroid and fucking
Armageddon. Yeah.
There's an actual fucking program that's what is it? NASA has that they're extracting minerals from fucking asteroids, just like sounds like that fucking movie plot.
Yeah,
Same
one landed the other day, allegedly. A fucking a returned pod full of asteroid debris.
Yeah, and allegedly these asteroids have so much minerals that could make anybody like a super, like there's the rarest minerals on there. People can send
the entire world will be trillionaires.
Yeah, we'd all be rich and fuck, dude.
Yeah, we can be sure that even if all that is true, the entire world will not be trillionaires.
Well, not there's always
there will be quadrillionaires, and there will be very few of them. Sample material from asteroid Bennu.
Yep.
The OSIRIS-REx sample collector. Yeah.
Yeah, we're not making this shit up, man. These articles exist. They're out there. They're fucking. Oh, you really don't know the globe Earth lore until you fucking just go, you know what? Let me take some time out to go research how much fucking bullshit there is out there with these space articles. There's one that the Kaplan thruster that can tow the fucking sun. I am not kidding you. With these thrusters, they're able to attach like a tugboat to the fucking sun and tug it out of its fucking, because it's in a specific orbital trajectory in the galaxy, and they're gonna move it because in case there's an impending cosmic doomsday asteroid headed towards Earth, they can move the sun and it can tug the solar system out of that asteroid's path, the global killer or whatever, using the Kaplan thruster. And dude, it's so out there. and somebody fucking type that Kaplan thruster, type it in there.
This sounds like, oh my god, there's a golf ball coming from my house. I better pick
and type in as soon as you type in Kaplan thruster, look at images. Just look at it. Just fucking look at it, bro. And then you're just like, how? This not even. Who believes this shit? Like, how is this even getting past? How is it even getting printed? Like, how are people even putting it? Fuck, dude. Like, it's just
along the lines of what you were saying before. Like, these are all these are things that people make up, like the Dyson ball and stellar engines and space elevators. Like, these are things that people say. I guess they propose them as pie in the sky possible things. I think somebody, maybe I can't remember who it was. Somebody did a calculation to figure out how much of the Earth's resources would be consumed in making a Dyson sphere, and it was like the Earth doesn't have enough matter to do it.
There's not enough.
So you'd have to mine other planets and asteroids in order to do it, and then also, if you did do it, you would block the sun out. But in theory, you'd then figure out a way to transmit that energy back to somewhere useful or whatever. But it's like, who gives a shit? That shit's not going to happen. It's just like, in case, like somebody said, if a golf ball is going towards my house, I'm going to attach a big rocket to the Earth to move the Earth underneath the flight of the golf ball.
Yep.
It's like, it's a little silly. Maybe it would work in a sci-fi novel.
Well, since we're talking about golf balls,
it works in American football.
Par for the course, man.
Can't even cook a field goal, man, unless the Earth rotates the freaking goalpost.
Yeah, that's a good point. It's actually probably the first way that a device like that would be used would be to get some sports bookie to always have the odds in their favor. get their
You sound like the fucking Hunger
move
Games,
the Earth,
bro.
right?
May
Move
the
the
odds be
fucking
ever in your favor. Fucking. I don't.
every ball of foul ball, every field goal hits when they want it to hit because they're moving the Earth underneath it.
Dude, we've been doing this for a while, man. So we've heard of the stories. We know the fucking information that comes out there that these guys are consuming. Okay, so let me ask you. Like, I don't know what position do you stand at, Homewrecker? Do you think the Earth's a globe still?
I'm a glober. I'm a glober, 100%. Yeah.
Well, think about it like this, man, because like we've heard a bunch of shit that comes. I'm gonna ask you a question. Well, it's a multiple choice. So multiple choice of like, do you think that the Earth is staying the same rate, spinning faster, or spinning slower? Right now.
So your question is the rate of rotation constant, or is it changing? And then if it's changing, is it accelerating or decelerating?
Accelerating or decelerating? Yeah.
Man, that's a tough thing. So I do think it's spinning.
Yeah. But is it staying the same rate?
I think so. Yeah. I mean, I think.
Well, let's say you were a betting man. Well, how much percentage would you bank on that it was staying the same, faster or slower?
Man, well, that's the thing, is that I don't know if I would take that bet, because there has to be variance, right? Because if I think that the Earth's mass is changing, that is going to change the rate at which it's spinning. And I do think the Earth's mass is changing. But so so I don't know if that means it would go up or down, if but I can tell you if the mass is changing, it's probably variable.
But what I'm saying though is, like nobody, like I've asked, people that think that the Earth is a globe and it's spinning, that's what it's doing, and they can't answer the question, or they'll give me an answer like yours because they don't know, right?
Yeah.
But they'll basically say, well, it sounds like to me like it would just be constant. Like there's no friction. It's like there's nothing that it's actually slowing it down or whatever to make it. But the thing is, there is an answer. There is an answer. So one of them is what the mainstream consensus would say that it is, and it's going faster. That's the answer. Bing, bing, bing. It's spinning faster. Within the last 50 years, the Earth is actually speeding up. Maybe not significantly, but it is.
Right.
It is speeding up. That's what they claim. So, if it is speeding up, then why doesn't anyone or everyone, like, why isn't there some public information? Why does it seem like it's very difficult for people to actually come to understandings about things like this, right? And okay, and the same goes for information you may or may not know. Is the moon inside or outside of the Earth's atmosphere?
That's the next question.
Yeah, next question.
I think outside.
Okay.
Well, okay. So I think that certainly there are atoms and molecules that came from the Earth's atmosphere that are.
Yeah, but that's
that
not,
are near. But in terms of like the cohesive atmosphere, no. I think it's outside.
So do you know that within the last 20 years, 20 years, was it 98? I think they discovered that the moon is actually within the Earth's atmosphere.
Within it, like as in lower than.
Not in that way, but it's within the Earth's atmosphere. Let's see. The image is portrayed, I guess, so that you can look as an orthographic view of what it would be looked like. And nobody, mind you, can actually have this view because that doesn't exist. But let me see if can somebody pull that up and put it in the live stream, voice text. If not, I'll just find it real quick. Let me see.
Bro, there's so many damn clips and papers that
this one.
I've tried to file them and figure them out, but I don't know if I can ever even go through them all.
Hey, just give me a moment. I'm gonna put it in the.
I thought we had like a thing that you could just type in the thing and it would pop out for you.
Yeah, but I like here. Check this out, Homewrecker.
Oh, that's an image.
Sorry, I mean this.
Yeah, orthographic.
Oh, Earth's atmosphere extends far beyond the moon. Okay, yeah, let me. Yeah, so that's.
Now
yeah,
let's
fair
hear.
enough.
Now, when I do this to people that think the Earth's a globe, I hear all the excuses of how they already knew that. Oh fuck, dude, come on! I knew that shit. Yeah, duh. No, duh, duh. Like, yeah, I'm like, dude, you didn't fucking know that. There's no way, Homewrecker Phil, that you knew this information at all. You did not know that, and we're in 2023, bro. You didn't know this shit. But see, this is important. I think I'm exposing people's mindsets to that are listening on Rumble and YouTube. Now, Homewrecker Phil is an example of a guy who's being honest. He doesn't really like. He's like, yeah, fine. I think that's not even attached. When I showed him this, I bet you anything, where we might hear someone that's going to be like, no, yeah, that's just, yeah, I meant that. Exactly what that. Yeah, I meant that. No, you didn't. You were as kind of like caught off guard by this as everyone else is, because this information in these circles, this information in these circles aren't talked about like this. We don't. When we approach other people who think the Earth is a globe,
it's never allowed, is it? Like, I've asked these questions in classes and in ask teachers and things, and they won't answer the question. They get all angry about it.
Yeah, that because they don't know. But like, at the same time, there's a curriculum that's already set forward. So if you sound like you're going against that curriculum, then you're just you're talking shite. I mean, better not.
Yeah, I understand that, but a normal person would be able to admit, yeah, I understand that some of the stuff that we teach kids is not necessarily, true, but there's a purpose to it, and they believe in the purpose, right? But if they're not even willing to admit that, then you have a problem, because they're in complete denial about reality, right? But then they're still thinking that they have a position to stand on. Well, if you're not accepting reality, then you really don't have nowhere to stand. That's the problem, right? Isn't that what we're?
Yeah, it's here. Let me post it. I'm gonna post a link so that everybody can know. And I'm not just I'm doing this because you guys, most of the guys who think that the Earth is a globe, they're really caught off guard by a lot of the things that are being said here, because it's too. It almost sounds like Flat Earth is making this shit up. Like we're the ones bringing it up. Why are you bringing this up, man?
When you asked me that question initially, and I said, well, it's complicated because there are parts of Earth's atmosphere that impact it, right? If you recall that.
I know, dude. Don't go ahead, Homewrecker. I'm used to it.
I think that a lot of people have a concept of the. I think on both sides have a concept of the term of the vacuum of space, and they think that that's a meaningful, concrete thing. That there is no pressure, and that space is an absence of matter, but it's not.
You mean this in this arena? In this arena, no.
Well, I think broadly, because when people talk about
maybe broadly, I would say the majority of people might think that it's an absence of anything.
Right. Well, people refer to the vacuum of space as a real vacuum. And I know that.
Or you mean like an absolute vacuum?
Yeah. Of course. Of course, it's not. Yeah. So I mean, this is interesting. I mean, I know that we are back when I said that we're losing. The Earth is losing mass, so that would probably suggest, especially depending on how and where we're losing mass and how the mass distribution of the planet is changing, that's probably going to cause a variable rate of spin on the Earth. But yeah, so I didn't know this in particular, and they're saying that it's basically hydrogen. That more or less makes sense. It's super light. But yeah, I mean, I think that if you said this to somebody, they'd be like, no, the moon is, the surface of the moon and everything around it is in a perfect vacuum. I think that's colloquially what people believe, but that's demonstrably not true. And so this is, I guess, more, this is a more measured explanation of that, but I'm not quite sure why or how they got those measurements. I'll have to actually read their paper, but I'm not horribly surprised by that, but I have no idea how they got the measurements.
But you think that the globe lore, you don't know the globe lore until you've actually talked to a flat earther, because we can tell you the globe lore. There is much more on the globe lore than you actually think that there is. So at this current time, there's a lot of what you think about the Earth being a globe that you think exists in the paradigm that you've been taught or told. So currently, you have this mindset. It's very topical. It doesn't go farther than just topical subjects from the we've actually kind of dove a little bit into these topics and found out there's more than what you think meets the eye with these conversations. So I think I have a pretty straight handle on like the Earth being what it is. But until you've actually talked to somebody, okay, so let's now give you another example. Gravity, right? What type of gravity do you think is adhering to the physics that the Earth uses right now in your paradigm?
I don't really understand your question.
So when I say gravity, what do you get from that? What do you think I'm saying?
I think in terms of like me sitting here on Earth and observing something, it's a state of constant acceleration towards, from my observational plane, the ground, right?
All right, so you got your cause and your effect, right? What is we can break it down. What's the effect of gravity?
The effect of gravity, like, is a constant acceleration towards again, from my frame of reference, towards the ground. In terms of cosmological,
I'm not really gonna challenge you too much, because I just want you to tell me what you think on these. So that's what you say the effect is, right?
Yeah.
Okay, so what is the cause?
I have no idea, no clue.
On the Earth being a globe, I'm not.
Oh, what is wait, I'm sorry.
What's causing the effect
of gravity or of Earth being a globe?
No.
I have no idea. I have no clue. I don't think anybody.
I thought you think that the Earth is a globe. You said 100%.
Yeah.
Okay, so there's no causal mechanism for the Earth's gravity.
Well, I didn't say that there isn't one. I just said I don't know.
Well, I'm asking. That's what I'm asking. What's the causal mechanism?
Gradual index profile, so the light curves smoothly inside. So refraction in the atmo is exactly this. The atmo does not present a sharp boundary, instead a vertical gradient of density and temperature. Hence refractive index. Light bends continuously through that gradient. Why the Snell's law only objection fails? It confuses the idealized sharp boundary case with the general principle. Snell's law is derived from Fermat's principle. Light takes the path of least time. That principle also predicts continuous bending in a gradient medium. So atmospheric refraction isn't breaking Snell's law, it's governed by the same root physics, just applied to a continuous gradient instead of a single interface. Analogy. Think of a car driving from pavement into sand at an angle. That's Snell's law, a sudden boundary. Now imagine the sand getting gradually softer as the car drives. The car doesn't suddenly change in angle, it curves smoothly. Same physics, just distributed.
mechanism for it.
I have no idea.
Well, you said I didn't say there wasn't one. Well, okay. Well, what do you say?
Well, it's okay for me to not know, right? I mean,
well, I don't care if you know or not. But either there is or there is not a causal mechanism. So if you say that there
is, right?
Well, if there is, then what is it? If there isn't, if there is not a causal mechanism, then you can say, well, there isn't because it would have been proven.
Well, you can. Well, if gravity in fact pulls things towards its center of mass, then it would make sense that
that's the answer we were looking for.
Fair enough.
Where does your mind depict gravity?
Well, no, that's not. That's where because remember, I separated the cause and effect. I'm telling you what the effect is, and then we went into the cause. So, and the reason why I use this is because I want to exemplify what I'm talking to you about. How people from the Globe Earth side, they don't understand what they're saying, or they don't dive into these topics a lot like we do. So,
okay.
So, and then when I'm asking this, I'm actually getting your honest answer from like what you think the effect and the cause is. So I'm not even trying to challenge you on it, or not, at least not yet. But I just want you to tell me what you think the effect is. You already told me. Now the cause, you said you don't know. But do you think that there is an answer for the cause on the Globe Earth paradigm?
Well, I think well, or for what causes gravity?
Yeah, the cause of the effect.
I don't know if there is a good answer. In the broadly,
there's an answer. It's just not, like.
I wouldn't say it's complete, and I would be surprised if anybody would say that we fully understand the cause of gravity. You hear that. Massive objects have the more mass, the more gravity, or whatever. But
do you believe that's true?
But well, I think it looks like it. I'd probably say I could say I believe that. Yeah, I don't know of any. I don't know of any massive objects that. I don't know of any massive. Well, that's the thing is that I haven't sat down and done the math. I don't know of any massive objects that don't appear to have any gravity.
Well, can you do the math for the, like, as you would put it, the constant rate of drop?
Oh yeah, for sure. Yeah, so I can demonstrate, with stuff in my kitchen that there's a constant 9.8 meters, roughly 9.8 meters per second.
Okay, so then you would say that there is you can quantify that.
Yeah, I mean, if you said, "Hey, prove a constant downward acceleration," yeah, I could do that for sure. I mean, I feel like anybody could do that.
So you're saying that in the Globe Earth paradigm, no one can ascribe the causal mechanism
to what?
To what causes the effect?
Oh, I don't think so. No.
Interesting. I don't know. I guess the reason I'm asking this is because I don't know where you stand with all these topics, but it sounds like you are not really standing with any of the Globe Earthers that I've spoken with.
No, that's probably true, man. I that's the thing is that if you said, "Hey, prove this to me beyond a shadow of a doubt," I'd have a really tough time doing that.
Well, and that's odd too, because it's like, why would somebody that would still question these things and not have, when you're not solidified and you. Okay, so for somebody to be bought into the Globe Earth being what it is, they have to have a reason why. It sounds like you don't. You just basically like.
No, I mean, I have reasons why, but they don't revolve around trying to understand these things that I don't have any really good literature that explains it.
Why would you then be adhering to something that you have no reason to believe in? Like, I can see why some Globers believe it, because it's to them it's a blind belief. They just trust the information.
Right.
They can regurgitate the information, and they can say, I just trust it because that guy said so, and I trust that organization, so there you have it. That's why I believe it.
Yeah.
But you're like, well, fuck, I don't even know. Like,
if I wasn't, I mean, I have a telescope. I look at stuff. It looks like there are balls in the sky. I think it'd be pretty weird if we were the only non-ball.
Well, I know, but have you critically thought about the information? Because here's the thing. Let's you don't sound like you're a guy who really does this. So, and I'm not saying that as a slight to you. I'm saying it because if you thought about it at least twice, you would think, well, wait a minute. Why do I think they are spheres? Because when you look through a telescope, you're looking with only one eye.
Yeah.
Okay, so not only cannot tell depth, but there's no way that you can be able to tell me shape. So if you say they look like spheres, then I need to know the dimensions of how a 3D object is perceived by a person using one eye.
Yeah, absolutely. No, I totally agree with you. I think that if you looked at a soccer ball through a telescope that was 100 yards away, and you looked at a picture of a soccer ball that was 100 yards away, you'd be able to tell, which one is round or not. Just based. Yeah, I think so.
Well, we have
I've never tried it.
We have such an image that can get put to you on live stream voice text, and you wouldn't be able to tell me which one the circle is or the sphere. And
may I please? You're contradicting the idea, right? That when you look at the horizon that looks flat, okay, it's not flat, right? You're contradicting that. You're saying that something like looks round is round. You're saying that something that looks flat is flat. I just wanted to throw that in. It's kind of logical.
No, that's fair. Yeah, I see what you're saying.
Yeah, but going back to this, like, because you have a telescope and you say, look at all the spheres. Well, we must be a sphere. But the thing is, you haven't addressed the fact that you don't know if they're spheres or not. You're assuming they are because there's a story attached to. So when you see the things in the sky, aren't you influenced by this paradigm, right? In context to what you think those things are.
Oh, so, I mean, if nobody ever told me, hey, the moon is round, and I had never grown up around people saying that the moon is a ball in the sky, it's possible I'd have a harder time being able to say definitively that's definitely a ball.
And I
think that's what you're saying.
And not to say that you wouldn't say that because it looks, like it's a circle, but to give it depth. And to say that it is this particular, it could be half of something, right? Doesn't have to be a whole sphere. It could be half of something that you see, or whatever. Like because you only see the face of the moon. Yeah. So like the issue that I think I'm having here is that people are making these assumptions and logical leaps without having their critical thinking engaged, which at least to the effect that you have the ability to say, wait, I could entertain something just as a thought. I'm not saying I'm going to believe it, but you could be in here to like listen to what we have to say. And what I'm saying too is the thing that you're doing is it's a bit of conflation when you say, I look at those planets in the sky and I can't think of the Earth being not a planet, because that word has been given to you with a story and a backstory.
You said ball, I didn't say planet, but fair. But I know, point but taken.
Like, because of the fact that even though you do say that, that's not what the mainstream advocates are going to be like, yeah, but you really mean planet, so it doesn't matter. Like at the end of the day, there's a story attached to the things that we look at in the sky. And so that's going to always be influencing us to think, well, I think that it could be this. I mean, some guy said it. So, just to think about it, because we can't ever go there. But, and then at that point, we don't ever go back to the source of the information. How the fuck did they find it out? Like, did they figure something out that I didn't, to come up with the fact that they're looking at Mars as the red planet? It's got like a rocky surface terrain and it's polar ice caps and fucking nickel iron core, all this shit. How the fuck do they know that they're feeding me that I just I can automatically believe it because someone said so? Oh fuck, it must be true, right? Because they're scientists, they got a better telescope than I do and whatever, yada yada.
Yeah, and if you ask me if the Earth had a nickel iron core, I'd probably just tell you I have no fucking clue, and I wouldn't even be able to give you a start on how to figure it out.
I know, but
give me millions of dollars, I still probably couldn't figure it out.
No, you come up with a better fucking story for you. Look, man,
publish it, get tenured, be rich.
I'm serious, dude. Like, here's the thing, though, like, because it's all having to do with because people. And this is the way it sounds to me. People are getting paid to tell stories. The better the story, the more money you get offered.
That's definitely true.
So you could sound intelligent, but all you're doing is you're coming up with the new DLC, right? Fucking for the next generation game that you're just making it more like, okay, so you said that we had this many planets in our solar system. Guess what? We just discovered 5 new ones. And then people are aghast by it because they're like, dude, how the fuck did you find that out? We're like, well, we got this new telescope, see? And it can see the invisible spectral lines or whatever that you thought weren't there, but they were fucking invisible. And so shit like that can come up, and then you are hailed and praised as the next fucking Nobel Prize. It's just shit like that, bro. And so people are getting accolades for absolutely nothing because it's like, well, this guy, he came out with a new theory.
And jobs and security. Yeah, totally.
The thing that I'm saying here, though, is that all of that is wrapped up in what the next generation of people. So let's say 2 generations away from us are going to be on a social media type platform talking about this, right? The next Homewrecker Phil and the next Alpha Veritas are going to be talking about this. And maybe the next Homewrecker Phil is going to be like, well, we have the new 5 planets that we've always known about 30 years. And like, you know what I'm saying? The guy that just came up with the information is going to propagate it. So it's going to be like more bullshit on top of bullshit. So when are we ever going to find out what the truth is if you're just believing shit? There's never going to be that. There's only going to be you believing. So right now, you're kind of like, I think, in a privileged position to say, just wait a damn fucking minute. Why do I have to believe that all the shit that I've been pushed upon to believe is what they're telling me to? I can absolutely say, how do they know? And then they have to, the burden of proof is on their shoulders to explain to me how they know. And don't just say, well, they've explained it to me. They said because of values and maths that we can put in there that we can figure it out with math, and therefore that's okay. No, you're gonna be like, no, I have to know how they know. Like, there needs to be some rubber meets the road content. I need to know what the fuck did they do to discover what element that's on that fucking thing I see. Like, and it's got to make sense too, right? So it's got to be practical. It's got to be something I can verify, falsify. And if it isn't, it's at fucking arm's length to me. Fuck. Like, I can't do nothing about it except for believe it. And so that's what I'm saying, Homewrecker. It's like, this is the part where you guys and the Globert side, it seems like the only thing you can do is rely on the information and or say, I don't know. But for us, it's like we're intellectually honest when we say we don't fucking know. But at the same time, when we say we know something, we actually do know because it's empirical. We can test, verify, falsify the shit that we're saying. And that's what differs from when you say, well, I know something. You stare at something and stuff looks like balls or planets or whatever, but you can never know. There's no way to test, verify.
Right.
That stuff is...
Yeah, I think one of the big things, I agree with you. For me if I read a paper about figuring out that a planet really far away has water on it, even though we can't visibly see an ocean or something along those lines, like if I read the paper and they talk about, spectral lines and all that other stuff, like I sort of understand how that stuff works and it kind of makes sense to me, but also, like you said, there's no possible. I'm not going to build a radio telescope or an X-ray fluorescence telescope or anything along those lines in my backyard to go test their science. And the only way to go test their science would be to get in their cliques, get in their groups, get access to the same equipment that they used, and do all that. So,
not only that, sucks. To agree with them though, you have to agree with those guys because like you said, cliques are cliques, dude. You're either in or out.
Right.
So you play in the sandbox by their fucking rules and their parameters, or you get the fuck out. Like that's just is the way that goes. It's these circles. They're not like for those guys who are like, hey man, let's critically think about all this bullshit, dude. You're invited into a club, and that fucking club is like, dude, you're either gonna fucking do it. They're thugs, dude. Get along with what, and they might be fucking nerd thugs, but they're still thugs, bro. Because they're like, you're gonna play by our rules. You're gonna do the curriculums that we say and speak like what we want you to say, and that's just about all there is to it. Or you're gonna get discontinued, and you'll find yourself in a worse position you were when you first started. Like, because you don't just enter these clubs and be like, let me just critically think about all this. No, fucking, you get with the program. You speak like them. You say the things that they do, and you don't divert. And people know this, bro. Like, this is like the way all this shit works.
Mm-hmm.
I mean, you don't hear a fucking one of these guys going out there and going like, you know what? On second thought, all of this shit doesn't make any sense. I think that we could live in a flat and stationary enclosed system. Bullshit, dude. You're never going to hear that. Those guys will never allow that. There's no critical thinking going on there. There's groupthink. There's fucking, fucking better listen to what we say or you fucking get booted out. So this is the kind of shit that the information that we're getting from the mainstream consensus, it's coming from these groups, bro. That's what it's all it is. And you're the byproduct. You're the guy who's listening to their Discovery channels, their fucking, their books that they have published by their, their bought and paid for publishers. Like all that shit is via that. You're not getting this fucking unbiased information that people are looking up into the night sky and just trying to figure things out. Nah, fuck that. You're getting a story by proxy of their fucking writers. Mm-hmm. And then you're just taking it on as a worldview because why? Because the mainstream said so, right? And these fucking guys with the high dollar telescopes are looking through them and, well, I don't have their technology because they got, that's how they hold you fucking, they're lording this shit over you because you're all you're going to do is believe now. And good for you. You know, you're just a part of the fucking another cog in the wheel, fucking believing their shit. So that's the thing though. But what I'm saying though, is that you don't have to, bro. You can just say, no, fuck all this until they provide some evidence that this shit is real. Then how the fuck am I just going to go along with this shit? Like, there's nothing. I think to me, that's more real than anything else. Like when you stop and say, it's some bullshit. How do they know? And if they're just telling you, well, spectral lines, because we've done a lab test and the fucking lab test proves conclusive that this is what element is, like, you don't ask no questions. Like, how the fuck are you going to do that lab controlled test over fucking the amount of distance that we're talking about? Because we're talking about our atmosphere, then the vacuum of space is lower. You're talking about going out farther and then millions of more miles and then all the way to that fucking light source and then to that atmosphere of that fucking light source. And like, dude, there's
you'd
so
have
many
to correct for
variables.
A lot of stuff. You'd have to correct for everything. Yeah.
It's way too much. It's like so much. And then whatever's in between, bro. So it's like, this is a fantasy to say that they can fucking dial in on what this. No, fuck that, dude.
I think like definitely to your point, like even if the average person cared, which they don't, they wouldn't have a way to prove it. And then the reason why they don't care is because they have fucking terrestrial problems to deal with. You know, they have gas to put in their car, and they have fucking a family to feed and all that other shit. And it's like if somebody says there's water on another planet, it's probably intellectually and emotionally easier to just say, okay, cool fact.
But that's what we've been saying in this channel, Homewrecker. Right. That's exactly what 24/7 Flat Earth Discord is here. Yeah. Because we're getting people to realize that is the fucking malfunction. The reason why people are in automatic belief is because of the fact that they ain't got no fucking time for this shit. Who the fuck's gonna sit there and try to debate on a topic such as this? Fucking no one, except for people that are like curious about it. And so what we're doing is we're getting out there to the majority of the people. We're putting it out to them like shock and awe. So when they hear us on the YouTube or Rumble, whatever, they're like, oh, this is fucking provocative. What the fuck is this dude talking about? Yeah, we're talking about how you've been fucking meleeed with this fucking information and you're just taking it on the chin like a champ. You're just like, fuck it. That's what they say. Who gives a fuck? I put on one pants leg at a time in the morning. I go to work tomorrow. Like, who gives a fuck? Yeah. But you're saying that meanwhile, back at the fucking ranch, they're taking advantage of your dumbass because you're just on automatic belief. Fuck, I ain't got no time for that shit. Well, good for you. You're part of the fucking problem. You're the reason why they've gotten away with it so far. Until you come to grips with the shit and you're like, whoa, wait. They're saying that the earth is this and that and we're over here and there. How the fuck do they know all this shit? And until you do that, you're a fucking peon. You're a pissant. You're nothing to them because you're part of their solution to getting more people believing this bullshit. Because all they're going to do is really just, fucking put another hit piece on fucking Discovery Channel and tell you that the nearest fucking life planet that's got life on it and shit habitable is 5 light years away, and you're going to be razzled and dazzled because you ain't got no fucking time to look into it. It's just about the size of it, isn't it? I mean, it's true, right? You're just going to get taken for a ride because you're allowing them to. So until that makes fucking sense to you and sinks in your brain, you're just going to believe every fucking thing they say because it's convenient. And you're complacent as fuck. That's what it is. You're complacent. You'd rather just sit back and fuck, dude. This is too much. I don't got time fucking arguing about this bullshit. I'll fucking just go back to listening to what they gotta say because it's easier. Anyways, I just gotta make some money, right? Gotta make a little bank, and take care of the kids, feed the dog. Fucking bullshit. I don't know. That's what it seems like, Homewrecker. Like that's all people are concerned about these days. They don't give a fuck about some critical thinking.
No, I agree. Yeah. Well, yeah. I mean, to your point, like if it is all a big grift, it's a pretty good one because nobody's out there with the time, equipment, money, and drive to go try to pick it apart and actually challenge it.
Yeah, but it starts with you, man. It starts with me. It starts with the people listening. Look, man, it's all about, like, we're not here to convince fucking people. Look, dude, the earth is flat, man. You're not listening to me. No, it's like this. You're not fucking thinking, period. You don't give a fuck about things, because if you would, you wouldn't be thinking that the earth is a globe. You'd be like, oh, no, fuck, who's measured the curvature? How the fuck do they know? You would be asking those types of things. Instead, you're like, yeah, it's a globe. And you're like, how the fuck, dude? How did they get away with making you believe that? I need to know how that. Tell me the thinking process behind you saying that the earth is a globe. Well, I don't fucking know, but it's a globe. Oh, that's curious. You don't know how you know that the earth is a globe, but you do know that it's a globe. You don't think that's fucking curious? Like how you just automatically know shit without even being able to stand up for how you know it?
Well, I mean, I can certainly stand up for how I I could walk you through the same process, I
don't think you could.
You might not like it or whatever.
No, you could go ahead and say. You could go ahead and say it because I think what's therapeutic is for people listening because they to listen to someone that is so entrenched in a topic such as this without having any understanding of how they know that it is the most psychologically curious position because like people are like, dude, how the fuck does he think that the earth is a globe if there's no evidence? There isn't any. The only thing they show him is smoke and mirrors. It's easy, right? Put some pictures, give you some guys with some really smooth monotone voices. The earth is a globe because we've known for thousands of years. Like, dude, that kind of shit mesmerizes, right? Because beyond all that shit, how the fuck do you know? Like, so I'm curious now, Homewrecker. How do you know the earth's a globe?
I have this isn't me trying to deflect. I actually do have a question, a flat Earth question, genuine question. I actually have been wanting to ask this whole conversation because I heard you mention that we're the stationariness of the flat Earth. I'm curious, why does the flat Earth have to be stationary? Why can't it be moving?
It's a default position. So the default position or the base axiom of any position would be what do the five senses verify our naturally observed an observation of the world that we live in. So when you go out into the world, right? Let's just do it this way, right? You and I and everybody else can stand outside their house right now, visibly detect, or can you measure or anything, right? With any way that you're moving. Like you would be in a car.
Me personally, like if I stood out in the street.
Yeah, like you would be in a car. Like when you get in a car, you're moving. So can you tell that just by being on the earth?
I don't see space zooming by or anything like that.
Yeah, right? But you get what I'm saying, right? How can you tell that by your senses? It's not perceivable. Would you agree with me on that?
So I can show you that there's movement. And I'm going to shoot a video.
Can you agree with me on that? That's not perceivable in that way with your senses.
No, yeah, of course.
Okay.
Yeah.
So now, how do you conceive that we're? Because you asked the question, I gave you the answer. It's a base axiom. We start there. So if there's anything to say that we are moving, then we need to understand how it is that we are moving. So now the ball's in your court. It's for you to now say, how
Yeah,
we're
totally. So I can prove that there's movement for sure. There's I can show that there's definitive movement, and that's why, and that's kind of like what my question was, is that,
Go
like,
ahead.
okay, if there's a flat Earth, why can't it be moving?
Well, go ahead. How are you going to prove that?
Yeah, of course. I'm going to shoot a video on this. I mentioned this a couple days in live stream text, and just for backstory.
No. Prove it's a globe. If you can prove it's a globe, you can prove it's not flat. The challenge is prove the globe. So that all part and parcel comes with, all the claims. Size, its dimensions, position in the universe, its rotation, its orbit, all of that. All that hinges on the radius value, 3,959 miles or 6,370 kilometers. Metric you like. So it's the crux. It's the foundation of the entire narrative. So if you can prove that radius, well, Shatur, have you ever seen that with your... Have you actually, be honest, have you ever seen a boat be obstructed from view beyond the horizon with your own eyes? Or have you only ever seen pictures of it? Everything is globe. Bananas? Are bananas globes? What about skin cells? Are they globes?
What about sharks? Are they also globes? Blades of grass, definitely globes.
Absolutely. It just takes a phone call to prove the globe. You can verify the globe with a phone call.
Yeah, so Shituo, the light can't push indefinitely through the air, right? So, why is it pitch black just 200 meters into the ocean? Because the sun can't push forever through a medium, right? Just 200 meters into the ocean, it's pitch black. Can't see the sun. Even if it's midday and the sun's right above you, if you were 200 meters deep, you cannot see it. Think about that. Same thing happens with the air, just on a larger scale. And the sun's not 93 million miles away.
So there was 3 people did a live YouTube stream, and one was in the United States, one was in Australia, and one was in Europe, and they all confirmed that they could see the sun at the same time. So I'm going to give you as a clue. Right? So what you're going to need to confirm that the Earth's surface is curving is direct measurement of the surface, not inference from by looking at other things. Not saying this other thing is the result of the Earth's surface being curved, because the only way that you could possibly know that is to have directly measured the Earth's surface itself to begin with. If you somehow think that you can put it into a logical syllogism where the Earth's curvature would be the necessary antecedent of something else, right, that's great and all, but you're going to have to demonstrate how you eliminated all other possibilities. Demonstration is key.
So if we can prove the globe, we get nitro.
That's right. That is correct. You get nitro.
All right. Well, so the first thing you have to do is you have to imagine that you're in the vacuum of space and that gravity after the Big Bang formed the Earth ball. The end.
Okay, so we just have to use our imagination. We just have to imagine. We have to use our imaginations.
Yeah. That's how you prove it. You have to imagine.
Oh, okay. Thanks, man. Thanks for walking me through that. That's enlightening.
Yeah. So can I get nitro?
I think you have to imagine that you have a nitro now.
No, that doesn't work.
No, we meant in Pyrrhus.
Hey, Sheepdog, you do get a participation trophy though. I will post it for you in the side chat right now.
Did you like that? I had to come in and do that when I saw the event. I was like, let me go mess with these guys, see if they recognize my voice.
I didn't at first. I was like, this guy sounds kind of arrogant. And I checked who it was.
I am so glad that you said that I sound arrogant. I love it when people say I sound arrogant. It just makes me more arrogant. No, I don't call it arrogance. Like, arrogance and cockiness are usually a product of not having an experience. But if you've had experiences over and over and over again, then it really comes down to being confident, right? Like, because they do kind of sound the same. It's just when you test it, one of them knows what they're talking about, and the other one doesn't. And so,
yeah, exactly, bro. I don't think you sound arrogant, by the way. It's just joking.
No, I know. I just sounded initially. It sounded arrogant, right?
Yeah. It's because of the words you said as well. That was good.
Oh,
you got John. I think you got John.
I coined a phrase, right? And I don't know if anybody's ever coined it after me or whatnot. And I'm sure somebody's probably going to make money off of it. But know that Sheepdog started it first, and it didn't start just now. I've been saying it for over a decade now. So it's not arrogance, it's confidence maximized. So when you are 100% confident in everything that you do, and regardless of the punishment or the consequences or the repercussions that might come with it, you remain exuberant in your how you go about it. It's just confidence maximized, and you should be okay with that. There's nothing wrong with that.
All right, so we have a submission in the side chat, right? They want to claim the nitro, and they've posted their globe proof. We have the live video from the International Space Station. Okay, so now, Hannah C., all you have to do is just validate the video.
Yeah, we're going to need some authentication.
Yeah, you could do that in multiple ways. I mean, you could validate the actual footage itself. I mean, or you could you could let us know how you validated the height of the ISS, what lens are they using. You could show us, even if you show us that there's Earth curvature that matches what we're seeing in the video, that would do it as well. So
it's a verified NASA account.
oh, it must be true if it's a verified NASA account.
So I will say this: it is an old stream. It's not a current stream.
No, it says it's live. It has to be live. If it says it's live, it means it has to be live, Sheepdog.
It says right below it, watching now, started streaming on May 12th, 2025.
Yeah, that's when it started, and it's still going. It's live. Why would they lie?
I really want to get that guy Mongoose in here. Did he come in here yet?
Which one?
Mongoose, he's over there in 24/7 right now. I tried to VC verify him, but he was saying stupid things like because we don't think the Earth is a ball, that kilometers aren't real. That's what he said. That's literally what he said.
Yeah, you can't get him in here? He's just got to click the link to the event that I posted in the lobby.
I'll tag him in it, see if I can't get him to join. I did recommend him for the live stream. I just wasn't going to VC verify him in the server for reasons like that. That just would have been disruptive behavior, and I didn't want to be responsible for something that I wasn't going to be able to have more of a conversation with him about.
I have a question. Can anyone answer me?
Yes. Go ahead.
If we assume that the Earth is flat, is the other planets flat too?
No, well, Earth isn't a planet, so I don't know what you mean by other planets. If you're assuming Earth is Earth, right? It's a flat topographical plane, and nobody knows the absolute size or shape of the Earth, right? But you could probably think of it kind of like the foundation that we all live on of this system.
So is it infinite?
No one would know the size or the shape of the Earth in its full extent, so that's not a question I can answer.
Can anyone else answer?
What's the question?
If we assume that the Earth is flat, is the other planet flat too?
Earth is not a planet, and planets aren't what you've been told.
Like the moon. The moon is not a planet, but it is round or a globe, right?
Well, it could be, but I don't even know what the moon is. It could just appear to be like that.
It is the thing that is in the sky at night. Some people think
Earth isn't in the sky. Earth is not in the sky. Earth is under.
No, I mean the moon.
Yeah, but we're talking about the Earth.
Exactly. Yeah, we're not talking about the moon, right? So let's say, yeah, sure. If you think that the moon's a globe, right? But we're talking about the Earth, like T-Dub said, not the moon.
Okay.
Yeah, so the Earth is not the moon or the sun or anything like that, right? So when we measure the Earth, it measures flat.
Okay.
We're not claiming that the Earth is like an object in the globe Earth version of outer space either. A lot of people confuse that. Like, we don't think it's a flat disk floating around in space with other round planets, right, in a big vacuum. We don't think that.
But it can be right. Right?
What's that? Say it again.
It can be right.
Why?
You'd have to prove it.
Because you didn't prove it's wrong.
We
That's
didn't
not
prove
how it
what's.
works.
We didn't prove what's wrong.
You didn't prove that the Earth is planet. You didn't prove that is wrong.
We don't claim the Earth is round.
And you don't claim that is flat.
Yeah, we did claim it's flat. Yeah, absolutely.
How you did it?
How do we know it's flat?
Yeah. You said you claimed and you proved this. How?
Yeah, so we can test over large distances to see if the curvature is present, but it's not present. So it can't be a globe, right? And we can't find any curvature. And we all experience it as flat. So unless proven otherwise, it's flat.
How you want to see the curvature if it is too huge?
Well, that sounds like a you problem. What do you mean if it's too huge? No, it's not too huge.
It's our
If it's a globe, if it's a globe, right?
Yeah.
We can. There's going to be effects of the curvature that we can validate here on the Earth. Okay, so even just over a 10-mile distance, there should be 66 foot of curvature. Okay, so that means that things in the distance should become obstructed or hidden behind the curvature of the Earth. Right? Right? Think about this. If I have a 10-mile lake, okay, and if the Earth's a globe, there's 66 feet of curvature over the 10-mile lake. So if I set up a camera just above the water on one side of the lake, I shouldn't be able to zoom in with the camera and see the shoreline on the other side of the lake because it would be hidden behind the curvature of the Earth.
I think 1 mile is too small.
No, 10. I said 10 miles. 10 miles.
It is, how much is the diameter of the Earth?
I don't remember exactly off the top of my head, but the radius is 3,959 miles. The circumference is 24,901 miles.
Yeah, I think it is so much bigger than 10 miles.
No. I said if we test over a 10-mile lake, we can calculate how much curvature there would be over that distance. The answer is 66 feet. That's how much curvature there should be over 10 miles, based off the radius value.
But the Earth is not complete round.
It basically is, right? It's only 0.3% off being a perfect sphere. 0.3%.
Where did you get this this rate or this percent from?
This is the mainstream claim, right? They say it's only 10 kilometers fatter at the equator. And if you do the math, it works out to around 0.3% off being a perfect sphere. That's why when NASA shows you these claimed images of the Earth, right, it looks like a perfect sphere.
I don't know.
What's that?
I don't know.
You haven't seen NASA's images of the Earth? The globe?
No. Yeah, I saw the image, this blue one.
Yeah, the blue one. Sure, the blue marble. Okay, yeah. If you draw a circle around it in Photoshop, it fits inside the circle. Because it's almost a perfect sphere. Technically, it's not quite perfect, but they say that it's almost a perfect sphere. but the technical term would be oblate spheroid because it's not perfectly a sphere. So it would be incorrect to call it a perfect sphere, but it's almost a perfect sphere. Do you know who Neil deGrasse Tyson is? The chubby black man who's the scientist, the astrophysicist? Do you know him?
Can you repeat his name?
Neil deGrasse Tyson. He's like one of the famous science presenters. Yeah, I'll put him in the side.
I don't know him.
Okay. Well, anyway, he's a popular scientist, and he said that if you shrink the Earth down to a smaller size, right, the size of like a billiard ball, it would be the world's smoothest and most perfect billiard ball. And if you know what a billiard ball is, they're very, very spherical and very shiny. So he said it would be even more of a perfect sphere than one of those if you were to shrink it down. That's how close it is to being perfect as a sphere. If it was a sphere, which it isn't.
Oh, what I studied that it's not perfect or more close to perfect. I think it is more than 1%, but okay.
No, I didn't say 1%. I said 0.3%.
I mean, it is. I think it is more than that.
Okay. What is the answer then? What is your claim?
I am hungry.
You're hungry?
Yeah, I want to get some food.
Ah, your brain has had enough.
Wait, before he goes, Roma. So are you saying that the Earth is too big to see curvature? That it looks flat?
I think that the Earth is not round or flat. It's a hot dog.
It's what?
In the shape of a hot dog.
Oh, so you're broken now.
You can go to eat now. Geometry hurts you. You can go to eat now.
Yeah, you failed. No nitro for you, sir. No nitro for you. Next.
What is nitro? Sorry, what's nitro?
Don't worry about it. If you
don't worry about it, you lost.
Yeah, it's fine. Better luck next time.
So what is
it? The next is how I can fight with cognitive dissonance.
Yeah, next contender. Do we have anyone else that has evidence of the globe Earth?
I'm leaving, but tell me what.
Is it Imrail? Did you say something?
Yeah. I wanted to ask, like, was this guy is gone? Like, Greenweaver Alex said that's photo from 200 kilometers, and the mountain should be covered like by 3 kilometers of like a curvature. So, what's the point this picture is taken from? Because it's quite unbelievable. That's 200 kilometers.
Oh yeah, I mean, there's tons of pictures where we're able to see things that are hundreds of kilometers away, especially infrared photography and things like that as well. But I don't think that the Alex had the exact observation height. But if its magnitude's off, I think they said it couldn't be more than 100 meters high. So I don't know. Okay,
not about the height, but like the point, because I don't think that it's 200 kilometers from the mountain. It sounds unbelievable. No matter what's it should be too high. It's
why is that unbelievable?
Okay, it's hard to believe for me. That's why I'm asking what's the point.
Yeah, but why is it hard to believe that you could see something that's 200 miles away from a high vantage point?
The first
kilometers.
It's not like a very bad quality of this photo. It looks like it's quite nice. So it should be some super camera, and I never seen the photo with resolution.
No, he just turned it into an infrared camera. He removed a filter that was on one of the lenses, and what it does is that lens with that filter on it only allows certain spectrum of light through. Well, when you remove it, now you're looking through infrared coloring, instead of
Which
normal
one are you
color.
talking about, though, Sheepdog? This MRail's talking about the one posted at 39 minutes after the hour by it was an image that Greenweaver Alex sent to me.
39 after the hour.
Yeah. Oh, look, I'll just repost it.
Okay.
So, yeah.
Oh,
so
yeah. Is this the Hawaii one?
No, I think this is New Zealand. So they said it's 200 kilometers, and you can see Kapiti Island, which is near, and it's no higher than 100 meters. I've seen it with my own eyes too. From Pikarikiki Hill, no higher than 200 meters, but you'd have to be low to see Kapiti Island.
Hey.
Like that.
Hey, it's Alex. I'm just driving, but I'm listening to you. Yeah, it's a Paikakariki Hill, and it isn't very high. I've seen it with my own eyes, but that's some Glober posting on Facebook, and it's really funny to see the comments. The comments from all the other people saying it's impossible. You know?
Ah.
Yeah, it's quite funny.
Yeah, it'd be really cool to know
I'm afraid I'm driving to work.
Oh, that's okay. Yeah, it'd be good to know the exact observation height, so we could do the put it into the Earth curvature calculator.
Yeah. So when I
Yeah,
tried
well,
to,
the hill it's on is 210 meters at the very tip, but there's no way you'd get that view from the tip of the hill, so it had to be down the hill at least halfway.
Yeah. Okay. Oh, we could do an average.
it's the
Yes.
same hill that I find on Google Maps. It's 20 kilometers from this mountain, not 200 kilometers.
No, it's 200 kilometers, believe me. I've driven there. Yeah, it's more than that because you have to go around the arc of the bay. But I did a crowflies measurement on Google Earth.
Oh, nice.
I can drop the screenshot of the Google Earth image, actually, if I get it at a traffic light.
Oh, yeah. Okay. Yep. Stay safe. But if you get a chance to do that, drop it in.
I'll do that,
Awesome.
yeah.
But person from, I don't know, from Belgium will tell you now how the New Zealand look like, you know?
Well, that's what Google says. If it's some other, like it says 22 maybe kilometers. If it's another,
She's there, man.
So okay, so it's not the same island, or it's not the same mountains. That's why
I
I'm
think you might be
asking.
measuring Kapiti Island, which is maybe 20 kilometers away. We're talking about Mount Taranaki that you can see in the picture, which is like New Zealand's Mount Fuji. It's 2,000 meters high, but it should be under 3,100 meters of Earth curvature. So I think the 20 kilometers you're talking about is
it's not on
Kapiti Island,
Yeah.
which is what you can see in the foreground, and very close. Yeah.
Okay, thank you. Yeah.
Yeah.
So it's not the
Yeah.
same one. Yeah, thank you.
Yeah, no. So Mount Taranaki is on the end of a peninsula in the other side of New Zealand. I'm in Wellington. So Paikakariki is almost Wellington, the capital, which is right down the south tip of the of the North Island.
So it sounds like a lot of people can see this, right?
Yeah, there's so many photos online. You see, I didn't take a photo myself when I saw it, but I went and searched for it, and there's so many. And it's quite funny. They're all by Globers, and they're all going mad in the comments. It's hilarious.
You guys know on the globe model that once factoring in those externalities that a glober expects to see those objects, they don't not expect to see it, right?
Yeah,
It's
like
reducting.
externalities that
Reducting.
nobody can prove exist meteorologically.
They're
Right.
measured and provable, yeah. What do you mean?
No, they're not.
Okay, so when a glober shows you the ship sinking behind the seemingly horizon, you say it's refraction.
Just foreshortening.
Which is the same move they do against you guys, right?
Yeah, I agree, Matrix. It's a lot of foreshortening of perspective due to objects in the near field, like undulations of water, that are imperceptible at range due to their small angular size, nevertheless obstructing the bottom of a ship that's even further out, that's even larger in size.
I don't know who was talking before that. The Glober. It mentions refraction.
Yeah, that's
But let me explain it.
Reductio.
Yeah, we didn't even get to refraction yet.
Reductio? Okay. Reductio, let me explain this to you. When we say refraction causes bottom-up obstruction, we can actually demonstrate this over a flat surface using natural conditions of the air and the atmosphere.
Is this the table in the penny GIF?
We can do it over water. We can do it anywhere, dude.
Well, true. Those conditions are probably rare, man.
What you can't do is demonstrate these over using natural conditions over a curvature. You can use curvature and these conditions as an explanation, but you have no repeatable demonstration of it. We, on the other hand, have repeatable demonstration over a flat surface of bottom-up obstructions.
I don't know why that's your epistemic framework for it. I mean, like, we have formulas to account.
You can't formulas is pointless, man. If you can't demonstrate it, math can fucking lie, bro. You can lie with math all fucking day long. I can prove 1 + 1 = 3, and you can't say shit about it.
Okay, so you reject math. Great.
No, he doesn't reject math. He's trying to tell you you can manipulate it. You can't manipulate reality.
It's just a language, dude. Just like any other language, you can lie with any language. Now, the thing you can't do is lie about reality, because when you go out and you demonstrate and manipulate the fucking independent variable and you demonstrate the environment and you show that what you're seeing is what you're seeing and you have a cause and effect relationship, now we have a different story. We can actually determine whether or not this is factual and evidentiary for the nature of the reality that we have going on around us.
You know, Sheepdog, something I've never seen in all my years of doing this is what kind of gradient of refraction is required to produce the steepness for 7/6R to be even true.
What kind of gradient of refraction?
Yeah,
it's not necessarily a gradient.
Yeah, it's a I mean, that's what we're talking about, the grin.
Well, so Indio did a video on this, and it extends the radius from 3,959 miles to like 4,100 miles, if I'm not mistaken, like 4,100 and some change. And but the bottom line is, right, like if you're going to tell me that my reality is behaving a certain way, you can show me all the math in the world, but if you can't show me the actual magic trick, like if you, hey, that card is using sleight of hand, okay, prove it. And then you give me some mathematical equation, but you can't show me how he's using sleight of hand for the card trick, then why would I believe you?
Yeah, exactly. Look, it's a great point. You know, we can reproduce what we're claiming on a smaller scale all day long. They can't reproduce any of their claims, right? They're just having to reverse engineer it using numbers without showing what Sporadic's talking about, which is the meteorological conditions that would have to be present to allow something like that, which isn't even possible, right? It's impossible. And then the amount of these crazy long-distance observations we have, these crazy conditions that would have to be present to allow us to see these distances are always there in all of these amazing crystal clear long-distance observations. That's such a ridiculous claim to make by the Globe side.
Right.
Look at
an earlier point.
I'll give you
infrared.
Okay, well, what's your guys' response to the Bedford
Never seen a single glober produce an infrared observation of the globe.
Yeah, the Bedford experiment.
Real quick.
Yeah.
Hey, real quick, Sheepdog. Sorry to cut you off. I just want to remind everybody that we got to watch our language on this server. That's all. Just real quick. Sorry to cut you off.
Anyway, Bedford experiment. You're talking about Walter Bisling's observation.
Yeah, I can link the wiki in side chat for anyone who doesn't know.
Yeah, the horizon
that's
is
a good one.
The horizon is behind the pole that he's using for his observation, and that pole is further than the curvature of the Earth would allow. So therefore, Walter Bisling also has a black swan.
Yeah, and his own calculator would flip the image upside down.
So I'll give you, so here's what you're going to need in order to get refraction through the air, right? Because we all know the argument, you have to have two mediums in order for refraction to occur. So in order for refraction to occur through direct line of sight, some things are going to have to take place. There's going to have to be a change in temperature, a change in pressure, or maybe some wind blowing. Instead of laminar airflow, it's going to have to be turbulent. And this will create a disruption in the air between you and the object, and then there would be some sort of refraction taking place on that. Now, it's much simpler to demonstrate a single point of refraction on a flat surface, creating a deflection upward that would give the appearance of something sinking into the horizon and having bottom-up obstruction. Much more easier to do that. Not only that, but when you look out over at the horizon and you see things going out over the horizon and then sinking down below the horizon, they tend to not lose angular size once they go over the horizon. They actually, even in some cases, grow in size, which is a magnification process, which is also a product of refraction. So again, we can demonstrate all of this refraction that's occurring on a flat surface. You cannot do that on a curved surface. If you wanted to say that refraction is the cause for why we can see things too far and is making things extending the curvature, making it look flat, well, you're going to have to do this while making things get smaller as they get further away, because you don't have the magnification, because that only occurs after it goes over the horizon.
Okay, so yeah, well, when using magnification too, you are compounding the effects of turbulence and scintillation as well. So you're going to have a lot of image wander and warble that work jointly with your claim of refraction. You don't see that, and when refraction is as steep as of a gradient that you require to claim terrestrial refraction is in the first place, you'd also expect to see chromatic dispersion, which is also not evident whatsoever in any of these images or videos ever produced by any glober.
I mean, I'm pretty sure the Bedford, like Wallace, he raised the viewing
please
height,
show the evidence like we asked
to minimize the refractive distortion. And then there was consistency among multiple trials, like Oldham's photographic document.
Reductio, I've had this out with you 3 times now. You have produced nothing. The other day you were asked to... silence. The other day you were politely asked to produce a laser bending down when you were presented with a laser test.
I don't know
you
why
were asked, you claimed refraction is causing the lasers to set straight. So we asked you to produce video footage or photo evidence of said laser bending around the curve. Downwards, bending around the curve, out in the open air. No fish tanks, no sugar water, no glass, out in the air, laser bending downwards. I have seen video footage and photos of it bending upwards. I've seen hundreds of them where it's dead straight, but I'm yet to see one where it bends down. Please present that.
But this is far better. Why do you think that is better than these controlled and repeatable experiments that were...
Why do I think it's better? Because your claim is all this refraction and ducting and all these crazy things are happening in the real world all of the time. And it just so happens that all of these people that have done laser transits at different temperatures, different altitudes, different humidity levels, it just so happens to coincide with perfection on the day that they did it, that it perfectly refracts and we get a dead straight laser.
Isn't that funny? Yeah, let's see all the repeats in control. You know what I find absurd, right? How every ray of light, all trillions and trillions and trillions of them, across an entire field of view extending for tens of miles, potential 100 square miles of field of view, that they're all taking independent ray arcs of curve through different meteorological conditions, and yet produce a stable flat image that is visible for tens of miles in all these directions over different terrain, over bumpy terrain, warm terrain, cold terrain, all this different terrain with wind and everything. And globers think that this is evidence of a globe. Globers will claim that all these independent ray arcs are conspiring together to produce a flat Earth.
So, please provide your laser transit video or photo evidence showing the laser bending down across a lake. That'd be awesome. Where people have gone out in the real world and here it is bending down, proving your globe.
You know, Matrix, I still have not seen any infrared observations of the globe.
But I mean, the reason why this experiment gets cited is because they have midpoint poles.
What experiment? Reductio, why are you sidestepping? This is a red herring. Can you provide what we require, what your claim is? Can you provide it, yes or no?
Something like that on hand, no.
Well, 1 second, because it was his claim originally. He's trying to say that the Bedford level proves the globe. Okay, so, and we asked you to present the evidence and the validation that it proves the globe. So put the observation in the side chat so we can watch the video, we can look at the images, we can have a look at the conditions that were present on that day, right? You need to provide evidence of the meteorological conditions that were present, right? So we know what the optical density gradient was for you to be making this hyper-specific claim, right? So put all of the data in to back up your claim now. You want to make hyper-specific claims like this? We need to see the data to go along with it.
Sure, I don't dispute that. In Alfred Russell's experiments in 1870, what he did to try to account for this was he put pole A at the observer's sight line with the telescope. He put pole B, the midpoint pole, 3 miles away, and pole C was the target pole 6 miles away, and each pole had a disc or marker mounted exactly the same height above the water, like 13 feet. And he looked through the telescope mounted on pole A to measure the top of pole C. So if the Earth were flat,
show us the validation that he did that. Show us
line with the midpoint of pole B should align perfectly with the other two, right? But
show us how he validated the meteorological conditions, right? The temperature gradient. We're going to need to know that if you want to make these hyper-specific claims, because you're Mr. Refraction, aren't you? Okay, so we're going to have to know what was happening with the atmospheric refraction that day. Yeah, obviously. And and you're going to have to present the evidence of the claim that you're making about what he did. You know, we're not going to just present you. Imagine if we presented you just data and said, back in the 1800s, this flat earther did this thing, and here's the numbers, and it proves a flat earth, right? You're going to, like, we're showing you high definition videos that you can watch the entire observation start to finish that have been done recently. Okay, we're not quoting something from over 100 years ago that doesn't have any video to go along with it. Do you even have photos to go along with it? Right? What did he use to measure the meteorological conditions between point A and point B? Right? To prove that there's not some type of specific effect going on that day. You don't have any of that.
Lens distortion, like it all comes into play.
I want to add something real quick. I'm sorry, T-Dub, I just want to add this real quick. So some people have presented the Walter Bisland's observation, and when you go in there and you look at what he did, and you look at the images, one of his observer heights is low enough that the curve of the Earth should be in front of one of the back pole, and instead it's behind the back pole. So whatever's going on to make the
well, that's how refraction does work.
Dog, we got several images that he deleted off of his website because we pointed out these mistakes.
Well, Wallace wasn't alive when the internet existed.
So, Reductio, if refraction is putting the horizon behind, it should also be lifting the pole up to make it look flat. So if it's dipping down, there's something else is going on.
No, okay, so
we caught him removing evidence that went against his claim.
He didn't bring Reductio didn't bring up all the Bisland. He's talking about Bedford level.
Here's my understanding.
Reductio, hold on a second, dude. One
Okay, you go
second.
first.
Right?
I'll give my understanding.
Yeah,
next.
yeah, because you just said something. I just wanted to respond to what you said, right? So you said you don't have any of that data to go along to validate your claim.
No,
because it was done such a long time ago.
I was going to elaborate, but if you let me go first, then.
And he didn't use 2 poles. He used 1 pole and a bridge marker on a bridge.
So Wallace designed the experiment to reduce refraction effects, and refraction can bend light downward. You guys deny that, but not in the way.
Come on! You can't prove it.
No, I don't.
We've asked you very politely, Reductio.
I didn't.
We have asked you ever so politely to prove it, and you still steamroll through without anything to back it up.
Sure,
out in the atmosphere, I want to see video footage or photographic evidence of a laser bending downwards. So until you do that, your claims of light bending downwards are null. You've got nothing to back it up.
I have another question after this.
You've got nothing to back it up.
We've got images. We've got images of light bending down over shorter surface where Earth curvature wouldn't be a factor. Like I point to your entire Sky Freeze channel of this, and we've also got great educational showing what happens when you introduce an inversion layer like over a driveway, making a toy boat appear to sink over a horizon even though it didn't even move.
Okay, so I'll just get my understanding out of Wallace's midpoint pole experiment. So refraction can bend light, but not in the way that causes the middle pole to appear higher than both endpoints, which is only possible with a specific bending shape of the Earth, aka the curve, which you guys deny. And so Wallace's experiment would be
that's a hump in the middle, bro. That's a hump in the middle. Was his theodolite level? Was his theodolite level?
Yes.
If he says only possible,
then
he needs to have a science experiment demonstrating that.
You're claiming that horizontal is now going to produce a hump in the middle, so you got like a chord? No, bro, that's not it. It'd have to be a drop if it was horizontal and level.
I'm saying Wallace's experiment, which this was repeatable, by the way. It's only possible on a curved Earth, even accounting for refraction. That's how he designed.
No, it's not. It's not.
I don't think you understand the experiment or refraction. But I have a second.
You not understand. You just said that he had the, you just said he had the theodolite level, and he got the middle pole higher. That's actually impossible on a ball. On your ball, it would be lower if his theodolite was level. I don't think you understand what was done.
Okay, I think you got it completely backwards. So on a globe, when looking at a straight level pole A to C, your line of sight is a straight line, but the Earth on a globe, the Earth's surface curves downward. So the midpoint will be sitting on the curved surface, which is above the straight line.
The midpole would be lower.
Yep.
Pole B would appear higher,
lower.
Right.
Lower.
Okay, let's perspective. Let's just show him here. This is how perspective works. Okay, where's something with poles in it? Right there. Inside chat. 3, 2, 1. Ta-da. See how all the poles are getting lower as they get further away, Reductio? That's how perspective works. If all those poles are the same height, that's what should happen. There should be no hump in the middle. They should all appear to get lower.
Well, hold on 1 second, because I don't think that's quite his point, right? What he's saying, like if you're standing on top of a basketball and you're looking out horizontally off the top of the basketball, the surface of the basketball would only drop away from you. Okay, there's not going to be a hump. Now, if you were looking directly at a target, that is, say, now we're going to go onto the globe, right? Say you're standing on the globe on one side of a lake, and you have a direct line of sight to another person that's, say, 6 foot tall on the other side of the lake, right? And your line of sight is going from your eyes to the other person's eyes. Then you're going to have a hump between you and the observer. But if you have a horizontal line of sight, right, that it's only going to drop down and away from you. It's only when you have a direct line of sight that's going to create a tangent, which would be the horizon, right? That's when you're going to have that hump situation. Okay, so if you're looking out horizontally, it's only going to dip away from you if you're on a globe, right? Because they say that anyone should think of themselves as standing on top of the globe from their perspective. You could just think of a basketball as the example and a little ant on the basketball or something like that. You shouldn't have a hump if you're looking horizontally and standing on top of a basketball.
Right. So what would have to be claimed is that he had to reduce the angle at which the theodolite was positioned in order to get the furthest distance marker to be true with the crosshairs in the theodolite. Thus, then claiming that the middle pole appeared to be higher than the crosshairs in the theodolite, inferring that there's a hump or a curve, right? That there's a curve. Right. If it was level, that means he established a tangent plane or line of sight, right? A tangent line. And if the surface of the Earth is curving, then everything upon its surface is going to appear to be, with distance, will appear to be lower in the field of view. You would have to tilt the theodolite below level to get things to be either to meet the crosshairs or to be higher than the crosshairs in the field of view. Get it?
No, and I don't think I'm going to make progress explaining that you would expect.
Then you don't understand what was done.
Because the ground and the pole standing on it rise up towards you in the middle compared to the straight line that you would expect.
Okay, why do they rise up?
Because the Earth is curved.
Okay, so in your position, anywhere on a ball, imagine a line, a vertical line, which is what you globers claim, that goes down to the center of the Earth. A plumb bob, if you will. It goes down to the center of the Earth, you grab hold of it and pull it up. You then create a line perpendicular to this line this radius line from the center of the Earth. That perpendicular line is your horizontal. So anywhere from that would appear to slowly curve down. So if you've stuck poles in the ground that are all 3 foot high and you have your theodolite set horizontal, i.e. perpendicular to this vector to the center of the Earth, every single pole should slowly reduce in height. And you disagree with this. I do not know why. The problem is, if you're claiming there's the center one is raised, that means you do not have your theodolite set to horizontal, i.e. perpendicular to this vector to the center of the ground. You have your theodolite set at a chord across the Earth. Do you understand that?
I don't think we're going to be able to
That's the only way.
Understand.
Okay.
I mean, I don't think you guys understand.
Okay, what you need to do is do some really basic mathematics. I want you to draw a circle. I want you to draw a tangent to that circle. Now, equally perpendicular to that tangent, I want you to draw equidistant heighted poles along that ball. So as you go, pole number 1, 1 foot high. Go to another position. Pole number 2, 1 foot high. And you'll notice they reduce in heights away from your tangent. And if you have a look back, T-Dub actually posted it for you at 24 minutes past the hour. There's a really simple graphic there. Your line of sight is the straight line. The ball is the curved one, alleged. Now, if you plant sticks in that, as they get further away from your line of sight, they will decrease in elevation.
So, Reductio, I just want to say this real quick. Do you know the difference between True Horizon and Horizon?
Yeah.
What's the difference?
One is optical, the other is geometrical.
No. This has to do with the person doing the visualization, not the location of the horizon.
Okay, go on then.
So true horizon is when you look out straight, not to the curve of the earth, but slightly above it, because you're looking straight. That's your tangent. That's what a theodolite is doing when you level it. It's not level to the horizon. It's level to the tangent of the earth. You're basically putting the theodolite, assuming it's a ball, at the top of the ball, wherever the top is, that the theodolite is the location of the top for that observation. And then you're leveling that theodolite because the observation it's going to see is going to be the true horizon. It's not dipped slightly down to look at the horizon. It's looking at the true horizon based off of the leveling bubble that's in the theodolite. Now, what you're saying is that in this three-pole observation, the middle pole is higher than the first and the second pole, which is impossible for a various number of reasons. The most common reason why it's higher than the others is because he didn't put it in. He didn't use the same height pole, or he didn't put it far enough into the earth to make it level all the way across. Like, he didn't do his measurements correct. But when you're looking at it at theodolite, everything should be curving away from the theodolite. Everything should be dipping down. Not one thing should be above another thing in a theodolite observation. That is what true horizon is. That's what you're supposed to be looking at in this Bedford level experiment. And that is a true fail from you trusting that observation. You need to be a little more hypercritical.
So Matrix posted the power lines on the railway, the eye level vanishing point. The thing that was shown in this experiment was, how is one pole actually higher than the next one? Right? Why is this one poking up above it? Which the further one drops down because of the curve, and so it would be expected to be...
The first one is the highest one, right?
The one you're looking at. And the midpoint is higher
the first one.
than the further one.
No, the first one. No, the first one is higher.
You're
then
at
the second highest one is...
Yeah, you're looking through...
And then the second one is lower than the first one, right?
Well, you wouldn't know that because you're just looking from the first one to the second.
Based off of your perspective, from your own personal observation, if you were completely stupid and knew nothing other than length, right? Like, you didn't understand how your eyeballs worked. Just by your perspective on where you're standing, the second pole is lower than the first pole, correct?
Well, I don't think you might. I'll just explain the experiment. You're standing at the first one, and you're looking at the second one. So,
okay,
both of them are like the same level, so 13 feet. Which the reason why they're above that high is because that's going to minimize refraction, because cold air can affect light bending. So you want to be above that to control for that and minimize it. It's not going to be perfect, but it does definitely help. And so when you look from the first to the second, the real clue is, where is the second pole 3 miles out in comparison to the third 13-foot pole 6 miles out? And
so
No refraction that day, huh? So when it looks like a globe, there's no refraction, but when it looks flat, there is. That's what I'm hearing.
No. So what you would expect is that on a globe, there would be the second pole obscuring the third one.
Yeah, this is affirming the consequent.
Only if you're standing in front of it.
Hold up. Let's just get this straight. Inside chatter, 34 past the hour and 35 past the hour. I've just modelled out two different things. Now, if we have a look at the first one at 34 past the hour, your claim is that the theodolite is set up horizontal. So if that is true and correct, then that is the effect that you should be witnessing. When you look straight, as you can see, the straight line, the one with the red dot on the end of it, and how the little poles get further and further and further and further away. They all appear to drop out of sight. That is what you should be seeing.
Yes, that's what
in your image.
Yeah.
Right. This is what you're showing us. Now go to the image at 35 past the hour. Right. Notice how at 35 past the hour, the line of sight puts the second pole as the highest, and there's a hump in the middle. Do you see the problem with the line of sight? That's how easy it is for you to make a mistake. You've probably misconstrued something, my friend.
I think
the
this
claim
shows
is that he had to tilt it down.
Yeah, that line you drew, because you're looking at. There's only. I mean,
the first one. Remember, the first one image is what you are supposed to see. Why is that not happening? Your claim is it's a ball. Okay, I will give you your ball. You've got your ball now, so why don't we see what happens in the first image?
No, the second image is exactly showing the experiment.
No, it's not. That's where you fucked up, mate.
No.
Well, here, I'm
see
looking
what I
at the
posted?
second image, and...
You see what I posted?
So,
You know how to level up the autolite?
5 minutes past the hour.
You know how to you know how to level up the autolite?
It'll be perpendicular to vertical. Just like look at what I posted at 37 past. Okay.
Oh yes, yeah, that's good as well.
Right. So in order for the second pole, right? For the first pole to appear higher than the second, he has to lower angle the theodolite down from level. So it wouldn't have been level, right? That's the argument. Not that with it level and perpendicular to vertical, the second pole appeared higher than the furthest pole. That's not the argument, because it could not. It'd have to be lower if the theodolite was horizontal.
See, and this is a conversation I have a lot with people who believe in the globe. They don't understand how vision works. They don't understand that you don't see things Euclidean or orthogonal. You're literally looking in perspective all the time. And so you can't ever compare orthogonal to perspective. It's impossible. This is why railroad tracks converge as they go into the distance. This is why, like, as you move further away from a house, you can see the top of the house, the roof. If you're standing at the garage, you can't, because things move down in your field of view from the sky, and then move up in your field of view on the ground. That's how perspective works. Actually, it's more like a cone.
You're saying
more
things
than
move
anything else.
up in your field of view?
Yeah, the things that are on the ground.
Edub's image is entirely on point and shows why the Earth is curved. Because you have the level.
Okay, you've missed the whole point of that image. See where it has the word level?
Mm-hmm.
See the coloured in line underneath the word level?
Well, when I say level, I just mean...
Yes or no? Do you see the coloured in line underneath the word level?
Yeah, it's going up for some reason.
The reason it's going up, Reductio, is that is where the theodolite should be facing.
So he should have
You have missed the whole point.
The experiment was done to look from the top of pole 1 to the top of pole 3, and you've drawn in that line. That's what. And
so, in other words, if that's the experiment, it's an instant fail because you are not setting your theodolite level. You are just aiming at something.
P-Dubs is not really a smart person to follow.
So do the angle. So he would have recorded the angle at which the theodolite was oriented, right? Does that match your globe expectations?
The prediction was that the second pole would be higher than the third and interfere with the visibility.
That's not enough, because there could be optical effects going on. You need to establish, right, that the angles, and even then, it'd still be affirming the consequent. But at least then you'd have some sort of geometry, right, reference. But some actual figures, some values which match the claimed geometry. It curving, consistent with a radius value of 3,959 miles, or the curvature rate of 8 inches per mile squared.
Jesse Path of Light would even. Jesse Path of Light would even say that this is a bad observation because he's all about the theodolite and how everything seems to dip down as it moves further away.
This is just a trust me, bro presentation this guy's giving us right now. It's just just trust this data from the 1800s. He doesn't have anything to support it. We'd be laughed at if we presented something like that to the globe side. That's why we don't do that.
Hey, I've got a flat Earth presentation from 5,000 years ago.
Well, I mean, just to give some history to this, the Bedford level experiment originally was done, I forget her name, but she was instrumental in founding the Flat Earth Society, right?
Go to that Bedford place.
This Alfred guy was responding to her experiment. He did the second pole. He did more rigorous controls, like raising the height to do.
Has anyone done it in the last 100 years that you can actually present something, right, rather than just asking us to trust you?
I could point other examples that have been done.
I know one person.
Years. Yeah. What are you guys' thoughts on polar circumnavigation?
Excuse me, Reductio. Have you seen Dr. John V's latest video that DJ posted yesterday? Have you seen that?
I don't know who that is, no.
Oh, this is a really, really good one, man. Look, if you've got a spare hour and a bit, he goes over all of the variables and details, right? This guy's a PhD. He's a very, very smart guy. He goes over everything. It's a crystal clear observation. I'll give you a little sneak peek at it, and then
Can you DM it to me? I promise I'll watch it before the next time we speak.
Yeah, I think you'll like it, man. You're into this kind of topic, and he goes into extreme detail about all of these things. So yeah, I'll just pop it in for you in the side chat, and I'll DM it to you as well.
All right, thank you. I'm just going to DM you as well, so it shows up and it doesn't get filtered out.
Okay, cool.
So, thoughts on polar circumnavigation?
I don't think no one's ever started in the north and then gone south and then kept going south and then come back to where they started again. No one's ever done that. We only have things like one more orbit in 2018 or 2019. Things like that where they go down, 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 and then they kind of do a bit of a U-turn when they get to Antarctica around the South Pole area, and then they go back again. No one's ever sort of continued.
What transcends all of this, DJ, is the assumption of spherical coordinates in the first place, which is arbitrary and a human choice.
I just
there was a guy in New Zealand or something like that. He claims that he did it where he flew south and then popped up from Antarctica on the other side going back north. But he fell asleep in his plane on autopilot, and when he woke up, his compass was pointing in the wrong direction.
But if you have a look at MagDeck maps, you could probably explain that away quite easily.
So my question with the polar circumnavigation is, I know that a glober will say, okay, you could fly across the equator horizontally along the alleged globe, and a flat earther will say, that's very cute of you, you just went in a big circle and ended up at the same point, but you tried doing that north to south all the way around the top of the bottom of the globe straight line. That's not possible if the earth is flat. A globe it would be, right? Is that kind of the idea?
If it is a sphere, then it should have already been done multiple times. It's never been done.
Yeah, like what you said, like, yeah, if you started in, like, just say you did a great circle route from north to south and came back to where you started, I don't think that would be possible on a flat earth. I mean,
so starting, would you be able to start anywhere? Like, you don't necessarily have to start at one of the poles. You could just, as long as you fly over all of them in a straight line without turning, right? And end up at the same point that you started at, right?
Yeah, I mean, just go south, go south and then come back to where you started.
Listen, no flat Earth is a 2D looping manifold.
Hello.
Hello, dude.
Hi there.
Okay. Was the Polar Mission 2025 that one they turned around, or
which one are you talking about? Can you?
What?
The Polar Mission 2025.
Orbital?
Yeah, with respect to
Is it orbital or suborbital? Is that something we can't verify?
Oh, you're talking about the one that they did, like, from quote unquote space. Dude,
what is the Polar Mission? Here, I'll just link their website.
Are you talking about? It was done in low Earth orbit. Is that the one you're talking about? The world's first ever orbit over, circumnavigation. Is that the one you're talking about?
Hold on. That's the link. I'm not sure if this meets criteria. I'm just having a read.
Oh, okay.
But it says polar circumnavigation
the average Joe can
around the Earth
attempt.
through both the North Pole and the South Pole. The Rockwell polar flight was the first to complete a polar circumnavigation in 1965, but you're saying no, they turned. So you can do that on a flat Earth.
Yeah, so, like, their idea is just to touch, like, to be, like, to sort of cover both, right? Like, just say you circle around the block. I mean, just say you've got a street, right? And you can start at one street pole at one end of the street, and then you go down to the other one, and then you turn around and you come back again. You've been, to both of the poles on your street. But what I'm talking about is not turning around when you get to the pole, continuing straight, and then arriving back at the first pole again.
Right. So they would take the shortest route in between the two poles, so a straight line on a sphere, and not turn around once they reach the opposing pole, but continue over it.
Yeah, so start at they don't even have to start at the North Pole, but just so it makes more sense in your head, right? Just say you start at the North Pole, and then you go south, right? And you go straight over the top of Antarctica, and then you come back to where you started again, right? You just go a great circle around the globe and come back to where you started. Obviously, you wouldn't have to do it in a perfect straight line or anything like that, but, along those lines. No one's ever done that, or anything close to that. Let me give you an example. Like, when you type it in, you get things like one more orbit. So I'll show you the map of what they did.
So is this for you guys, like, it hasn't been done, and the implication is maybe it just can't be done because the Earth is flat then, right? Is that the...
How would you even know you've done it?
No, that was not done for sure, but Earth is not flat because of that.
That would be one good way to show.
Like a couple of years ago, right? A couple of years ago, that pilot came out and said, "I will charter my aircraft. You get the money together, flat earthers. Get your group. We can all get on board, and I'll take you around the coastline. We'll start at Australia and we'll end at the tip of South America, or vice versa, whichever one." Right? He says, "We'll traverse the coastline of Antarctica, and you'll see." Right? And I was like, no, I was straight in his comment section. No dice, bro. It's straight over the freaking middle, or none, or bust. That's it. You go straight over that bastard. I want to see ice on either side of me. I want to see that freaking coastline behind me, and then one coming up in front of me. And ice on either side of me.
Okay, DJ. Well, this was the
one more orbit. But look, the problem with also like the path that they said they took, it's not the type of circumnavigation that would disprove a flat Earth. But if you actually have a look at the footage that they shot, it doesn't seem like they actually even did what they said they did. Right, I don't know if it was a little bit of a scam or something like that, or they were meant to do this particular route, but there's no real proof that they did this, right? Like they have some footage, they have a YouTube channel, a website, but you have a look at all of their footage, they don't even show you really out the window of the plane during any of the trip. The footage is like within the plane, not even looking out of the plane. They'll show a few shots of them landing at a few different places, but they don't show any footage out the window when they're going over Antarctica or anything like that. It's super sketchy. So, but even if they did this path that they're claiming, it's not like the type of north to south circumnavigation that would.
Yeah, I could see how this is possible on either model.
Yeah, we don't exactly claim a model, but yeah, I get what you mean. Like some flat earthers claim that the AE, like Gleason map is the flat Earth map of the Earth, but that's
that. It's called the
we're not yeah, like the United Nations flag, right? The AE map, right? The round one that some flat earthers claim, oh, this is the flat Earth, and this is how the sun and the moon orbit around the flat Earth, and blah blah blah. Right, but it's just a globe projection. It's the azimuthal equidistant globe projection map.
Okay.
But even though there is claims that Gleason apparently said in his book, it's a projection but not of a globe. Now I don't know. I haven't read his book, but there are flat earthers currently claiming that Gleason's map is not a globe projection. I don't know. I'd have to study how Gleason
says
that map.
Yeah, so T-Dub, if you look on the back of the map page, it says an extortion of the globe. It's a word that's not used anymore. It's hard to find an actual definition of it. It means something like twisting or something like that.
I think if you're using this AE map, I think this is straightforwardly wrong, just because.
And the globe's wrong. Totally can be wrong if the globe's wrong.
The North Pole would be the center, and the South Pole would be anything pointing away from the center. So anywhere on the outside of the circle, that's all the South Pole. But obviously the Southern Cross.
You're confusing the way it looks. You're confusing the way it looks versus the way that the coordinates are. It's a projection of a coordinate system. See, this is people often get confused with a map versus a coordinate system. They're not the same thing. They can be the same thing, but they're not always the same thing. Actually, frequently, they're not the same thing.
I mean, I could see a flat Earth, like maybe the North Pole is, maybe shift this over. The North Pole would be all the way to the right. The South Pole would be all the way to the left. And then everything in between.
Did you not hear what I said?
I'm just saying that would be more plausible because you can account for the Southern Cross.
What does that mean? How would you shift the coordinates when you did that?
Well, that would explain why.
So it has latitude and longitude lines on it, right?
Well, yeah, I mean, what it would explain is why these polar circumnavigations turn around once they reach the edges. They can't fly over it because they're at the edge of the Earth.
Okay.
And
it seems like you're dug in like an Alabama kick, dude. Trying to teach you something, man. So it's a coordinate system, latitude and longitude, right?
yes, but I think in globe terms. So when I think that, I think
where are those?
when it's on a globe.
Yeah, but what does it mean to have a latitude and longitude?
It's going to be the north, south, east, west coordinates.
Okay. So how did we create this coordinate system? How was it created? What does it refer to? You think it refers to the ground, but it does not.
Oh, DJ, I realize, yes, you guys don't claim this per se.
Okay.
I know.
Say it again.
Indio, sorry, I didn't want to get distracted.
Yeah, that's fine. So if I wanted to find my latitude and I couldn't see the stars, how would I do that?
GPS?
Yeah, that would also be the same thing.
Let's say you don't have that.
GPS doesn't use that coordinate system, technically.
I don't know. Like, I'm not a map guy. I'm not an expert. I mean, I think they.
Well, then why are you telling us about maps? What the map should do when you're not a map guy? It's fine. A lot of people don't know about this, but latitude and longitude are not points on the ground. They're in the sky. Okay? So longitude denotes the sun's position, where latitude denotes where the celestial equator is relative to the observer. Right? So if the celestial equator is 45 degrees above the horizon, you're at 45 latitude. The sun's over Greenwich, and you look at your clock, and it says 5 hours before 12, then you're at 15 times 5 longitude. This is how the coordinate system works. Has nothing to do with points on the ground. Neither does GPS. GPS is in something called Earth-centered, Earth-fixed, which is another coordinate system, which puts you on a Cartesian coordinates on a plane. See, these are projections of a coordinate system. That's all they are. They have nothing to do with the ground. It doesn't start with the ground ab initio. That coordinate system is, they do have one. It's called the public land survey system, and that uses Cartesian grids, boxes. It's very hard, basically, to orient yourself relative to everywhere else across long distances. Is difficult, so we use the stars in a model, a celestial sphere model, to do this. Okay, so you look at these maps like the AE map. Hey, this map, the Earth don't look like this. Yeah, probably not. But that thing is just a projection of the coordinate system. It only tells you your longitude. That's what the purpose of the AE map is. If you're somewhere on there, it's a time calculator. That's all it is. So if you're on one of those lines of longitude, you can tell when it's going to be noon again. That's all it does. It doesn't do anything beyond that. It's not what the Earth, quote unquote, looks like. Okay, it's nothing like that. Any more than a temperature map is like what the Earth looks like.
You could pretty much project it onto anything, any sort of structure you like, right? Like in any
Literally
shape.
anything.
Yeah. And then you could project the sun's path and whatever, like the luminaries and that. Doing
You know
all
how they
sorts of
skin
weird
3D
shit.
models? You understand they skin 3D models? They have a wireframe, a mesh wireframe in a 3D software, and then they wrap basically a rectangle on it. But they distort the rectangle so that it fits and that the 3D model looks like, somehow you'd expect it to look. So this is all that's happening. It's just, I shouldn't say just, it's differential geometry, basically. You can map any surface to any other surface. And then you can preserve whatever you want. You can preserve angles, you can preserve areas, you can preserve distances. Typically, you can't preserve all three. Anyway, it seems confusing, but it's actually not. That's why when someone says it's 69 miles per degree of latitude, okay, who measured that, man? Nobody's ever measured that. Just assumed to be true, based upon an assumed radius that no one's ever measured.
Well, that'd make the perfect sphere.
Oh yeah, it's good enough. It's close enough. Is it now? I guess no one's ever been lost at sea. That's never happened, right?
Yeah, they just didn't know how to navigate.
Well, I mean, there's so many ships at the bottom of the ocean, it beggars belief. They didn't get there because they weren't lost following the globe.
Not even the Antikythera mechanism could save them.
So I heard someone, I was listening on the live stream earlier, and someone said something about 200-kilometer observation in New Zealand or something.
Yeah.
Is that you?
Yeah, I'm asking like because I think I misunderstood all this time. I was misunderstanding actively all this like situation with drop over curvature and stuff like this. So when I heard that the mountain that is 200 away from the point of view, 200 kilometers away, it should be like it should be blocked by 3 kilometers of curvature. And I also always imagine that it. Like if you, I'll try to probably send it in the chat. I've already did it several times. So I always thought it's a red line, like the height of the land mass or a water mass that should be blocking the direct view. Was I correct or incorrect about that?
Well, I mean, the technical term is called the sagitta. Right, so let's say you're standing somewhere and there's, someone else is standing somewhere else on a globe. And you drew a line, a direct line through the globe, feet to feet. That's the chord. And then the height above that is the sagitta. That's what's supposed to block things.
Is it like...
Right? It's supposed to be like a mountain. Yeah, that drop is basically 8 inches per mile squared.
So
it's generally true.
So the problem is like when I try to look at it, it's this H, the violet line, that's 8 inch per mile square. And I did the math and it's this one. It's not the small red one that's blocking. Like the formula is R, like R, the radius of the Earth, times 1 minus cosinus the angle. And it's the H. It's not the small red line.
Yeah, but that number is equivalent roughly to 8 inches per mile squared. It's actually like 7.98 inches per mile squared.
What he showed was the sagitta. Okay, so let me look at this again. Hold on 1 second. Okay, so that little d number, the red line, that's the sagitta. That's what a sagitta is. The black line of that triangle is called the chord of the arc, right? In the drop would be like, say you're at the top of H, the purple line, so you're at the top. The drop is how much, where the green and black line intersect, how much that would drop from eye level, right? I'm on a phone, so I can't draw it. But say we drew from the top of that circle, we drew a straight line, like a tangent line going out, and the drop down from that line to where the green and black line intersect, that is called the surveyor drop or the curvature. That's how much that drops down from eye level is what 8 inches per mile squared quantifies.
Now, does that you drop, right? Is that
yes?
Is that,
so basically,
is that vertical to your? Is that vertical to your tangent plane or vertical to like a continuation of the green line?
It would be exactly the same as the violet line.
It's the same.
What?
Like when you continue, like when you point these tangents that you explain, and then you calculate the distance to the intersection of green and black. So it's the same that the violet H line, because it's like a rectangle. So it.
Yes. It would be the same as the H line. Yes.
Yeah. So it's the drop. But like when we're talking that someone is blocking the view, for example, imagine I stay at the top of the violet line and this mountain is in the intersection of black and green. It's the small red one that is blocking the view. So it's not 3 kilometers or that's blocking. It's like 800 meters or something like this.
Yeah, we understand that.
Yeah,
I mean, if someone said that H was the mountain being blocked, typically, so there's, people will say like, 1 mile is obscured, but what the drop is completely different. How much something drops down.
You got to take into account the height of the observer as well.
Yeah, that's another factor.
I will say this though.
Well, let me just say this. So we typically, when we talk about 8 inches from outsquared, it's a newbie, and we're just trying to give them a rough number so that they can understand it. We're not trying to be specific, because typically they think that there's no curvature in thousands of miles. You know what I mean? Because they don't know anything about the topic. So
Right. So see
trying to give them a rough idea.
Right. DJ posted the table there, and goes through the math. Right. So there's a square, right? So it's a square. Basically, he's got there.
Yeah, so just like to save all of us time, what I meant is like this drop over distance, it's not the same that we observe. Like it doesn't matter, like it doesn't matter too much, because we would like to know the height of the thing that is blocking the view, because it might be like it could be a very big drop, but like we don't care about that. We care if the thing that we're trying to see is blocked or not.
Well, no, the horizon should appear in front of the object, and then you should also see the horizon blocking a specific amount of that object. Or in some cases, some objects aren't even tall enough to be above the curve, so they should all be completely hidden by the curve.
You can have a look. I'll post the link to the Earth curvature calculator, but it explains how it does the math there. I've posted the diagram of how it explains it and the formulas and everything. I'll give you the link to the one that I copied these off.
And that 8 inches per mile squared, it's good for like up to 1,500 miles. And at like 1,500 miles, it's only off by like 30 feet. Like 30 feet is like negligible when you're talking about something that should be hidden behind a couple of miles of Earth curve or more.
Yeah, we have a calculation available that anything under 1,000 miles, or excuse me, anything under 980 miles or something in that ballpark, it's good up to 1%.
But when you take into consideration the maximum distance you can see anyways, why are we jumping up and down about 1,000-mile view? Like, seriously.
Yeah, forget it. So 1% error margin, I should have been more specific. You're within 99% of accuracy up to a distance of up to 1,000 miles. You follow, Imrail?
Yeah, and I'm just like, I opened this calculator, so I'm doing this at the same time. That's why I'm silent.
Because the parabola in question, right? It's a fitted parabola to a circle, right? It's the best fit. Instead of like a tangent line, you could think of it like a tangent parabola. I mean, not exactly the proper terminology there, but it's the parabola of best fit, such that the parabola touches the circle or the sphere or whatever at one single point. All right, so using that, you know, it's good for communication purposes. You know. I did a derivation in the last few months if you're interested, but
even a Glober, George Nekichuk, or whatever his name was, he was you know, he spent years fighting against flat earthers online, and even he said, yeah, look, it for Globers to like squabble over this shit, it's dumb, because 8 inches per mile squared is actually really close, like approximation. Like it's good enough.
But yeah, you know, I don't think Imriel's, you know, questioning the accuracy of the drop over distance formula. I think he's more saying that the Sagitta would be how much the object in the distance would be hidden by, not using the drop over distance calculation.
That's exactly what I meant. Thank you.
All right. Well, that's
not even technically correct. It's not even technically correct. I mean, depending on your, you know, that assumes, you know, you have no elevation. You know what I mean?
Exactly. That's what I said. The height of the observer matters, because you can draw a tangent plane from the observer's eye to the Sagitta.
This is how I explain it. First, you have to find the distance to the horizon. So you got U to the object. What's her name again, dude? Is it Imrael? Give me a distance from U to the object. I'm gonna give you an example. If you use round numbers, it makes it easier.
200 kilometers.
Okay, we're gonna do 200 miles because it's a little bit easier for me. All right. Or you know what? Let's keep it simple. Let's do 100 miles. How about that? Oh, you want 200 miles? Let's see how far.
Because we have an observation.
Right. I got it. He wants the actual example. All right. Give me a second. Let me find out what 200.
Okay, 200 kilometers, 124 miles.
124 and a quarter mile. All right. So what you're going to do is you're going to take the observer height. Do we know the observer height?
Can you repeat your question?
Can you speak about the evidence that you are going to cite?
Look, I told you that I'm not really a mathematician guy, or I'm not really well at understanding all that.
So let me get this right. You don't understand the thing that you're about to give me.
I do.
Can you speak on it then?
I just have to read it first.
Oh, okay. So, bloody hell. Okay. Go and read it then. Drop it in the side chat. And when you understand what you're talking about, we can have a conversation.
And right now, you can say 50 pounds per person. That's 200 pounds per family of 4.
Why do we get Indian call centers jumping? It's just weird, dude. It's not a good start for a conversation where you don't know what you're talking about and that you're going to give me something and say, hey, you can read this, being as you don't actually understand it. Yeah.
Look, next time I'll be here, I'll come with a proof, okay?
Yeah, fine. If you've got an experiment that proves shapes, that'd be great.
Next time I'll see you around here, and I'm gonna prove it to you that Earth is not flat. It's all just a conspiracy.
Ash, specifically,
Okay.
a scientific experiment that proves the shape of the Earth. That's what you said.
Jedi, can you tell him how many times you heard that I will come tomorrow, next week, next month, next?
I'd love to, but I forgot to keep counting, dude. I don't know. It's too many now.
Sorry? Are you asking me anything?
No, I'm telling you, you said Jedi, I will bring tomorrow that proof. And that Jedi heard like at least 1,000 to 7,000 times from other persons.
Don't worry, man. If you want to, I can.
I'm not worried. I heard from 2,000 from 5,000 times.
Do you look? Then you do not believe in science, then, right?
Sorry, hold on.
No, we
Hold on.
that's
Hold on.
holiday.
Hold on.
And right now you can say 50 pounds per person.
Ash, we do.
Do you believe in science?
Yes, we understand what the scientific method is. That's why I asked you a very specific question to provide the scientific experiment that proves the shape of the Earth. If you knew what the scientific method was, you'd understand that that question's malformed. The scientific method doesn't deal with the shapes of objects. That would be geometry. Geometry isn't science. There's no hypothesis in geometry.
Okay. Cool.
So you're not going to be able to give me scientific evidence for the shape of the Earth. Such thing could not exist. You can give me a measurement, though. That'd help.
Okay, then I'll give you some. Okay.
Anything else, Ash?
Nope. You guys continue. I'm doing my research.
Okay, buddy. Thank you for that. We look forward to speaking to you again.
Okay. You too.
That was interesting. Nice example of something that happens every single day.
Is that how they go into like their tests? You know, when they go to a classroom, they go to, they're studying their whole life. Oh wait, I forgot to study. Let me just do the test without studying. Like these people, man.
Oh well, lots of fun. Lots of new people joining as well. Welcome to our event here on the 24/7 Flat Earth channel on the lovely English Hub server. Welcome one and all. Hi.
Conspiracy of the Earth.
Conspiracy of the Earth? What?
That's all I heard. That there's a conspiracy of the Earth. That guy didn't actually say anything. I don't get it.
No, we're saying the Earth is measured flat, so it can't be a sphere. Don't know about conspiracies.
He thinks the flat Earth is a joke and a giant gag, and everyone's laughing. But he's never met people like us, right? People actually looked into it. He's just, gone off of the mainstream. Fortunately, so that's a lot of them.
We got someone in the side chat saying the Gleason map is a concave Earth map with an observer laying down at the South Pole looking up.
Wait, what? That would be another AE map, right? Gleason's. Somebody laying down at the South Pole. So somebody laying down everywhere along the circumference of that map. What?
What do you mean?
Holy shit.
Oh, crap. Justin Bieber's here.
I can sing a song for you.
You got 5 seconds.
It sounds like we got. Yeah, that's time's up. All right. Dong, gong.
Yeah, that's me on mute, unfortunately. Okay. Thank you.
Yeah.
Okay.
Right. Change your name to Bollywood Bieber.
I felt like we just got hit with like some TikTok brain rot music.
Yeah, man.
Yeah. Yeah, that's
Takes me days to get that shit out of my head.
My bad. I should have vetoed that.
That's fine, man. It's what happens to us now, right? When we're bored and we're scrolling through this, that, or the other. YouTube shorts for me. So I'm bored, I just scroll through that, and all of a sudden I don't know, someone's dancing at me. It's some weird tune that I keep hearing all the time. And then I can't get the tune out of my head. So yeah, it's the world we live in now. We're being hypnotized.
Yeah, the subliminal message was go back to the globe.
The subliminal message at the moment is they're going to tell us that aliens are here soon. That's the thing that's going on at the moment, it seems to me. Oh, aliens, they're on their way. We can see them. They're coming.
Where?
There's, apparently, according to our great sky priests, there's an object that's entered our solar system from outside the solar system that's going faster than any object that I've ever seen before entering our solar system, and it's on a direct course with the Earth. It's done things apparently that it shouldn't do according to laws of physics, like change direction by itself, slow down and speed up all by itself without any gravitational influences according to that narrative. But yeah, everyone's pointing up at the sky at the moment to see this A1 Atlas or whatever it's called. I'm not too sure, but it's all over social media. Sky's falling, guys.
Now, how can I see this? All right, not some so-called, people. How about me?
Get a telescope, take a time lapse of this particular region of space, and watch over the time lapse this light move a little bit where the background of lights don't. That's pretty much all it is.
Oh, okay, gotcha.
Yeah, but at the moment, guys, it's this, I don't know, disclosure about aliens and stuff. Now, we've always heard about it, right? It's been going on for years. When will they tell us? When will they obviously tell us the secret that they've been trying to keep for years, that aliens obviously exist? Yeah, they've been pointing up at the sky a lot more recently and saying that there is something out there that it shouldn't be doing the thing that it's doing, and it's coming right here. So, yeah, I don't know.
People talk about Project Bluebeam a lot. I find it interesting that when they show a graphic of whatever that thing in the sky is that doesn't have a tail like a comet, it's blue. Now, that's just coincidental, but I find it interesting. But yeah, no, they're seeming to ramp up something for some reason.
You know, when I was my daughter was younger, I played tricks on my daughter, right? Like, if I'm roboting, let me know. I would tell her to look up in the air, right? Look up at the ceiling, look up in the sky, and and then I'd put a piece of candy on the ground and make it look like magic appeared all of a sudden. So I'm pretty sure that's what's going to happen.
Yeah, I think I understand what you're saying. It's an interesting you brought up Project Bluebeam as well. So I mean, look, we can talk conspiracy all we want, but if there comes a day where there's lots of activity in the sky and we're all perplexed by it, I don't know if I'm going to buy it or not, especially if they're talking about aliens and stuff. Yeah, I definitely wouldn't be buying that story. I mean, where would they come from, right? Yeah, it's not a planet, blah, 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 but the idea of these things in the sky.
Well, it's helpful. So people ask us all the time, how will my life change knowing that the earth is flat? Well, one way is to not be ripped off with all this propaganda. So if you know that this region called outer space, or at least the vacuum of it, and the distances to the stars and galaxies and blah, 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 is all nonsense, then whatever they're telling us about whatever may or may not occur, we can just go, oh, well, that's BS. And you're at least a little bit ahead of the game, not being ripped off by whatever it is they're trying to herd the cattle into.
The video that guy posted about the Gleason being a concave Earth map is kind of funny. If anyone wants a good laugh, the link's there.
Yeah, I figured it would be talked about again. I was going to ask because I came across something on the internet, something about this concave Earth. It's like the third. They're saying it's the third Earth option, and it answers all the questions for flat and round Earth. I guess I didn't even bother.
Yeah. Yeah. It's going to really solve the flat water being flat issue.
It's going to answer all the questions like curvature is. There isn't any. What the fuck?
Yeah, I've always said.
Do they have a reverse curve?
Do what?
I was going to say, does the concave Earthers have a reverse curve of the Earth?
There was one study that apparently had thousands of observations inside of a cave, and there was like a deflection outward instead of, or deflection inward instead of outward. And so that's their evidence for it.
Yeah, they think we live on the inside of a ball, where space is on the inside of a ball. When I look up, I look through space, and Australia is on the other side of space. It's an interesting idea.
I blew Indio's mind, though. I gave him a concept. I said, what if on the concave Earth, right, like we're going to hypothetical, what if on the concave Earth, as you rise in altitude, you yourself shrink, and that lines up with Einstein. And he thought about it. He's like, dude, that just fucking blew my mind. Like the higher up you go, the smaller you get. So you're infinitely getting smaller as you go further and further up. And that's what space is.
Ow. Ow.
So how's it work? If you see a boat sail away, it's sailing upward.
Yeah.
And then if there's someone on the boat looking back at you, they're looking downward, or they're also looking upward. Are you up from them, or are they?
Everyone's up. When you're on the outside of a globe, everyone's down from you. When you're on the inside of a globe, everybody's.
But if you're watching the ship go up, surely that person would have to look down if they're looking back at you. if you're looking at each other through a telescope, right? They're going up. Like you can't both be going up, right?
Yeah, but you are.
Yeah. Good response, Jedi.
Thanks, man.
Got me there.
I've learned a lot from Globers, you see. You can't get out of that one, can you?
Yeah. That's what I was trying to ask them. Like, if you have like a round lake and it's like 10 miles across the lake, right? In any point directly across the lake, and you're zooming in on a person on the other side of the lake, right? Like, how's that work? And the concave Earth's response was that the water's lower in the center of the lake, and it's everyone else is upward from the center of the lake.
Ow.
The water's like lower in the center of the lake than the edges of the lake. And I said, what if there's another lake that's identical to that one next to it?
Yeah, I see where you're going, you bastard.
Rectilineator boys. That's what you need.
All I know, if the aliens attack, I hope Will Smith and Jeff Goldblum are still here to save us.
Jeff Goldblum is still bloody here, for sure. Will Smith isn't in favour these days, so it'll probably be someone else. But definitely got Goldblum, for sure. Can't imagine an alien invasion without Jeff Goldblum, to be honest.
Yeah, it's a dinosaur expert and an alien expert. Come on.
Yep, he's the man.
So if we even get invaded by dinosaurs, his job is secure.
Jeff Goldblum for president.
Isn't he a Ghostbuster too?
Yeah. If he wasn't, he should have been. Surely he was. Or did he look like the guy that he looked like? I can't remember.
Yeah, he looks a little like Egon.
That's his name. Thank you, mate. Yeah, he looks like him.
John Belushi was supposed to be in it though, but he died.
Yeah, I remember that. That was sad when he died. I liked him. It was funny.
Well, Ghostbusters would have made him an absolute superstar. Would have been, it was a big hit.
I miss Chris Farley.
And John Candy.
Another good one.
Planes, Trains and Automobiles is probably still one of my favourite films. I love that movie.
Yeah, that's a great one.
My effing car isn't fucking effing there. I have to walk down the effing highway, come back here and have you smile at my effing face.
The movie that's most analogous to this channel, though, is Groundhog Day. I think it feels like Groundhog Day quite often in here.
Yeah, man, for sure. Groundhog Day mixed with Idiocracy, I think.
Yeah. I was just thinking the same thing.
But John Candy in Planes, Trains and Automobiles was a shower curtain ring salesman. So I think he probably would have had a job at NASA as well on the side, maybe helping to make the lunar lander, possibly.
Well, if it didn't work directly, he definitely supplied them with parts.
Definitely supplied them with parts. Yeah, absolutely.
But why is everybody on mute?
The guy got emotional yesterday about too many of us being on mute.
That Peter guy. So
I don't remember their names. Rings a bell.
Quasimodo?
All right, Dad. Fucking off. It's a good.
I just remember them all as Jagdish. Like, oh, it's Jagdish. He's in here.
Welcome, A. Welcome to the channel. And Ash. Is that the same Ash that we spoke to earlier? Welcome. Ash? Hello? Welcome. Oh, and they go.
Let me out. Oh. Back again.
Oh, Ash is back. Welcome back, Ash.
You have to ask yourself if Ash is having some microphone issues, because we know you've unmuted your microphone, mate, but we definitely can't hear anything if you're trying to say anything.
I think this is a new Ash. It's a different profile picture.
Oh, awesome.
That stuff is flat.
Pyro, welcome back.
We don't have time for a meeting of the Flat Earth Society.
Welcome back, Cairo.
Hello.
What's going on, man? What brings you back here again?
Yeah, I just want to listen what you guys are talking right now.
Excellent. I like your accent.
Thank you.
Well, if you have any questions, Cairo, then we can give you something to listen to.
No, I already have been to this like chat before.
All
So
right, I
now
see.
don't
That's fine.
What?
Okay. No, that's okay. Yeah, I can see you've joined before.
Yeah.
We were notified. It said Cairo has arrived back again.
Oh, I don't know about it. Like,
I got a question. What have you learned about flat Earth, Cairo?
yeah, like I have learned about like one guy was there. He was saying like how we have atmosphere if the Earth is round. So it's a fair point. Like, if we are in vacuum, why we have atmosphere?
Oh, cool. You've been listening. Nice.
Yeah. So maybe Earth is like something like a box or maybe a container. That's why we have atmosphere. Maybe. If
Yeah,
I'm
well,
not wrong.
usually if you have like a gas pressure, usually there's a container present, right, to have the gas pressure. And if you look up the definition of gas pressure, yeah, it says that you need a container to have gas pressure. So that's why we say like it would have to be some kind of contained system that we live in.
Yeah, because in vacuum we can't have like atmosphere.
Right. Even look at what happens to when you put water inside of a vacuum chamber. It just turns to steam. Yeah.
Yeah, I've seen some videos.
Well, it's good that you were thinking about it. And then we also have long distance observations where we don't have any curvature over huge distances. So over the surface of water, you know, we can look over 40 kilometers and it's completely flat. We can validate that using lasers and using different types of optics.
Yeah, like
But we don't claim to know the shape of the Earth, right? We're just talking about the surface of the Earth not having any curvature that we can validate, right? Not the overall shape, right?
okay, so you mean what the shape of Earth? You don't know the shape of Earth, like
No. I don't think anybody knows the shape of the Earth.
Yeah, like
the Earth
yeah,
is
you
Earth
are right. You can't know where we live, like
because we can only get up so high into the air, you know, and when we get up as high as we can get, we can only see, you know, a certain distance away. So it's also very difficult to explore. If you keep going south, it's very difficult to freely explore. Difficult for many reasons, difficult for legal reasons, and also just difficult in general to you know, to actually go to those very dangerous areas.
Yes, it's lethally cold down there.
Yep.
yeah.
Like obviously the Earth is round because during like lunar, eclipse, you can see the moon like curve. Like you can see the curve on the moon. That's the shadow of the Earth, and obviously that states that the Earth is round. Like it's
during Cenillian eclipses.
I'm sorry, what?
You mean like during a Stellarian eclipse, where the sun and the moon are both visible in the sky at the same time?
No, yeah, it's when the Earth is between the moon and the sun, and when you see like the moon, like when you see the shadow on the moon, it's obviously taking part of the moon like as curve, like it's curves the moon like the shadow.
Completely disavow. Completely disavow. I mean, think about what you're saying, though. You're saying that something in the sky above your head is being blocked. And the thing that's doing it just so happens to be the thing underneath you, the ground. So you look down, you see the ground, and you look up and see the moon, and the moon's being blocked by the ground. That literally doesn't even make any sense.
I still don't get your point.
Okay. All right. So you look up and see the moon is being quote unquote blocked. Right?
Exactly.
Okay. So the thing you're saying is blocking it is the ground underneath you.
So stupid.
That literally that doesn't make any sense at all. Again, the ground below you, you're looking down at the ground. It's underneath your feet. And you look up in the sky and see the moon. You think it's being blocked. And you're saying the thing that's blocking it is the ground. That doesn't make any sense, bro.
Why not?
I mean, I don't how to spell it out any clearer for you. The ground is underneath you. So you're looking up in the sky at the moon, and you're saying it's being blocked by the ground. That's can I say retarded? Like that's retarded. That doesn't make any sense.
But you gotta like explain how lunars happen. Like how
No, I don't have to explain it. I don't have to.
How the shadow.
I don't even agree that it's a shadow. I don't even agree.
What is it then? What is it? Go ahead. So you're saying it's not.
I don't think anyone in human history has ever known what the moon even is.
Like you can't even say I'm retarded if you can't explain.
I wouldn't say you're retarded. I'm just saying that idea that the ground is blocking your view of something in the sky. That's very silly.
So the sun is shining.
There's a lot of evidence in science saying the Earth is circular. We cannot depends on just what we are saying. What we are seeing.
Okay.
Because we are consciousness. We gotta limit it. You know what I mean? So you should depends on the evidence and what the science saying.
Yeah, they're not believing it, but I also want to say something that the moon only shines because of the sun. The sun.
I completely disagree with that.
Oh my god. Okay. If that's
for starters, based off observation, it doesn't even look like that. That's a story that you've been told. I used to believe that like you do, but when you actually take the time to go out into reality and observe the moon, it definitely doesn't seem that way. That's a really good story. That it's just like a dusty rock, and the only reason it's lit up is because of the sun. I think that's really, really silly. It clearly does not look like that. I mean, do you ever even look at the moon, bro?
Explain the shadow then.
I don't even agree that it's a shadow.
Oh, I don't think so.
There's nothing to explain. I don't know what the moon even is.
It just depends on what you're seeing in your eyes. Because the people, when we're living in the old century, they're saying a lot of myth. But
but we're not doing that. We're not doing that.
Yes, you do, because you just think on seeing your moon and the thing. You can depend on what you're seeing. It's not
Well, we're not making up myths and stories. There's not a single flat earther in here that's going to be like, yeah, the moon is this and it does this and the other. The truth is, no one knows what the moon even is in the first place. So I don't agree that it's a shadow. I don't agree that it's a rock that's being lit up by the sun.
Okay, if you don't know,
those are the myths. Those are the myths.
So you don't believe that Earth is round, neither is flat.
I don't know.
Okay,
Yeah, well, that's something you can
a better
actually test
answer.
and measure. That's something you can test and measure, and the moon doesn't have anything to
So
do
you
with
think there's a plot by the government or some things making on the people?
Bro, that's just cope. We don't care about like that aspect of like, well, who could have who done it? It doesn't matter. The Earth is like measurably flat, so it how you deal
Okay, so
with
you
that
agree
and
it's
who
flat.
told you
So you agree
stories
it's
like
flat.
that's on you, bro. That's cope for you, but
Wait, you agree it's flat? I didn't catch it.
100% it's flat. Yep.
Okay, just a second ago,
But in the end, you don't have the physical evidence to.
No, we do. We do have
proving
evidence.
you.
Yep.
What? You
Who
have
told you there?
anything?
Yeah, of course. Who told you there wasn't evidence? Why would we? Why would it be flat earthers based on no evidence?
What
Do
is
we look
your
like some
evidence?
globe earthers in here? What is the evidence? Well, there's observations, laser tests. I mean, the physical nature of water. How many more do you want?
I don't think so because I said you can depend on your consciousness.
No,
We
it
got
doesn't
a
depend on
limited
consciousness. It depends on how water behaves. It doesn't have anything. I could be blind. I could be dead. The behavior of water is never going to change. It doesn't have anything to do with my consciousness. It's the like it's how nature behaves, basically.
I
You
disagree.
mean if the Earth is like
He said that's retarded. How's that retarded? If the ocean, if all bodies of water, hold on, if all bodies of water are flat, that has nothing to do with my consciousness. That's not retarded. That's just how reality is.
Yes.
I disagree with that.
Okay, so there's only two options here for how water, the surface of a body of water, can only be one of two options. It's either curving or it's not.
No,
Period.
I disagree with your idea of the Earth being flat.
Okay, well, you probably don't know what that position involves, so you just.
Why isn't the Earth triangle?
Relax.
Earth is not flat. It's
All right, here comes the G code. But anyway, the surface of a body of water has only two options. It's either curving or that's it. There's no other way around that. And so if the surface of the body of water is not curving, it's flat,
Have you ever
period.
seen a ship sailing on
How
the
are you gonna notice it?
Yeah,
if it's
on
curving or
flat
not?
water. Yes, of course I've seen ships.
How are you
I go to the
how are you
ocean
gonna
like every
notice
day,
it?
probably.
How are you gonna notice if it's curved or not?
Well,
Like, it's so vast.
Here's the thing.
You're not
Here's the
gonna
thing.
even-
Here's the thing. All bodies of water behave the same. So, like, what if a swimming pool is flat?
comparing
Then the
a
lake
small
is
amount.
flat. Then hold on. We're talking about bodies of water. So, something you can put your body in, at least, like a bathtub, swimming pool, pond, lake, sea, bay, ocean. I would say all of those behave the same. So of course I can't see the whole ocean in one shot, but I can see a swimming pool in one shot. I can see a bathtub in one shot, and it's 100% flat at the surface. And all bodies of water behave the same.
You're
What's
saying
going on with the
if the Earth was curved, the water should be curved.
That's crazy.
Man, the cope is real.
What's going on with the cope right now?
Is he saying that if the Earth is curved, the water should be curved, and that's laughable? Is that what he's saying? Badass. So why would the water not be curving along with the curvature of the Earth?
Because it's not the same. Like it's not the same measure, obviously. Like, you
What's the
can't
measurement?
compare-
then?
Okay, let's say we're talking about
That's all I want to know. Badass, that's all I want to know. What is the measurement then? What is the measurement? Badass, let's talk about the ocean.
A vast.
Badass, I really don't want to mute you. You made a claim. Tell me about the measurement. What is the ocean supposed to measure?
Are you gonna be like observing the ocean from above, and you're gonna see it like?
No.
should be
You
completely
made the
flat?
claim.
No.
I want to know.
Okay, I can answer.
I want to know.
answer.
Okay, so
you're
how does the ocean behave? What is the
moving from one
measurement of the ocean?
You're moving from one point to another in the ocean. Okay.
Moving or looking?
No. Well, let us say you're moving.
Why are we moving?
Why are we moving?
We're measuring the ocean, dude.
Okay, I'm giving you an example.
Okay, so distance is this
You're
distance
gonna see.
linear?
You're gonna listen. You're gonna see.
Badass, is the distance that we're traveling, is it linear?
What? No.
No, it's not. Okay, so if it's not a linear distance, then tell me how you compute or calculate this distance.
Wait, but did he say that on a globe the water would be flat? Like, we could throw
he
the
said
whole
that.
traveling anywhere thing out the window. That's completely ridiculous that he said that on a globe or on a sphere the water would be flat. That's absolutely ridiculous. And in fact, thank you, it is flat. You're right. In reality. So welcome to Flat Earth.
So you're saying that 70% of your ball is flat?
You just say that's retarded? How? So on a ball with okay, wait. Let's look at pictures from space. Does that show you flat water, ding dong? Yeah, I didn't think so.
He ran away.
Yeah, he's a retard. So who's next?
So who says that the Earth is flat?
Damn near everybody in here. Actually, yeah, you're right, Sasha. The Earth says that.
Water, Earth is saying that.
Like, there's so much people that believe in that.
Do you think that water is lying?
Oh, you believe in the ocean?
I can't believe there are so many people that believe that they're on a spinning water ball in a vacuum. That sounds ridiculous to me.
Bro, the sun is Earth.
The sun is Earth?
Why would the...
He said the sun is curved. Yeah, well,
the sun is curved.
For you. The sun isn't like the Earth in any way, shape, or form. So what else you got?
The moon.
The moon isn't like the Earth in any way, shape, or form. So what else?
You can see in the sky that there's a circle. It's called the moon.
Okay, cool. Yeah, I see clouds in the sky also. Is the Earth a cloud? No. So the things in the sky are not the Earth.
Oh, but clouds are not planets.
Yeah, the Earth isn't a planet either. So here's the thing: the Earth isn't like anything in the sky.
Yeah.
I look up and I see planets, I see stars, I see the sun and the moon. The Earth isn't like those things in any way. And there's not a single resemblance. I look around the Earth, I'm seeing trees and water and people and things. None of those things exist in the sky. There's really no reason to compare the Earth to anything in the sky. So cool. The moon can be a circle. It can be whatever you want. It's just not going to change the Earth.
Hey, flat earther.
Do you believe that for example, Jupiter is a planet?
The Earth is not a planet. The Earth is not a planet, and we're also not in outer space. So
how can you
it's not that there's a bunch of balls in space and then one flat thing. Like, that's not our position. So there's that.
Can you define
Do you know what lunar eclipse is?
What's the planet?
Lunar eclipse. Do you know what that is?
Yeah, that's your idea. Your idea of the lunar eclipse is that the moon is being blocked by the ground, which we just covered. That's retarded.
What? So
crazy.
if there was no, if the Earth was flat, there wouldn't be no lunar eclipse or solar eclipse.
No, dude, sorry.
Lunar eclipse happens. Lunar eclipse.
You don't know what flat Earth is. You're not in a position to be telling us what flat Earth should or could or would be. You don't know what flat Earth is, so don't tell us what it should do.
That's great.
Whatever is happening on the Earth is.
I'm telling you that the Earth is not flat. It's.
You don't know what that means.
It's failed.
You don't know what that means, dude. Go ahead.
It's
measurably flat.
You don't know what you're talking about.
You said
you listen to some people.
No, I've done it myself.
No, we listen to the Earth.
You come here and you are telling us that Earth is flat. That's ridiculous. Your idea is ridiculous, not ours.
It's like this.
No, your idea is ridiculous.
Talking, dude.
No, your idea is.
First of all, you're just going to
the fact.
You don't want to
accept
keep talking.
Earth is.
Shut up.
There are hundreds and thousands of proofs.
Shut up.
Okay, but you can't give us one.
Carry on.
To Ted, shut up. First of all, you don't know me. You don't know what I've done, or even if I've done anything ascribed to YouTube. I know the Earth is flat because I know how the Earth is measured. I measure the Earth flat every day. So do you. We all measure the Earth flat.
So do you know who Arthur Thinis is?
What?
Here we go.
Arrow.
Do you want to
Theories, I think
respond
it was
to
his
what
name.
Jedi said
He was a
in good faith?
look. He was a mathematician or he was the guy who was dealing in geometry at that time around 240 BC.
Oh,
So he
gematria.
did that
Okay, 33.
Look,
Geometry.
he did
He's
that
talking about
experiment
he's
to show
doing
that the Earth is round.
shadow angles.
Anyway,
Sorry, dude.
anyway,
Excuse me. If I stick a stick in the floor and there's a light source that casts a shadow, does that mean that my surface has to be curved?
yeah.
Clown.
So if I've got a table and I've got my sauces, my tomato ketchup and my salad cream and my mayonnaise, different points on the table, but the light is directly over the middle of the table, you know that they're going to cast shadows on the flat surface. Hello? Man, he was speaking about Aristophanes. He's talking about geometry. Did it, 1400 BC or whatever number you pulled out your backside? He measured the length of a shadow and the angle at the top of the stick from the imaginary hypotenuse. Do you know your own story, dude? I'm talking to you.
Yeah, I'm listening.
Good. So you can cast shadows on any surface.
Yes.
Good. Can you measure angles with any surface?
You can.
Can you measure angles with any side or surface?
If you're casting a shadow, then you can. If there is a shadow, you can measure that.
Can you measure an angle if one of the sides is curved?
I don't follow. I don't get it.
Got him.
Right. So Aristophanes, he measured angles. That was the measurement he took, produced by the stick and the shadow.
Yes.
It's an angle measurement. An angle is defined as the intersection of two straight sides. If the surface of the Earth was curved, a curved side, could you measure an angle if one of the lines is curved?
But how tall?
I'm asking up here.
Earth is so big. Very. You measure an angle.
There's two sticks in the floor that are a distance apart. Hold on, shush. There are two sticks in the floor. Depending on what story you listen to, one of the sticks could be a well. The well or the stick is directly underneath the sun. He buggers off 500 stages and puts another stick in the floor. So there's a distance between two sticks along the surface of the Earth.
Right, so
you can measure an angle with a curved side.
Can you take a 10,000 miles?
Can you measure an angle if one of your lines is curved?
But what does the angle have to do with the?
Because Aristophanes was measuring angles, mister.
I mean, you
can
measure the angle, but it depends on the stick.
Depends on the stick. It depends on the sides of the triangle that he's creating. He's got a stick and a shadow and an imaginary line between the top of the stick and the end of the shadow. That's called a hypotenuse. This is a right angle triangle. He's also created a larger triangle with two sticks in the floor and the sun above one of the sticks. It's 90 degrees underneath the sun because the sun is at the well or sixth zenith. That's 90 degrees. The other stick is 500 stages away. Or to be more accurate, 483 miles. We know that distance because we can subtract the 7-degree angle measured at the top of the stick from 90 and then multiply it by 60 and we get 483 miles. It's a straight line distance between both sticks on the floor. So where's measuring the curvature of the Earth?
He's talking about
Aristophanes.
Like I said, it's all about the tall of the stick.
So it's all about how tall the stick is, guys.
I mean, the
This is too advanced, bro. These guys brought up their own proofsies and don't know anything about it. You're getting slapped around on your own proofsies here.
The Earth is so big that the surface angle.
We could probably just roast you by asking you how big and see how long it takes you to answer that question. How big is it?
Why would I answer that? I'm looking at this.
Because you don't know. You shouldn't be saying things like it's so big and you don't know how big it is, dude.
In 1,000 miles, I'll say that it's still so big, and it's not compared to
how big
Earth.
is it? How big is it?
Oh, let's search it up.
So let's search it up. He says, dude, you shouldn't be saying things that you don't know to be true.
Yeah, I don't know about this. I'm just a person.
Yeah, so don't say it, bro.
I'm just saying while I
1,000 miles is 24 parts of the Earth.
Okay.
I have to wonder who walks into a boxing ring and doesn't know how to box, and then tells his opponent, oh, "Hold on a minute, I'm just going to learn how to throw punches."
500 million kilometers.
What are the rules of this game that I'm playing?
What the hell?
What?
So let's say.
Yeah, bro. You need to tag out, bro. Like for real.
Like nothing compared to 500 million kilometers. So in this you will
What are you talking about, man?
This is actually bigger and only bigger than actual Earth size.
Oh,
you don't know what Earth size is, dude.
This is so clear. I don't know what y'all are actually talking about.
Man, you're
trying to go against what Jedi's telling you by saying, well, just the Earth is big. You don't even know how big it is.
Why can I not understand what you're saying? Because you're saying dumb shit.
You said 1,000 miles. Now you need to finish the circle. The other 23,000, not millions, 23,000 miles, and then you have the Earth.
But if I check the SIG, that is actually taller than.
And did you hear me? It's almost 25,000 miles. That means 1,000 miles, then more 24 more 1,000 miles, and then you finish the circle of the Earth. That's how big Earth is, not millions.
I'm trying to figure out.
Talking about.
I've got to ask, what's the relevance of the size of the stick?
I say
pause.
Not per, or what's called. I was talking about the air first.
What the fuck?
That's so fast.
Air surface.
Doesn't even sound like the first guy we were talking to. He sounds like something different now. He sounds that lost.
All right, let's see. What can I say?
Yeah, that's pretty bad, Jedi. Where'd the guy go that said there's a million proofs, and their best foot forward is, well, we put a stick in the ground. Holy smokes, dude!
So how long is the actual Earth if she's flat?
Don't know.
No idea.
What's the surface of something that's flat in 2D dimensions? It's not 3 dimensions, right?
What do you mean it's not 3 dimensions? You ever swum in the ocean?
I mean, if it's flat, then it's like 2 dimensions, right?
No.
Be a surface description. The surface of the Earth is primarily.
What's the actual surface? What's the area of the Earth?
Obviously, have a misunderstanding. I'm trying to help you. Probably not going to help if you keep talking.
All right, talk.
Okay, so the surface of the Earth is primarily water, right? The seas and the oceans. The surface of the water, when contained and at rest, lays horizontally on the surface. Now, we obviously have elevation. You're standing on land, which for the most part is above sea level, like mountains and stuff. And we obviously have a seabed under the ocean, and then the depth of the rock beneath. So obviously the world is 3-dimensional. You are 3-dimensional objects occupying 3-dimensional space. The surface description of the Earth is flat.
So does that mean like 2D?
That's crazy.
That's crazy. Man who thinks that the world that he occupies is 2-dimensional. him a three-dimensional being. So, whoa, dude.
The globe's getting cooked on a live stream right now. Oh, bowling.
Funny, bro.
So, like, sorry for interrupting. How does the sun move?
How?
Like in the circle, in the
Jesus
flat
Christ.
plane,
Yeah, I
the earth?
don't know the exact paths of the sun, the mechanism which it takes. The paths will probably be best described as circular paths, but the sun doesn't follow the same path, obviously, every day. So, yeah, the sun moves across the earth in what appears to be circular type patterns.
It can be any shape, not circle.
What? What? The sun? What can be any shape?
Like, when the sun moves, where somewhere it's a winter and somewhere it's a summer.
Yeah, this is dictated by how much of the sun is in the sky. That's what summer and winter are. Summer is defined as when the sun is highest in the sky and you have more daylight. Winter is where the sun is lower in the sky and you have less daylight.
So, like, opposite seasons happening at the same time.
Not at the same time, the sun moves. So north or south of the equator, it's only summer north of the equator, and then it'll be winter south of the equator. You can observe this in the north and in the south. And that's the path of the sun, moving north of the equator for summer in the north, leaving its distance and heat further away from the south. And then over 6 months, it moves back over towards the south. It'll be summer in the south, and it'll be winter in the north.
It's a flat. How does your imagining?
If Earth is flat, how the surface would look like?
Just like
Ash,
flat.
if Earth is sphere, how the surface would look like?
If Earth is what?
Sphere, globe, ball. How the
Okay.
surface would look like?
Oh, it would be like curve.
Okay, now we have two things, flat or curved. How we will realize is it curved or flat or flat?
Well, there will be somewhere the bend, right?
Yeah.
So we think that it's a bend, but it's not bend. It's a flat.
Yeah.
Okay.
I talked about this with one of my friends, and they think I'm hilarious. Like, they weren't believing me when I told them this thing to them.
Yeah, simple.
It's not that they don't believe you. It's because when you question their belief, they are reacting to you emotionally, and they're dropping logic and common sense to the garbage, and they're basically just going back in what they believe and projecting that into you. You don't believe what we believe. You're questioning, but they don't know that. They're just laughing at you because you're trying to present to them that the facts is that the earth is not curving, right? You said you described it as flat, and you're acknowledging that and telling them, hey, the earth is not curving, but in their mind, they're seeing the TV and the imagery that they saw in the movies, and they know the Earth is this thing in the TV, and it's curving, it's a ball, and that's why they're laughing at you because you're not saying what the TV said. So, but for them to realize, they will have to go and check their belief and verify if their belief is correct, and then check themselves. And when they check and they falsify their belief, they're gonna come to realize that what they believed, it's not so.
So their belief is very strong that at one point maybe then that the fact
It is a strong belief, yes,
they are not even trying to get out of the box. They are not trying to think out of the box.
Well, yeah. I mean, some people, inside the box is comfortable, and they don't want to be the ones that they don't want to be, in a sense, think about it. They don't want to be like in your position. They don't want other people to be laughing at them, right? They're laughing at you, and they want to be on that side of the fence, pointing the finger, ha ha ha. They might be scared of realizing something. But it's mostly ignorance about the topic. Like you heard a guy earlier saying, Earth is too big, that's why it's flat. You see, he said it's too big. We don't see the curvature because it's too big. And then the guy asked him, CB asked him, but how big it is? I don't know. Let me check. You see?
I said curved, so big that it was curved. I didn't say that it was flat.
Exactly, but you said what you're saying is wrong. The other guy was trying to explain you something about angles and the measurement of the angles and what can you conclude about that? And you were saying, but Earth too big.
No,
but you don't know how big it is.
I was saying, how can you measure an angle if you have a small stick?
You do measure the angles from the shadows, right? And from the sticks, but that's not the point. The thing is that you are ignoring what is being said to you by claiming something that you don't have no idea what that even means and coming to a conclusion based on your ignorance about the topic. That's where the problem lies.
I said that in my place, I'll see the Earth flat. But if I take a long distance and I measure the angle with the long stick, then I would see that there's a curve. That was my point, actually.
Jera, you want to touch back in this point? Is anybody there that want to bring back to this point? Because I'll take it.
You take it, man. I wasn't listening hard.
No, the guy asking about the shadow of the angles and what does that mean actually when they're applying these measurements of the shadows and what conclusion people comes to about it.
Yeah, you got it, man. You take it.
So it will be an inconclusive about the surface of the Earth because you're measuring angles, right? And it's not gonna give you the shape of the ground of the whole of the Earth, right? When you're measuring these angles to the shadow, you're saying if the stick was long enough and the shadow was long enough, that shadow will be curving with the Earth. That's what you're saying, right, dude?
Yeah.
Yeah, but that's not the case because when we measure the Earth across distances, bodies of water, there's no drop over distance that will be required on a curving surface. So the angle that you're measuring at your local area, and then in the next step, those angles are not giving you any curvature of the Earth at all. You're not concluding. You're not concluding Earth is curving at a certain rate based on the measurement of these angles, these shadows. That's not a conclusion that you can come about.
No.
What was that?
They say that we transform, like you transform to a small, very small thing, right? So let's say that I have a ball in my hand, and I actually put a camera that is actually extremely small towards this above this actual ball that is curved, because I know that it's curved. And what would you see? You'll see that there is a big land that is actually flat. You see it flat, but because you are very small. But if you zoom out, you'll see that the ball is actually angled and actually curved.
Would you be able to measure that curvature over distance, do you think?
Yeah.
Okay. So
why does this not happen? Actually, doesn't happen in what we are speaking right now, the Earth. Let's say hypothetically that the Earth is curved. Why can't we think about like that?
Because it's a hypothetical.
It's not hypothetical. It's proven.
It is until it's proven.
Yeah, if you prove something wrong, if you prove the wrong of the wrong, then you will have the fact.
How would you prove the dimension of the surface of the
What happened? What happened to that guy? Did he just leave or what?
I don't know. Hey, I don't know where he's at. But I have another point. What about day and night?
I don't know what's happening.
It was the kind of the science question we had in the classes in the air, like why do two sticks placed under the kilometer apart the cast shadow at a different angle at the same time, and why they should be exactly the same? That was he was asking to, like he was asking the curvature.
if you move a stick from outwards from directly underneath a light source, like if you were to walk from being underneath a light to not being underneath a light, you'd watch your shadow increase in front of you, wouldn't you? So you could literally put two sticks in the floor, one underneath a light source, let's call it the sun, and it would cast no shadow. If you were then not underneath the sun, then the stick would cast a shadow because of the angle to the sun.
You know what I trip out on is how even to this day, bro, they still bring up the Eratosthenes thing, and it's like it's so ridiculous, dude. It's just.
Bro, this I get it. It is ridiculous, but there's new people like this lady that's asking question that they're trying to explore it, and yet I explaining to them so they can comprehend it. It's okay. It is ridiculous. It is kind of ridiculous, but it's okay. It's part of the territory, bro. You know this.
Yeah, I know.
Can I add the point, please?
What's your point, my friend?
I'm talking about day and night.
Mm-hmm.
So let's say like this the fact that, like, for example, in New York, if it's daytime, then in Tokyo it's nighttime, right?
Mm-hmm.
But the Earth was
Did you ask this question from ChatGPT? Right.
Anyway,
one of my friends did when I was telling them that Earth is flat, and they asked this question, and they asked me that same question there. When I asked them where did the question get from, they all said we just asked it from ChatGPT.
Nice. Can I ask the question now?
Yeah.
Yes,
sorry.
you can.
So if the Earth was actually flat, does that mean that we have a same day and night cycle, and there's no delay between the places?
No. The Earth is flat and the sun moves across the Earth. So when, for example, it's noon in New York, that means the sun is pretty much 90 degrees above the south in the sky.
Right, that's directly more or less up on that line of longitude. It's high in the sky for them. For me in England, from my point of view, it's lower in the sky for me towards the east. For people that are further, in the west, for people that are further east, let's say in the Middle East, the sun will be much lower on the horizon. It's how perspective works. You notice the same thing with any light bulb that you see that's above your eye line. As you walk away from it, it appears to get closer to the floor.
So for you, it's all perspective. So that means that the sun is actually turning around the Earth.
Yeah, the sun has paths across the Earth.
How can you prove that?
Go on, what's your question?
How can you prove that scientifically without a perspective?
I wouldn't be able to prove it scientifically. I'm not looking for I'm just observing what the sun does. So observably, the sun takes circular paths around the Earth.
If it's all perspective and there is no science actually proved, then
It's
how
not a
would
scientific question. Science deals with causes of phenomena. At the moment, we're trying to figure out the path of an object. It's not the method. You wouldn't use the scientific method to answer this type of question. We'll answer the question another way. We can measure it, for example.
So all your proofs are based on your perspective and what you're seeing.
Yeah. And based on that perspective, we can observe the sun, for example, be above the horizon for 24 hours in the north in the summer. For 3 months of the year, the sun is above the horizon, circling around any observer who's inside the Arctic Circle. Conversely, 6 months later in the summer in the south, any observer standing inside the Antarctic Circle can see the sun above the horizon for 3 months. Again, the 24-hour sun.
Yeah, this corresponds with the solar analemma. So if you want to look up solar analemma, what he's saying right now corresponds with that. So it's an observation that anyone can make.
So you all believe that the Earth is flat, and at the same time you believe that Earth is the center of the universe.
More like the floor. But yeah, it's kind of centralized on us. We're the only Earth at the sky are in the sky. So yeah, the Earth is a floor. It's not a disk orbiting around the sun. It's not a ball orbiting around the sun. The Earth is the floor and the lights are in the heaven.
That's crazy.
Obviously so.
It's crazy. That's crazy. Yeah, we know it sounds crazy.
I mean, it's pretty obvious.
You haven't experienced anything else other than a flat stationary plane.
And it's not obvious, though.
It is. All right, let me ask you two questions. Do you feel or sense the motion of the Earth?
No, because
okay, sorry, dude, please. So in that instance, the motion of the Earth isn't obvious to you. Okay, next question. From your vantage point on the Earth, do you see the curvature of the Earth?
What?
On the surface of the Earth where you live, do you see the curvature of the Earth?
Yes, I see it.
Where do you see the curvature of the Earth, dude?
When I look at the ocean, I see that it's...
You see what?
When I go up on a mountain, I say that places go farther away. So that means...
Okay, that's because you've gone up a mountain, dude. It's like literally stand up and you can see more of the floor because you've increased the ability to resolve the angle by changing yours.
If the Earth was flat...
No, dude, excuse me. Don't want to be rude, mate, but you said it was obvious. First question I asked you, is it obvious if the Earth is moving? No, I don't feel that. And now you don't understand perspective. You said climb a mountain and you can see further. Yeah, that doesn't mean that the surface of the Earth that you're looking over can only be spherical.
You understand what I said when I was talking about the mountain, though?
What, you said you could see further.
Yeah, because when I go up, I see places farther away, but when I'm down, I don't see the same.
You didn't hear what I said, so this is going to become frustrating. I'll do it again. It's like standing up and being able to resolve more of the floor that you are standing on with distance because you've increased the angle.
Yeah,
Same
because
thing applies to climbing the tree, going to the top of the Burj Khalifa, climbing a mountain, getting into an aeroplane. With the change in height, you're going to be able to resolve more of the surface that you were looking across.
yes, but if the Earth was flat, then I don't need to go up.
Why? Okay, so you don't understand how perspective works. So do you understand things with distance reduce in angular size? For example, that mountain that's far away looks really, really small, but the mountain I'm standing on looks really, really big.
Yeah.
Think you should be able to resolve everything, do you?
But that's
even though things obviously with distance get smaller.
That's all about my vision power. If we take
At the moment we're making observations, it's most definitely going to be talking about your vision.
Well, you actually speaking just about your what you're seeing with your eyes.
At the moment, we were trying to figure out if it was obvious. So far, you haven't demonstrated to me that it's obvious. You've only demonstrated.
I've never said that the Earth curved is obvious. I only said.
You just said it was obvious. That's why I asked you those two very questions.
That it was not obvious that the Earth was flat.
Sorry, it's not obvious that the Earth is a rotating sphere. Don't feel any motion, and you haven't shown me curvature. Just you not understanding how your eyes work.
I mean, with my eyes, I've already seen curvature.
Really? Where?
In the ocean. When I look at the ocean.
Again, so back to this example. I'm going to be clearer. Are you talking about left to right curvature or curvature away from your observation, downwards?
Oh, I cannot see that because the Earth is curved.
You can't see that?
I cannot, of course, because it's hidden. I gotta go there.
What the fuck is he talking about? Do you understand the words that are coming out of my mouth? Because I definitely am starting to misunderstand you.
Do you put a hypothetical of the Earth?
No.
Why can't you say that if the Earth was curved, what would I see?
Yeah, how could he see if the Earth is curved? Even the light couldn't pass through it. You know,
Yeah,
you
you
can
guys aren't understanding. The question, hold on. The question was, can you see Earth curvature? Yes or no? Yes or
yes, many astronauts have
Okay, hold
seen
on.
through
I'm
the
talking
space.
to you, sir. We're talking to the gentleman. So the guy was answering Jedi. If he saw curvature, yes or no? Not you. The first guy.
I would go to space and I would look at the Earth and I would see the curvature.
No, sir. No, sir. He said from your vantage point, which means on Earth, do you see the curvature?
Of course not.
Right.
Thank you.
So
well, I can
it's
see
not
from
obvious.
I can see it from the sides, though.
Sorry, it's not obvious then.
No, it's not obvious. I've never seen that it was obvious, but it's not obvious too. So you're saying that if you look at the Earth, then it's obvious that it's flat. That's what you believe.
Yeah.
And I feel that it's not obvious, so it's actually not.
It is. Sorry, you know that water is obviously flat on the surface. Water, when you put it in a bucket, when you put it in a bath, it's flat on the surface when it's at rest, isn't it?
Yeah, because of gravity.
No. It's flat. Gravity would curve the surface. That would not be a straight line. A straight line would be, I don't know, a flat one.
I know that.
Okay. So water, listen, is flat upon the surface. Over 70% of the surface of the Earth is water. Therefore, the Earth can only be flat upon the surface.
There is something like called gravity, I think so.
Yeah, that would curve the water.
Because there's gravity.
But the water is flat.
Because there's gravity.
Oh, so the gravity makes things flat, which would be vertical, perpendicular to the horizontal plane of the Earth. Welcome to Flat Earth, my friend. Hallelujah.
Oh my days.
So you understand what vertical is, don't you? You understand what perpendicular is, don't you? You understand what horizontal is, don't you? You're saying that gravity makes things horizontal. Flat.
But the water is not the earth.
No, the water is 70% of the Earth's surface.
But it's not
sea level. The 0 point where you're going to get the elevation of the mountain.
It's not the same.
Climb.
It's a liquid, and earth is solid.
Sorry, does the liquid have a surface?
Do we live in the liquid?
Excuse me? Does the liquid have a surface?
No.
No, the liquid doesn't have a surface.
Oh,
so
no.
drink your
Come
cup
on,
of
man.
coffee in the morning. Oh my God, can I not have a conversation?
Well, what does surface mean? Is
surface?
That the air? I was talking about the air, though.
No, we're talking about the surface of water.
Oh, the surface of water. Yeah, it exists.
Yeah, it's horizontal on the surface, isn't it?
The volume of the water. That's what I was talking about.
When contained and at rest, water is horizontal on the surface, isn't it?
But if there's no gravity, then...
No, we always have gravity, dude. Here on the Earth, where the water is, it's horizontal.
You're saying that in space, there is gravity?
No, I'm saying on the Earth, where all the gravity is, the water is horizontal on the surface. How many times do I say this for you to understand? Shall I write it down and post it in the chat?
Earth is not in space. You're saying that Earth is not in space, right? If you take water in space where there's no gravity, then it will be curved. And Earth is in space. That means that Earth is curved, right?
Yeah,
water in outer.
How do you know that, man? You're just making a whole bunch of claims. You don't know that.
Because that's science, no?
No, one word science what does that mean? You don't. The lack of comprehension that you guys have. Oh my days.
I mean, have you ever? Let's see. Have you ever?
You've already heard him say that the Earth is not in outer space; it's the floor of everything that you know. So you're going against and gaslighting either your audience or our audience.
If you take water and you pour it from, for example, what shape would it take?
Well, guys, the issue he's having, he said water in outer space. There's no such a thing.
Oh, wait, let's see.
That's what I said. He's just making a whole bunch of claims and then imagining something.
You know that water in a vacuum evaporates, right? You know that?
What?
Water in a vacuum is not water anymore.
It's gas.
Exactly. And you say water in outer space.
And it's
that's
all about
not a thing. That doesn't happen.
Sure.
Yeah, but we have water in reality. We have water in reality. So therefore, we have a pressurized system which requires containment. We have gas pressure, water in the liquid state, and then the antecedent to those things, containment. You don't have that on the non-curving sphere thingy that you imagine.
Oh, if I take a tempered box and I put water on it with like a 30 degree, and I put that on the space, there is gravity, but the water is not confronted with the tempered space, right? So what shape would the water actually take? Have you ever asked this question to yourself?
You don't need to be asking silly
in a
questions if you
vacuum wouldn't take a shape.
So that means that no shape.
You can't have water exist liquid in a vacuum. What happens when there is no pressure surrounding water is the water will turn to gas.
There is no pressure. There's no forces. There's no gravity.
Exactly.
So that means
that's why the water in vacuums turns to gas. Ice, for example, in a vacuum will sublimate. It will skip changing to water and change immediately to gas. That's the funny thing about vacuums.
Oh my days. Because
do you require citation for this and demonstration?
Because the atoms would move so quickly that would actually turn into gas.
Yeah, so we're going to turn to gas. You can't have
molecules. Do we say molecules in English?
Yeah, molecules, depending on what state of matter or what energy was within the matter.
I know about that.
Good. So you can't have liquid spheres in vacuums. You should know that then.
Oh, yeah, of course not, but what we
Good.
talk about
You
vacuum,
also can't have balls of gas in a vacuum, can you?
but there's still molecules. It's
still molecules, and gas has the power of infinite expansion because of temperature and its random collisions. Gas expands. That's why you can't have spheres of gas in a vacuum. Gases only take the shape of that container, don't they?
Because gas turns into molecules.
Gas turns into molecules. How fucking retarded are you?
Because the distance between the molecules are so big that it's actually turning.
Yeah, exactly. So it's all going to expand.
What I'm trying to say, but actually it's so slow, so I gotta explain it at the actual 100%. So when there is actually a big distance between the molecules, that's actually gas, right? Isn't that gas?
Yeah, go on. What's your point?
That's gas. So you're
that's
saying
gas. Yeah, that's gas. What does gas do?
What does make the molecules go faster and actually separate
temperature?
Temperature, right? So the vacuums, what does vacuums have? Temperature.
No, vacuums don't have fucking anything. It's absence of anything. The vacuum will be the space that the gas is probably going to expand into.
Let me search something real quick.
Okay, you go and search it real quick.
Because there's le vide.
Gases take shapes, do they?
You can find
liquids take shapes in vacuums as well, do they?
Can I ask you a question? Can you make void in Earth?
Pardon?
It's scientific that you can make void in Earth.
Make a void? What, a vacuum?
Mm-hmm.
Yeah, it will be a container that you suck the gas out of. Nature by itself abhors a vacuum, doesn't like it, they don't exist. But we can artificially create one. You're going to need a container though, aren't you?
So you're saying that when you put water in a vacuum, it actually turns into gas?
Yes.
So the molecules actually start separating themselves for no reason?
Yeah, because they're not met with any pressure that's keeping them tight together.
So there's vacuum in space, right?
Apparently so, yeah.
So
that's the claim.
So the water is actually exposed in that vacuum.
The water, what would happen to the water in a vacuum?
So why doesn't this ocean turn into gas?
Oh, because we're contained.
Jedi, he's in the cross lines right there. He said there is a vacuum, right? And when you said yes, and we have water and we are next to a vacuum. So he's affirming the consequence, thinking that the impossibility of the high pressure system next to the vacuum is the case. But this is the cross argument right here. This outer space idea cannot exist. That's the argument, dude. It cannot be the case because we have gas pressure and that requires a container.
He said that when you put water in a vacuum, they actually turn into gas. Where this is the first time I heard that. And
he doesn't think that. I mean, we think that, but it's not because we made it up. That's the way it is.
Yeah, that's what he says, right?
That's what water does in a vacuum.
Dumb question, but wouldn't they claim that evaporation would be a turn into gas?
But did you prove that?
I'm playing devil's advocate right now, so
you do not believe in science, but do you prove that yourself that water is actually vacuum turned into gas?
What the furry fuck? Why did you have to start that sentence with "you don't believe in science"?
Because
do you want me to do your homework for you because I offered you citation and demonstration?
You just believe in perspective.
Do you guys have a job?
I don't think this is a good faith argument. I mean, why am I trying to help this gentleman? Do you require citation and demonstration for the claim that I made that water, when exposed to a vacuum, will change state of matter and turn to gas? Do you require that from a university, sir?
No.
Okay.
He said it's the first time he ever heard of it. He's learning about it now.
It's all about pressure.
Right.
How do you cause pressure?
What do you mean?
What causes pressure?
Air.
Air and?
There is no air in space.
No, I'm not asking you about space. I'm asking you about what causes pressure. So we have the gas. Now, what causes the pressure of a gas?
The interactions with the molecules.
Okay, that's going to cause the gas to expand.
Or to... But it's all about temperature.
No, that's going to cause the gas to expand faster or slower.
I guess faster.
Okay. Are you aware of the ideal gas formula? PV equals NR.
nRT, yeah.
Yeah. So you understand that pressure is caused by the volume, the container. The physical interactions of the gas molecules that have random motion.
Yeah, the number of molecules, the temperature, and the volume. But
yeah, exactly. Yeah, it's all in there. PV equals nRT, where T stands for temperature, the ideal gas constant, and the molar mass. Why do I keep getting interrupted by this type of music? It's constant. So you understand what causes pressure, don't you? The gas colliding with the walls of its container.
Yeah, that's what I say, yeah.
Yeah, good. So how do we have gas pressure with an open system?
An open, you mean there's no air?
Yeah, no, open mean that the container isn't closed, it's open. If to have gas pressure, you require a container to be closed and you open it, how do you have gas pressure in an open container?
No, it's very low, but it actually exists.
It actually exists.
It's pressure of the
What
air.
happens when... Do you remember the vacuum chamber you were talking about earlier?
Mm-hmm.
Okay. What happens when you open the door of the vacuum chamber? What happens to the gas outside?
It enters, I guess.
Yeah, it rushes in, doesn't it? It fills the available space. When the system was closed, the gas couldn't enter the closed system. When the system was open, the gas could enter the open system. So let me put it like this. If the Earth is an open system surrounded by a vacuum, how do we have gas pressure?
Because of atmosphere, I guess.
No, the atmosphere is a gas. Atmo means gas, air. Sphere, that's a shape.
I remember that there's gravity, but in the vacuum of space, there's no gravity.
What? In the vacuum of space, there's no gravity. Who cares about gravity, dude? It's got nothing to do with what...
Speaks about these things with such confidence as if he has first-hand knowledge.
Who
Pretty
believes
interesting.
Earth is flat?
It's not a belief. It's a measurement. After you measure something, you don't have to believe. You could know. Jedi, did your audio cut out?
Yeah, I don't know. Apparently, I've been clipping a little bit. Maybe it's my Wi-Fi. I'm not too sure.
I'm gonna say, Jedi, you've been like 98%. There's been a few clips I've noticed, but it's been mostly good.
Yeah, dude, you missed a prayer call, man. That interruption was for you to get back to get back to it.
That seriously, mate. That music, it follows me everywhere. It's a thing. It's really annoying.
Literally, huh?
Yeah, I heard it outside today as well. It follows me around.
I just walked into a cafe, so I got like piano music stuck in my head now.
What happened with the new people? There was some guy saying, I want to be devil's advocate or something like that. Then there was the younger, it sounded like a girl asking questions, and then the Indians and the Pakistanis. I don't know. Anybody want to open their mics and ask questions? Go ahead.
Empty. That guy's muted.
Who's muted?
The new guy.
That's the guy that said gravity. Space has no gravity.
Yeah. No, I mean the one that was talking to Jedi.
No, I was just saying I was playing devil's advocate for the Vegete, trying to help him and maybe because actually it would be a good question for me to ask as a newer flat earther. What is you said gas? It would have to turn to gas. Well, wouldn't that be evaporation?
No, it's called sublimation. If you look it up, you'll get more details that way. We could go over it with you here, but you can do a lot just by looking it up. I mean, now with AI and everything, you've got everything at your fingertips. It's definitely a process. And welcome, by the way.
Lily,
yeah, thank you.
Lily has some questions for you guys if you want to talk to Lily. Lily, feel free to join the VC. You don't have to type. We can talk. Well, Lily, you should probably pay attention to whatever the function is that you're at then. And then come back when you have a microphone.
Don't phones have built-in microphones?
Yeah, they do.
It might be on PC.
She says she's at a function.
A function might mean that she's like in a activity with people or something. I don't know, some type of function. Sounds like music and stuff in the background.
Possibly. But she's got her ears plugged up with us talking to her. So she's not listening. She is typing, so she's not paying attention to anything.
Yeah, I've done that. I've been in loud places and just being in here. I don't open my mic because I don't want you guys listening to the music.
Ah, you've been at a function, huh, Jency?
Bro, you know how Spanish people are? Their music is over the top loud. If I unmute my mic, you guys are gonna be deafened by that loud music.
Yeah, I know what you're talking about.
And then we'll mute you for TOS violation.
Exactly.
Ooh.
As long as it's not, as long as it's cumbia, then you'll be okay.
Hi guys.
What's up, dude?
Been a long time.
That's a
I'm
Snoop
here.
Dogg fallacy. Saying hi, guys. The sky high fallacy.
What is a Snoop Dogg fallacy? Hi guys.
You say hi, guys. Yeah.
Hey, it's Deep Shit. KD, welcome, man. Good to see you.
Yeah, good to see you, DJ.
Yeah, good to see you, man. So we got one of the server administrators in here. That's nice to see you in here. Appreciate that.
I've been here because Vivek is a little bit busy in his life due to some work. So if you guys have any issues and all, feel free to ping me or any other admin.
I think it should
I'd love to assist.
Oh, DJ has it pretty much handled in here, I think.
Yeah, DJ's a cool guy.
We have a couple of new people, but they're kind of shy. So
Yeah. People need to speak to improve their English.
Hi guys, I have a question.
Yes, Fish Rabbit. What's your question?
If the Earth is flat, why do navigation systems and maps rely on calculations that take the Earth curvature into account?
They do?
yeah, because they work off of these models that the Earth.
You guys are so fucking retarded. The Earth is round. Fuck the admin. Fuck DJ. You guys are all niggers, bro.
Wait, who is that?
Upset person.
Oh, this Jamal guy, right?
Yeah,
bro, it's not me, bro.
It's Jamal looking for his dad, but his dad is not here. He's asking for him. The end guy is not here, Jamal, so go away. Go to a different one.
Did he call us the N-word? Cool.
Yes, he did.
Yeah, he's looking for his daddy.
So the question was, how do we use or navigate without these maps that you said we use? But they're using a spherical coordinate system. So that's what they're based off of. And that's based on a model, WGS84 model. You can look that up if you'd like. The spherical coordinate system, and that model is what they're using. Most of the systems, anyway.
Does
It's
that
not
help
based
you out?
on the actual. Yeah, so it's not based on the actual Earth. It's based on a model. Yeah.
Yeah, the grid system is not the terrain that you're navigating across. It's a grid that you utilize for reference. And I mean, they shape it into whatever shape they want to. But it's not the terrain that you're going across.
Did that help, Fish Rabbit? Did that answer your question?
There are flat models, globe models, triangle models, many different grids, different shapes. The one that you might like the globe grid, the spheroid grid. That's not the terrain that you're navigating across.
Yeah, you can also make any point on that grid system the arbitrary starting point. It doesn't necessarily have to be a North Pole, a South Pole. You can make Texas the center of the world, and then plot a map based on Texas being the center of that map.
You can start from your house, from your kitchen. You can start from there.
But if you make it a map, you're going to be using an XYZ coordinate system with Z and X being the horizontal plane and Y is the vertical axis, which is going to be topography lines. So every map you make ever will always be a flat map. It'll be a flat representation of the land as seen from above.
Very good. Thank you for answering, Fish Rabbit. We got a lot of people in the
his
chat.
name.
Holy.
That was his name, Fish Rabbit, the one that asked the question.
Fish Rabbit. He, I think he dipped, but he had a profile picture. It was a fish and a rabbit. I can't believe it. But yeah, shout outs to the chat. We got a lot of people. We got a lot of new people. We got Velvet. We got V. Some new people I'm calling out. We got Mark Inc. We got Lily. We got Kim. Yeah, we got a lot of females in the chat. I mean, potential females, and maybe see. We got Diana. Like a lot of females here. Like, is this ladies' night or something? What's going on? Got any questions? Feel free to unmute. And we got our local guy, Alminator. Going on to everybody. I guess a lot of lurkers today. Got a lot of people in the chat. Guess they're just here to be in the popular crew, the 24/7 Player Discord, the most viewed channel in the English hub. Because we are number one. That's us right. I'm just filling in some dead air now, but we got Abdur. Welcome, Abdur. We got ATIF just joined.
Yeah, so please open your microphone up if you have any questions about the topic, or if you think you have any evidence that the Earth is a globe.
We got FinTalks just joined. We got T at the bottom just joined. We got a lot of new people, y'all. Open your mics. Say what's up.
Yo, what up, Flutters?
What's going on?
He asked a question. He asked what's up, and that will be not the ground below your feet.
Okay, what is down?
The ground.
That will be the ground below your feet.
Good answer, Steve.
So,
are you aware that on a sphere, any direction you point is up ultimately?
No, seriously, what is up? Up, down, side, forward, backward, whatever. What is sphere, globe, and whatnot?
Do you have hands?
Everyone does have hands.
he doesn't know what up and down is, so I'm wondering if he has hands. Does he know he has hands?
Doesn't sound like it.
Yeah.
Yeah, I think up is the same direction. Up is the same direction for everybody on the Earth, and down is the same direction for everybody on the Earth.
On the Earth, right? That's true.
Right, but on the globe, right, up and down are every direction.
Well, you're in Australia, so it's inverted for you, right?
Well, I'm not in Australia at the moment, but no, up is the same direction for someone in Australia as someone in America. Right? Because the Earth is not a globe.
But it is.
And how do we know that? Well, if it were a globe, right? If it were a globe, then it would have to have curvature over distance. And we could calculate exactly how much curvature there should be over distance. And then we could go to a large body of water and check for the curvature, which we have done thousands of times, and 100% proven that there is absolutely no curvature whatsoever over these distances where there must be curvature. And we have all of the evidence ready to present anytime anyone requests.
And how could you define that Earth is not a globe, it's a flat?
Define? Well, it's a topographical plane, right? And the surface isn't curving, so it can't be a globe, right? So over a certain distance, right? If you go to a 20-mile lake and the Earth were a globe, there should be 270 foot of curvature over that distance.
Yeah,
every curvature, right? Yeah, any body of water over 20 miles, whether it be an ocean or a lake, would have approximately 260 to 270 foot of curvature over that distance.
Right.
Yeah. So, but when we go and test over these distances, it's completely flat, right? We can set up a camera on one side of the lake or section of the ocean, right? And we can zoom in and we can see something on the other side, right? Clearly, that should be hidden behind hundreds of feet of Earth curvature, if it were a globe.
Yes.
Well, I've got an image I want to post that supports my theory of a spherical Earth, but I cannot post photos.
You can send it to me in DM if you want, and I'll post it for you.
Okay.
Yeah, because you've got to get to a certain level in the server before you get automatic image permission.
I have seen in many Discovery channels that when a space...
Gotcha.
Yeah.
Yeah, go ahead. Whoever was talking. Yeah, you're good.
Yeah. I have seen in many Discovery channels and the news channels that whenever a space shuttle, which is, or whenever it is going into the space, is when it clears the distance from the Earth, it shows that the Earth is a completely spherical shape. I have seen in many.
Ironically, the Discovery Channel, right? Outer space. So you said you saw this in Discovery Channel, right? Outer space and the globe idea were never discovered. They were invented, made up. Inventions by men, not discovered. So just letting you know. Go ahead, guys.
That's a good point, Jency. The first person to think about it like that would be Pythagoras. And you can go a little bit further than that, but Pythagoras had a cult where they said that the sphere is the most perfect shape in the universe.
So when you're saying that they go to outer space, a made-up place by men in paper, that wasn't discovered. And then the curvature of the Earth that you're standing on, curving at a certain rate to create a specific shape at a certain dimensions, that was made up, not discovered. There's no man that has measured the curvature of the Earth. It's only on paper. Like a story, when you make a story and you write it on paper, a movie, a cartoon, storytelling, made up stuff. That's what the curvature or sphere Earth is. Not discovered. In Discovery Channel.
All right, so what's his name? I forget. 1 second. T has sent me through his image. All right, so this is his globe evidence. So I'm just going to post it for him in the side chat here. And then T, if you want to explain your evidence to the panel.
Well, as you can see, the windmills, right? They're placed on a different body of water, like on a different body of land, right? And we can see that the Earth isn't flat because the windmills are shorter because of the Earth's curvature.
Brother. Hello?
Yeah, hold on a second, my friend.
Yeah, right.
Yeah, so we're just covering the other guy's question quickly at the moment, right? Okay, so that particular wind farm, right? We don't have... Yeah, what's up?
I have just posted a text in the chat box. Can you give me the answer for that, please?
Yeah, but just wait, right? Because somebody else is talking at the moment, right? So just hold your question.
I'm sorry for that.
That's okay. Okay, so with the windmill picture, right, when we zoom into the picture, we can see clear signs of miraging effects taking place. I do have a higher resolution version of that picture. And when you zoom into the left, hold on, I'll just see if I can find it quickly. I really should name my files better. Right, so we can see the wind towers on the left. And you can see that a tower behind the tower that's closer is actually higher up in the air, right? Even though all of those towers are meant to be the same height, right? So those towers aren't on land. That's actually a windmill farm that's out in the ocean.
Yeah.
Okay, and we have what could be easily passed away as just a common miraging effect taking place with the windmills. I will find this file Yep, go ahead.
That's a natural phenomena, brother.
Yeah, it's called sinking, right? It's a form of inferior mirage. Right, so something that would normally be visible on the geographical horizon apparently sinks beneath it. That's the mainstream Oxford definition of sinking, right? So we do see signs of that happening in the image, and we also have evidence that can counter that, right? So I can show you footage right now of a different wind farm where we actually know the distances, and we know the height of the observer. So if you have a look at what I'm posting in the side chat, okay, so here we have a camera set up at a particular height. If you can see what I posted at 9 minutes after the hour. Okay, so he's set his camera up at 3.5 foot off the ground, right? That's just over a meter. And then he's zooming out at a similar thing, right? A wind farm. Okay, so this is called Rampion Wind Farm. And we know the distance is 8 miles to the first windmill on the left. And the distance to the windmill on the right is 11.2 miles. Now, if the Earth were a globe, the bottom 50 foot of the windmills should be missing behind the curvature of the Earth. But we can clearly see in this observation that we can see the entire windmill towers all the way down to where they touch the water. And then we can see the surface of the water goes far beyond the wind towers. So along with that, there should also be a horizon at 2.3 miles away. Okay, so if the Earth were a globe, the horizon should be a certain distance away. Right, that would be what would be blocking the wind towers, okay, the horizon. So here's an observation where we have a little more information about the the image or the video, and we can show that it doesn't match with the globe mathematics at all. So that would be a counter to your photograph, right? So in your photograph, it's just a photo, right? It's not a video, and we don't know the height of the observer. We don't know the distance to those like the windmills, or anything like that, right? It looks a bit miraged when you zoom in on it. So we have a nice clear one here with a lot more information that is a good counter evidence.
Yeah, but don't you think the distance in your GIF is not enough to show the Earth's curvature? So, like for example, if I'm standing in, let's say Greece, right? I should be able to, because of you're saying the Earth is flat. I should be able to see Libya's coast if I'm standing at Greece, right?
No.
But you can't.
No. Right, dude. We should be able to see the curvature of the Earth. It should be at 1.225 multiplied by the square root of the observer's height in feet. To keep it simple, if we're on a sphere and your eyes are 6 foot above the water, the horizon will be 3 miles away. That will be the tangent point that your eye line met at distance if you were standing on a sphere. The horizon is further than that. So we see further than the geometry that we're told that on a sphere. To address your next question about seeing Libya from Greece, angular size reduction with distance and the atmosphere that you are looking through. You can use technology to increase the angles of things at distance so you can resolve them and see them in your optic, but that only works so far. Ultimately, the atmosphere, the thing that we're looking through, at distances of like 200, 300 miles, become opaque. The light that you're trying to see can't pass through that amount of gas because the atmosphere isn't transparent. Okay, so on a flat Earth, we see as far as we can see, as far as the optic enables us to, and as far as the atmospheric conditions. On a spherical Earth, the optic, the atmosphere, and the curvature of the Earth would be as far as we could see. The curvature should be at 3 miles for a 6 foot observer. We can see a horizon well beyond that.
Yeah.
T. Hey T.
What?
I posted a video for you and I tagged you with it.
Yeah, but I ain't watched 11 minutes. I can't lie.
Well, you don't have like a 10-minute observation span?
No, I'm just too lazy to watch all that.
That will answer your questions. Observably so. By observation, you can see this phenomena happening. About the windmills and the boats going away from your view in reference to other objects on the distance. And what the guys point out to you, that the sphere will have a specific point where things will be going behind. But that's not what we see.
I mean, the video just looks like Earth curvature to me. I mean, the ship's going away. Pretty simple.
So, you're saying that you already checked?
I skimmed through the video.
So listen, all the other variables, you checked, Mark, all of the other variables, and you disqualified those, and then came to the conclusion that the only reason you don't see the boat and the boat is going away from your view, it's because Earth curvature. That's the only reason.
Well, you also got to counter in like fog. Obviously, you can't see infinitely, right? There's fog, right, and Earth curvature playing at the same time.
So Earth curvature will be at 1.2 miles from the observer. I mean, we're talking about 1 feet altitude.
Yes. Yeah, these ships.
Go ahead. You were gonna say something, someone?
What?
Yeah, I was going to say, how do you know it's Earth curvature if you've never confirmed it? But yeah, thought that was pretty obvious.
Well, how are you going to say it's a flat Earth if you haven't confirmed it?
We measure it all the time. In construction engineering, for example, large civil engineering constructions, we build upon the Earth as if it is a flat, level, stationary plane. We also aviate it with the same process as if it is a flat, stationary plane. So we measure it, we use it, we build upon it. It's our natural, everyday, lived-in experience of this Earth.
Yeah, would you like to see a laser demonstration over 21 miles that proves it? I mean, there's a ton of stuff that proves it. But we verified it. That's why I'm saying, have you verified that it's Earth curvature that you're witnessing there? That's why I mentioned it.
Are you gonna look at the laser?
Here's my final question.
Hey T, you're gonna look at the laser test?
Not bothering all that. But here's my final question before I go to sleep. Here. So
T, you're getting answer. You're getting answer to your questions, but you're ignoring everything that is being said and the evidence that is being posted for you. People are taking, their time to give you the information, and you're saying no, hand waved.
I don't really give a shit. I'm just here to ask questions and here to answer. Like, I don't need an answer to your answer.
All right, watch the next question so this can be over with.
Here, okay. Here's my last question. Final one, right? Let's say the Earth is flat.
Okay.
So what? Why are y'all putting so much effort into this?
Why? You won't care about the answer.
What does that change?
You won't care about the answer. You won't care. Which is probably a good thing on their behalf. You don't really care.
I mean, I know the Earth isn't flat, but let's say it is, right? What does that change?
I'll tell you, T. I'll tell you, they got you to not care about anything. That's what they wanted. They got you to not care.
No, but what does that change if the Earth is flat?
How did it get here?
It is. What does that change?
How did it get here?
Why would you care about that?
How the Earth was created? I don't know. Lots of people like to ask how the hell we got here. Lots of people assume that the story that they're told that the Earth is a sphere and was created by some kind of explosion long ago, where everything, including the sphere, the Earth that rotated around the other sphere in the sky, the sun, was born into existence. But the Earth isn't that. So the question remains, well, how did this get here then? Why am I here to even ask that question?
Explosion in a vacuum?
Weird. Yeah, it's called the Big Bang.
My doubt, I have one doubt with JD. Hello?
Can you repeat that? Because it sounds not right. Go ahead.
Yeah, if I have one question with, right? If Earth is not spherical and it is in a flat, then why the water is standing on the Earth? It means, why it is not falling into the space?
There's no space, vacuum for the water to fall off into. If the water is still here, it must be contained. The water's still here, so it's got to be contained.
That's the answer. There's containment in place, obviously. Contrary to the globe belief, there is no containment on the globe. So it's impossible, it's an impossibility to be so, because there is no container on the globe. And we have water and gas pressure, and that requires containment to be the way we have it as. You have water contained, gas pressure, and then you also know that real spheres and water, when you put those two together, you will not get the globe idea. The sphere with water on the outside, that's an impossibility in reality.
Yeah, but the NASA is revealed when the NASA shuttle landed on the moon. They have taken the images of the Earth. That shows the Earth is completely.
My friend,
that
can't happen. That cannot happen. Yeah, that's like movie sets, Hollywood, Disney, Bollywood. You ever heard of Bollywood?
Yeah, I'm from India. I know Bollywood.
There you go.
Movies on TV. They can't have gone from the Earth, which is an open system in a vacuum, to a rock in a vacuum. For that to exist, well, it couldn't. We'd all be dead. We have gas pressure. We remain on the Earth, and we're supposed to be surrounded by a vacuum. Gas pressure is defined as the force the gas exerts upon the walls of its container. If there is no container, gas continues to expand into space. So it's a very simple law of nature. The reason why they didn't go to the moon in a vacuum is because the vacuum of space can't exist. Not in the way that we're told.
And when they showed you from the movie set, they show you Earth as a sphere in a vacuum with gas pressure and water on the outside of the spinning sphere. That's a misrepresentation of reality. When you go to reality and you check water, it's not curving, it's in a pressurized environment. Gas pressure requires containment. So when they show you the opposite of reality in imagery, movie set, you know that's not real. That's not real. Because reality is contrary to the fantasy set that they show you in the TV.
Okay, if Earth is not spherical, if it is flat, then why the tides are taking place in the oceans? On the moment of the moon.
change in sea level? Don't know.
Yes, yeah, that's what.
Yeah, I don't know why there's a change in sea level.
Oh, it's an impact. It's an reflect the rotation due to the rotation of the moon.
That's a nice story. That's a nice story, but we're talking about sea level, aren't we? And the change of tides of the sea level. High tide, which is a higher level than low tide, which is a lower level than the mean average. That's level. That's a straight line from left to right. That mean sea level is a horizontal reference datum. So the reason why water goes up and down, a change in level, it's not going to change the level of the Earth. The story that you've got about a moon changing the level of the water on the Earth is fascinating. It would be interesting if you could demonstrate it in a scientific experiment somehow.
Yeah. So do you believe the moon is spherical, or it's also a flat disk?
No, I don't have beliefs. Right? I look at the moon, it looks like it probably could be spherical, but sometimes I have caution to pause. The point is, my friends, is no matter what speculation I have here on Earth, until I go to the moon, I'm not going to be able to tell you what it is.
The moon could be spherical, it could be flat, it could be a circle, it could be concave, it could be half a sphere, full sphere, but the ground below your feet, where you're standing on, and you're looking up to look at the phenomena that we call the moon that moves in cycles, that ground and the waters across are not curving to be a sphere. So you're standing on the ground, navigate across the waters, you look up, see the moon, whatever shape it is, doesn't affect the place you're standing on and you're looking from to observe the phenomena. Circle moon, sphere moon, shape moon, whatever. You're thinking that you see the moon and you attribute to the moon a certain shape, a certain aspect, characteristics, and you're saying the earth must be like that thing up in the sky. It has to be. But that's a logical fallacy. It doesn't follow. You cannot reach that conclusion definitively, logically. You cannot say it is so. You cannot establish it to be the case because when you go to the earth and you measure the earth, it's not curving. So how can you come to the conclusion that the earth is a sphere if it's not curving? It will be illogical. And TF, and also you mentioned the moon landings. The set that you saw on the TV in those videos, that's not the moon. That's a movie set. The moon is the thing where we look at the sky and we observe from the realist level. The imagery that you got, and then they looked to the earth and they show you a circle earth from the moon.
Yeah.
That's like, you know the movie Narnia when the girl went into the wardrobe?
The Lion, the Witch, and the Wardrobe.
You know the movie Narnia, the little girl going into the wardrobe?
Yes.
Yeah, when she went to Narnia and she found the talking lion and they waged war against the witch. You know that didn't happen in reality, obviously, right? Because we can go to Africa and see lions, and lions don't speak English, Spanish, Hindi, because you can find Narnia in all the languages, and the lion will speak in all the languages. But you know, when you go to reality, you know that the lion doesn't speak any of those languages.
Yes.
Yeah, so when we go to Earth and we see the water across the surface and we check the Earth and we use it practically, we do things practically on the Earth, we know that it's not a sphere. But when they show it to you in the TV as a sphere, that is a misrepresentation of what the Earth is. Just like the lion in Narnia, the talking lion, waging war against the witch.
Yes. What is the final conclusion about the Earth?
The final conclusion is it's a flat, stationary, contained system.
And another conclusion is that there's a lot of things that we know and that we do practically in reality. Things that we can check, experience, and verify. And there's a lot of other things that we don't know.
Yeah. Yeah. It is the Bermuda Triangle, bro.
So, Atif. Atif.
Yeah, brother.
You posted something that it looks like you did a search, maybe ChatGPT or some type of AI engine.
Yes. Yeah, I gathered this from.
It says the Earth is not perfectly flat, right?
Flat. Yeah.
It's mostly spherical in shape, but slightly flattened at the poles.
Yes.
So if it's spherical, can we check that? Can we those letters, right, will mean something, right? Spherical, right? Spherical means a sphere curving on the surface.
Sphere, right? Round, like a ball.
Yeah, like a ball. So that's a claim that those are letters, right? You're reading that.
Yes, the same thing taught me in my childhood in the schools.
Okay, so this sphere will have a specific value, like a specific size, right?
Yes.
Yes. So those numbers, do you think we'll be able to test that? Go to the real. So shut down the ChatGPT, right? Turn off the screen of the phone, and then go to the real world and check if those letters that are saying the Earth is a sphere, if that adds up in reality, if we can find that. We're capable of doing stuff like that, right? Check claims, verified or falsified.
Yes.
Yeah, so that's the case. That claim that you read, that has been falsified. Laser tests, long distance observations, everything that we do practically in reality doesn't need the sphere. There's people that have been posting some of the laser tests in the text, so I would recommend you to look into some of the videos that have been posted for you, and that might.
Oh, sure.
Here, talking is one thing. We can say a bunch of things, but if you look at the examples that have been posted for you, that's some extra information that it will be. I mean, I will recommend for you to look at.
Sure, I will check that.
Let me tag you with a video that I posted about a long distance observation of a boat. Remember, when you're looking on the internet, you're gonna find a bunch of information that is gonna promote for you the globe thingy, right? The globe idea. Oops. So just look at the other side. People that are questioning and testing for the claims and finding that it is not the case, falsifying the claim. So it's Atif. I tagged you. If you click on the tab to see attachment, there's like an 11-minute video that will show you some interesting footage about a long observation. That's just one example of the topics that have been spoken about in the text in the past, I don't know, 20 minutes. That's just one of many videos and links that you could probably look into in this VC. You got any other questions? You can go right ahead and ask. I'm talking too much.
Hello, who is here?
Welcome.
Thank you.
What are you doing?
Clarence did it in English.
Hello, Berserker. I can hear you, but you're roboting a little bit.
Oh, okay. I will
No,
disconnect.
it's all good. No, it's fine now.
Oh, okay.
What's going on, man?
Well, looks like the stream is up. It's like refraction is quite a trigger word. Greetings, all the new people showing up. Welcome to Flat Earth. If you have any questions, feel free to reach out. Well, I guess after this stream, Quantum Eraser probably won't find himself back in our circles very often anymore. Not that he ever was.
Oh yeah, his anti-DJ stream.
Yeah, it's up, and he's madder than a hornet. And some of the people chiming in that I thought were friends of DJ are really not friendly at all.
Oh yeah. Oh well. What are you gonna do?
Yeah.
I always say, forgive them and forgive them and let it go.
That's really all you can do.
What are you what are you talking about? Sporadic? No,
Quantum
DJ
Eraser.
having?
No, Quantum Eraser sent DJ a bunch of ridiculous messages last night, and he's doing a stream for his little community, basically talking crap about DJ. So DJ's take on
Really?
the refractive index in a singular medium. So yeah,
Yeah, it's not
And,
just DJ's got a beef
I
with.
mean-
He declared war on all of us out here.
Ooh, Quantum Eraser.
Yeah, the guy. Yeah,
I'm a great fan of both of them. DJ.
But that's like
I'm a fan of
Quantum
both of them.
Eraser's
DJ.
favorite argument, though.
Yeah, go ahead.
That's his favorite argument. That's his favorite argument. He's kind of like chose this hill to die on. He likes saying, "Oh, yep, I shut Globers down with this argument," and it's whatever, man. It's just a silly thing. It's very childish, and I don't know.
Which argument?
You know, it is.
Which argument?
That's what I can't get over.
Which argument does he mean?
He's basically saying that you can't call other different types of miraging effects refraction. But when you look at the definition of refraction, what else would you call it? You know what I mean? So it's just, I don't know. It's just like people arguing about, where do you? It's like something simple, like certain people like to write the words, cannot as one word, you know what I mean, or as two words, right? Or a lot, as like an ALLOT, or separate ALOT, A space LOT or something. It's just like preferences based on, it's silly stuff, man. It's really childish, to be honest with you.
I know all this comes from the fact that Snell's law is defined as the law of refraction. And what Snell's law comes from is Fermat's principle of least time, which is more of a generalized case, and Snell's law is more of a specific case.
I guess the Globers are partying now, like 1999, because this is what happens when we don't stick. This is what happens when we don't stick to the Black Swan and don't let
this has everything to do with the Black Swan.
Yeah, I know because of the refraction, but it's just fantasy story refraction. It's a fantasy story. I mean, even when we give them the refraction and the maximum of refraction, it can never compensate the amount of how further we are being able to see. But just to make it clear, I like both of them. I like very much Quantum Eraser.
Well, Berserker, you're probably not going to like him after this. Because, sorry to cut you off.
Yeah, but
Quantum Eraser is saying there's no such thing as a refractive index of air.
Yeah, sorry for interrupting you, but the point is, DJ is the most patient guy here. I mean, to take on DJ, he's the nicest guy here, and very, very patient.
Oh, I know. I don't know what his beef is, but he's now saying, or was a few minutes ago in his live stream, that there's no such thing as a refractive index of air.
Yeah, and sorry for interrupting you a couple of times.
As if air is not measured to produce a phase change and its phase velocity change compared to a vacuum. Which I don't. And then, all of his fans are like, well, that's true. That's true. You're obviously right, sir.
Wait, so what's happening? Is he coming on?
I'll tell you real quick. Quantum Eraser's got to show up. He said basically politics, flat earthers are the new land of misfit toys, and he's going after DJ. And he's criticizing DJ for saying that air has a refractive index at all.
Okay.
Yeah, he's completely lost his marbles.
So is he jumping
sporadic? Can I watch it now? Is it live now on YouTube?
Yeah, it's on his YouTube, or you can go on his server and join the live stream.
Where do you mean FED?
FED.
So he's not going to jump back in on. He's not going to jump back in on Discord.
He's in the FED server right now, broadcast.
Oh.
Oh. Ballbusters, right?
Yeah.
Okay, I will see if I can join there too without being logged and dropped out here. I will try it. Sometimes it works. Sometimes I get automatically logged out here if I join somewhere else. I will take a look. I will mute myself here, and I will deafen myself also just to hear there if I'm able. Okay, let me see.
Okay, well, good luck. It's like the stupidest thing to get pissed off at, and a stupid hill to die on. This is crazy.
Just short info. It's cool. I'm logged in at the same time here and there. Okay, I will take a listen. There, I mean there. DJ is talking at the moment.
Oh, he is. Oh shoot, DJ went in.
Yeah.
Add respect to DJ, but it's true. DJ doesn't give a shit.
Yeah, why should he? I would do the same thing.
Yeah, it's good on him. Something that still puzzles me to this day is how come Americans haven't mastered the art of four-way stops. The four-way stop has been around for like 100 years. The laws have not changed in the entire time.
Or where traffic's going in one direction straight and coming the other way, turning left, how you're supposed to duck in behind the person going straight.
Yeah, or generally, right from the top, it's like first come, first serve. Two people opposing each other. One guy's turning left and the other guy is turning right. Then the guy who's turning left has to yield to the guy that's turning right. It's basic yield laws applied. Like, this isn't hard, folk. I got a massive headache.
They always do that to you, Sporadic.
Yeah, isn't that funny? Like
they know what ticks you off, dude.
It's like it's first come, first serve, okay? I normally have to take a left. So I wait for all the other cars to go who came first, and then I get to go because I'm next. But then the guy who comes up ahead of me who's turning right thinks he can just jut in front of me. But I was there before him, regardless of me turning left. It doesn't matter. I was there before he was, so I can come left.
What is it? You're talking about four-way stops?
Yeah, just blowing steam about this. Not that my blood pressure needs, any lift.
Hey, I
got this routine.
Just gotta forgive him, man. Just forgive him and
I know.
let it go.
I know. It's just I'm just a little annoyed that this is so ongoing like this.
Hey, I got a stumper for you.
That's why it keeps happening.
You know how you can turn right on a red light?
Yeah, unless there's a sign that says no.
Right. Or can you turn left on a red light if it's a one-way road going to the left?
Wait, why would there be a light for a one-way road?
Let's say you're on a one-way road going straight, right? There's no opposing traffic. And then
there's an intersection.
And there's an intersection, and you want to turn left, and that left is on a one-way road also. Can you turn left on a red light?
No, the red light masters it all.
Yeah, but you're not crossing any traffic. You're just turning into the nearest lane.
I know. You still got to yield to the traffic light. Suppose this were the case, right? There's a cop parked there, and you had 3 beers to drink. Would you wait for the light, or would you go? Let's say you had 3 beers to drink, and there's a cop sitting at that intersection. Would you turn left on that red light?
I would drink 2 beers and then share the third one with the cop.
No, we're talking New Jersey.
No, I would argue it, man. I'd be like, but I'm not crossing any traffic. I treated it like a stop sign.
All right, whatever.
I came to a complete stop. I yielded. I noticed that there was no interacting traffic, and I treated it like a stop sign. I've actually gotten off on that ticket.
Better hope that cop doesn't smell those beers.
Exactly right. I sure as hell would stop and wait for it to turn green. I don't give a fuck. Pardon my French, guys. I'm following all the rules.
As you're breaking one, right?
See, that's the thing, though. I read all the rules. Like, one day I got tired of getting pulled over for stupid shit. So I literally sat down and read all the rules for the Texas Department of Transportation. And it says nothing in there about you being, that's one of the rules that's not in there. If there's no rule on it, then you use your best judgment.
Well, yeah, or you apply the same logic from another rule. Right? And I ain't turning left at a red light no matter what.
Yeah, but you can turn right into the most farthest right lane. So if you can turn left from the left most furthest lane into the left most furthest lane without crossing any traffic, are you impeding any traffic?
Well, the thing is like right-handed things are more permissible than left-handed things. That's just the way we are with our road system and safety.
So are you biased against left-handed people?
You bet.
But the main reason behind the logic behind that 20 cups is that if you do that, you're now in the passing lane for that road, that multi-lane road. Because the left lane is always where you're supposed to pass. So it should be the fastest traffic. If they're moving quickly on somebody's ass, and they need to move over because the person's slamming on the brakes, whatever, that's supposed to be their safe space to move over and pass.
Yeah, but I yielded to all traffic, made sure that I wasn't impeding any other traffic. Like I said, I got out of a ticket once. The cop saw me do it. Why'd you turn left? Well, I didn't cross any other road, and it's similar to a right-handed turn. It's just a left-handed turn from a one-way road to another one-way road. So it's the same thing as a right-handed turn. Yeah, and I was like, and it's not in the rules and regulations for the Department of Transportation. So if it's not in the rules and regulations, I can use it to my own discretion and have my own best judgment on it. Treat it as such, as long as I'm not impeding traffic. And he as he's like filling out the ticket, he's like, fuck, he ripped it up.
That's awesome.
I don't recommend it all the time. I just wanted to. I just wanted to see
know
what
a
would
lot better
happen.
than he did.
I mean, yeah. Well, I didn't know it better than he did. I just knew it, and because I knew it, because all they are policy holders anyway. They're just looking to enforce policy.
So sporadic. Did DJ say he was going over to QE's thing to defend himself and defend his position?
Is that where everybody's at?
I hope not. I hope nobody's giving that guy free airtime.
No, I try being kind or nice about QE. Like he has his purpose. He did establish some of the framework for some of our conversations and stuff like that. But his demeanor has always been so horrible. I did leave her serving.
Yeah, I heard some good things and some bad things. Never spoke to the guy.
I'm not a huge fan. He's not a fan of the ether, so he's a little shit talker about it. Whatever, I don't care. I'm an ether guy. Can't prove it, I believe it, but I think there's enough evidence. A difference of opinion, right?
Yeah, man. Everyone's entitled to their own opinion. That's for sure. I don't think it's right to demean people based on their belief systems, unless it's like a belief system that encompasses like being, I don't know, being harmful to others, So that's kind of where I draw the line, is when you're being harmful to others, then yeah, I'm probably not going to agree with your, probably going to have problems with what you're doing with your free will. But other than that, I'm usually pretty lax. I could take people as they are, But yeah, like the way he's talking to DJ, definitely lost some cool points in my book. Alminator, can you say something, or are you server muted?
Something.
Oh, there you go. You're good. How you doing today, man?
I'm fine. How are you?
Yeah, just working, living the dream.
Yeah, I'm finished working, so I'm living in Europe, so it's pretty late, 9:30 over here. So I'm just enjoying the evening, listening to you guys.
I know, I am pretty entertaining. I did not
Yeah, well,
give
I'm glad
myself
your mic.
a name legend for nothing.
I'm glad you got your mic fixed, bro. I'm gonna hop off, let one of these other gentlemen talk to you.
I don't know what
I was in
happened.
between
So
satellites.
somehow Discord changed the mic setting to press a button to speak. I didn't do that. So it's some Discord update that happened in the last few days.
You can change it back on your profile.
Yeah, I did it. That's how I fixed it. So, do you guys have a specific topic you want to talk about?
I want to talk about how flat the Earth is.
Okay. Feel free.
What about you? Is the Earth flat or is it a ball?
So
is it an oblate spheroid?
I'm not a flat earther, so my opinion is Earth is a globe.
Right on, man. What made you come to that conclusion?
Various things.
Like what?
Like, for example, watching things that happen in the sky, like measuring distances on our Earth.
Okay, measuring distances on our Earth.
Mm-hmm.
What kind of distances?
Well, basically every distance that you can measure. So I was here in the Voice a few weeks back, and maybe some people remember me. So I'm working in the ATC environment, air traffic control, and my job requires me to understand that flight distances, how they work on the globe or on the Earth, let's say it.
Okay. Well, you measure distances. What about drop over distance?
What do you mean with drop over distance?
Well, when the plane is flying around, right? As the plane gets further and further away, it goes behind the curve, right?
So the plane is just flying straight above the surface.
I agree with you 100%.
Okay.
The plane is flying straight. It's not flying in a curved path.
How do you know that?
You just told me.
I'm saying straight. It's following what the plane is measuring as horizontal.
Yeah, no, I agree with you 100%.
Okay, so how does it? How do you come to the conclusion that Earth is flat by that?
Well, you didn't mention any curvature in any of that. Those statements. You said it flies a straight path and it flies horizontal to the plane.
So I was referring to distances that planes fly all around the world, whether it's on the south part of the Earth or on the north part of the Earth. If you map or if you consider the flight durations and compare that with the distances on the south and the north part of the Earth, then I actually couldn't find any flat Earth model which would explain any of these relations between distances and flight durations.
Yeah, I'm having a hard time finding a globe Earth model that explains how everything works also.
Well, the globe Earth model is pretty simple. It's a sphere.
It's much more complicated than that because it's a sphere that looks flat.
Sphere with no curvature.
Yeah.
Okay, that's interesting. So how do you get that there's a sphere without curvature?
I mean, it's measured flat, observed as flat, practically used as flat, but somehow it's a sphere.
What is exactly the flat measurement?
Hold on. Zero curvature. That's the flat measurement.
Well, that's two words. That's not a measurement. So either you can provide how you determined that zero curvature, or you can admit it's just a phrase.
All right. So in order to measure curvature, you would draw a tangent over the curved surface, right?
I cannot draw a tangent because a tangent is something virtual. So how do you draw a tangent?
I mean, you can use a straight object, you can use a laser, you can use line of sight. Any kind of tangent that is a representation of a straight line. And then what you're looking for when you're trying to measure curvature is you're looking for, over distance, you're looking for deviation from that tangent. That's how you measure curvature, right?
Can I ask you something? How do you determine that a laser or a line of sight is a tangent?
Do lasers curve?
Yeah, absolutely, they can.
Okay. Show me how they curve in nature.
I can, if I would be able to present a picture in the chat, I would show you. Maybe I can find a link to that.
You can send it to me. You can
Give
send
me
it
a
to me.
second. So lasers are not special. They are just light rays that are following refraction. They are just light rays that only consist of a single light frequency.
I mean, you're putting it in a very simple form and you're leaving out a lot of context so that way you can make it adhere to what you want to occur.
I'm just addressing what you said, how you determine what a tangent is. And you were saying a laser is a reliable reference for a tangent. And I was just saying that a laser does not necessarily have to go in a straight way without any curvature or refraction.
I'm not denying refraction, but lasers with high enough energy behind them have been shown to go several tens of miles straight, in a straight line. You deny that?
Sorry,
consistently in a straight line.
So I have seen experiments where lasers definitely do not follow a straight line.
Okay, like what?
Okay, let me try to find that.
Yo, what's going on? Do you guys still believe that this flat?
We know it's flat. Wait your turn.
Alright. So, it is flat if you believe it.
Alright, so in my
Yeah, what do you guys think of aliens?
It's all only happening
Like the
on
trilogy?
Sorry?
Talking about the movie or the video game? Talking about the movie or the video game?
No, not the movie or the video game. Do you think that being exists other than us humans in the universe?
What difference does it matter?
Oh, it's bad. Oh.
Sorry?
So if there's other beings other than humans, and let's say there's no outer space, right? Where would they come from?
There is outer space, so there are many planets. So they live in other planets. Do you think we are the only ones that live in this?
There's wandering stars, right? That's been proven. But as far as outer space is concerned, in the way that you're thinking of it, I mean, I don't think that's been proven, right? It hasn't been verified by you. I know that much.
So you guys don't think that other planets exist?
We see lights in the sky. What they are, that's another story, bro.
Well,
You know
there
what
are
they
many
are?
planets, Saturn, Venus, and all, Mars, and all. So,
Well, you say other planets exist as if the Earth is a planet also.
yeah.
Yeah, we're not saying the Earth is a planet. You know what the definition of a planet is?
Planet is a, what do you call it? A planet is a, you don't believe it's a ball, so it's a flat substance in the universe.
Well, why don't you look up the definition? The definition will tell you that it's a celestial body. And what a celestial body is it's an object in the sky. So when I look up in the sky, I don't see the Earth, right? So the Earth can't be a planet because it's not in the sky.
You can't see it in the naked eye, from the naked eye, but out in the space, outer than the Earth's surface, there are many planets. So, don't you think
There's
people live in?
lots of planets, but the Earth is not a planet.
So, don't you think that people like us, other than humans, live in other planets?
What other planets? If the Earth is not a planet.
I don't get what you're saying.
I know you think the Earth is a planet, but it's not a planet.
Yeah, I think that the Earth is a planet. Yeah.
Yeah, that means it would have to be a ball or spherical in nature, and you'll have to prove that is what that's the case.
All right. Okay. Don't you think if there is, or don't you think other like Earth, there are other what do you call planets or something like Earth exists other than Earth?
No, everything in the sky, nothing in the sky looks like anything on Earth.
You only believe that that Earth is only there in the sky and nothing else.
When I look up in the sky, when you look up in the sky, do you see trees?
No,
You see
you can't
grass?
see it from the naked eye. Yeah,
Do you see life?
I see light. I see just stars. You can't see planets from the naked eye.
You see stars. You don't see life. You don't see other beings in the sky.
No.
Right. So what would make you think that anything up there was like anything underneath your feet? The Earth is special, man. Enjoy it.
So if you imagine out in the space, don't you think?
Yeah, I don't like to imagine.
You don't like me? All right.
I said I don't like to imagine. Why should I imagine my reality?
Yeah, you should imagine because you believe that the Earth is flat. So, I mean,
I don't believe the Earth is flat.
But how do
you don't believe that the Earth is flat?
How do you know?
How do I know?
Your assumption is correct.
Because I looked for curvature, and there was no deviation from the tangent when I looked out.
All right. So you don't believe in other planets. So, I mean,
the Earth's not a planet.
Earth is not a planet. Then what is you said?
The Earth is Earth. It's a place where all life exists.
Yeah, Earth is Earth. So don't you think other place exists? Is there only Earth in in the space?
To my knowledge, only Earth exists. There's no other place to go live.
So there is not a place called Jupiter, Saturn, Mars.
Can you go there?
Well, I can't go there, but NASA can. Blue Origin can. SpaceX can. So
you just keep giving them money then.
No, if you had a rocket, you could go there literally. But you don't have it. No, normal people don't have a rocket, so.
So, Sheepdog, do you think the ground of the Florida Mariana Trench exists? Can you go there?
Mariana Trench?
People have
No,
gone there.
No, it's too deep. You can't go there.
Right. My question was to Sheepdog whether he thinks it exists.
Do I think that it exists? Yeah.
Yeah. You can't go there, and according to your argumentation, you can't go there means you can't be sure it exists. Right?
Okay.
The Mariana Trench.
I'm more likely to go to Mariana Trench than I am to go to outer space.
But how do you know you are able to go there if you never tried?
How do I know if I'm able to go there if I've never tried? Like I said, I am more likely able to go down to the Mariana Trench than to go to outer space.
Yep, that's your opinion. But my question is, how do you back up your opinion? Or what's the
You know what I'm still waiting for? I'm still waiting for you to show me laser lights curving. That's what I'm waiting for you to show me.
I just posted 2 links in the chat.
Let's take a look. Okay, so the first one that I see is a laser light bending out of a water bottle. Now, is this something that occurs naturally in nature when I look out over the ocean or a lake?
So these are 2 laser rays.
Is this a reproducible effect over a lake?
Just tells you that the laser doesn't always go in a straight way.
Right, you have to produce a very special effect in order to make that happen.
Yeah, how do you know that the atmospheric effects on Earth are not special?
Well, when you point a straight line, there should be deviation from the curvature, or it should hit its target at the end of the straight line.
Yeah, but how do you determine what is a straight line? That's a circular reasoning. You are using lasers to determine what straight is, and then you say, because I assume the laser is straight, the straight laser that I assume is proving there's no curvature. That's circular reasoning.
You can do other tests as well to determine whether or not the laser is confirming what you're already seeing.
Sorry, say again.
I said you can also do other tests to confirm what your laser is already doing.
Okay. Which test?
Direct line of sight. If it's long enough, you can do radio wave propagation.
Radio waves and sight are using the same optical laws like a laser. So that's the same circular reasoning.
Well, radio waves are just light anyway, right?
They are
frequencies form of a light wave.
They follow the same laws like lasers and optical light. Yep, that's.
But but when you I'll give you another example. Is there more refraction or less refraction with infrared versus regular light?
So according to my knowledge, the longer the wavelength, the more refraction you have.
Wrong. Less refraction.
Yeah.
So we've also done infrared observations as well that confirm what laser testing is doing.
Infrared are following the same rules.
Yeah, but there's less refraction.
Sure.
Yeah.
but every wave that you use as a reference follow optical laws, including refraction.
So what you're saying is there's no way to determine whether or not the Earth is curving or flat.
There is actually, but not light in itself.
So then whoever measured the Earth in the first instance?
I can answer.
How do we know the satellites are in the right location? Because the satellites need an Earth radius in order to go around it. Right?
The satellites need to, in the first place, have a reason to stay in the air. And I wonder what that reason would be on a flat Earth.
What that reason? You act like reality is not the same on Earth. If there's no curvature measurable, then, right?
There's actually
as far as
measurable curvature, but
show me the measure of the curve.
Light.
Show me the measurement of the curve. Show me the deviation from the tangent. The drop over distance.
So I think we just established that your way to establish a tangent is not a viable way to establish a tangent.
It is. You're just doing everything you can to dismiss it.
I just explained.
This is your nah.
So basic physics is not nah. Basic physics means light bends based on refraction.
If there's refraction.
What?
If there's refraction.
What do you mean if we observe refraction?
Well, what do you need in order for refraction to occur?
Just different densities of a medium.
Different densities of a medium.
Yep.
So you only need one medium with different densities?
Sure. Which is air in this example.
I can demonstrate refraction on a flat surface when it's disappearing bottom up. When you demonstrate things on a curved surface, reappearing with the horizon behind it.
I know you want to post a picture of Snell's laws with light refracting on a straight surface of glass and air. But I just shown you different examples of that light.
I'll show you natural. I'll show you natural. I'll show you natural conditions creating bottom-up obstruction over a flat surface. How about that?
Yep. Feel free.
We'll go through a lot of my accounts that I follow. We'll go find this. Now what we'll start with is an in-home test with a flat floor.
So are you going to post something in chat or?
Can you fucking wait though? Are you that much of a little bitch?
No, don't go there, sheepdog. So light bends.
He's being a little asshole.
Alminator, you're saying, I know, but dude, we're not. You don't want to be going there. Don't want to be attacking people, even if they deserve it. So, Alminator, so you're claiming that light bends upward.
Just so you know, John. So light Alminator, there's a video in the side chat for you to watch.
Yeah,
and I've got 100 more.
Okay, so you're saying light bends upwards behind a physical object to make everything appear to be flat, is what you're saying, no matter how far away the object is, right? So the object could be 12 miles away, and it's going to bend up more so than the object that's 11 miles away. You know what I'm saying? You're going to say that light bends upward to fool everybody into thinking the Earth is flat? Is that what you're saying?
No. Light bends downwards, not upwards.
Okay, so how are we going to see what's going on 12 miles away when the geometric horizon is supposed to be 3 miles away? How does that work?
light bends downwards, so it doesn't hit. The light that's hitting your eyes are not a straight line to the horizon. It's bending downwards. So if you can imagine that.
Can you demonstrate this?
Yeah. Let me just explain.
Can you demonstrate this like I did with my video?
Yeah, I don't want to imagine this. I want to see a demonstration because you might be onto something if you can actually show this demonstration. But
so you don't want to hear my explanation. You just want an explanation or a demonstration, right?
Well, I don't want to imagine it, right? Because that's all I've ever done my entire life is imagine that the Earth is a ball, and I'm tired of imagining it. So I'd like a demonstration.
Just trying to explain to you what my reasoning is, but if you want to just see a video, okay.
Right. You look over out at the horizon, and light bends downward to the more dense medium. We get it. Do you have a demonstration of this?
Just give me a second.
well, are you going to put something inside chat? Waiting.
Yeah, just did. By the way, this is not a video made by me, but I did the same experiment on my own. I did also take some pictures, but I can't post pictures in the chat. So you have to take this as my evidence.
Yeah, I've seen this video before. How come the horizon does not appear behind the cone?
Because light is bending.
Yeah, but when we look out and we see things too far away, the horizon is always behind the object that we see too far away on.
I made pictures. I can post a video that I made myself from my YouTube channel, which definitely shows the horizon is not behind ships on the ocean, if you are referring to that example.
No, we know the horizon moves from day to day depending on condition. What I'm asking for is a demonstration over a curved surface where the horizon appears behind the object.
I just posted.
The horizon did not appear behind it.
I just. So Oberfences, if you are brave enough to join voice, lenses are always curved, in case you didn't know.
We know they're curved, that's why they give perspective.
I'm just addressing what Oberfences posted in chat.
Yeah, no, but like I'll say this too: things that appear to be in front of the horizon that are further than what we're supposed to see on a curved surface, they don't appear magnified like they do with your magnifying lens that you're using to bend around the curve.
Scale. I thought the topic was whether you can see behind the physical curve, and that's what my video shows.
Well, I asked for the horizon to be behind the object.
The fitness ball shown on that video also has a physical horizon, which is different from the optical horizon.
Right, you're still not addressing what I'm saying.
I absolutely do. You were asking how we can see something that is behind the physical horizon, and the video that I just posted shows that.
I asked that, but that's only half of what I asked.
What's the second half?
With the horizon behind the object.
Well,
the horizon's not behind the object.
That's the whole point. Yes, the horizon
Right.
is
Do,
not
do we
behind
need
the
to go to the Black Swan?
Yeah, feel free. The Black Swan is exactly supporting my argument.
No, it's not.
You have the oil rig in one picture being shown before the horizon, and on another picture, on another day, in another weather situation, the oil rig is behind the horizon. So how can that actually happen on the flat Earth? It's actually disproving
Why is the horizon not behind your coin?
because it's a horizon.
So the horizon moves in the oil rig picture.
The horizon moves depending on your refraction.
Right. I'm asking for a demonstration of the coin not being visible, and then the horizon, and then you causing refraction, and the horizon being behind the object, not at the object or in front of the object.
Well, if you look at the picture where the coin is visible, then just go back 10 seconds, and then you see the coin is behind the horizon.
I'm asking for the horizon to be behind the coin.
Yeah.
Like it is in Black Swan.
I just told you. Just go at 18 seconds. You can't see the coin. The coin is behind the horizon.
I'm going to show you. You obviously have no idea what I'm talking about.
I'm just talking. I provided you with an example that you were asking for. I'm not sure what your problem is right now. So you were posting a Black Swan image. You were asking me for an example in the real world.
Where's the horizon? Where's the horizon at?
I assume you were asking me how you can reproduce what I'm talking about.
I'm using natural conditions to show you, right?
So
things
video that I posted
disappearing
are not
bottom up on a flat surface. No, you're using a magnifying glass, which is very much more dense than the
So I'm sure you have seen the other picture of the Black Swan, where the oil rigs are completely shown at a different location, and one is partly. Yeah.
They also look magnified.
Yeah. So
which is a property of refraction.
Reality.
Magnification is a property of refraction.
It happens in parallel to refraction, but you are complaining that my video is not representing reality, and now you are saying the
It's
Black
not.
Swan, the second Black Swan image, is irrelevant. Although it's
if you look in the side chat on the hour, I took a screenshot of the coin sitting on the ball, and you see how the horizon is behind the coin.
Mm-hmm.
Yeah, that doesn't happen when you put the magnifying glass down.
So do you realize that in the video the camera is moving? The screenshot that you just took is when the camera is clearly showing the coin in a straight line. And later on in the video, the camera is moving back so that the coin is behind the physical curve, and then a magnifying glass is added so it is visible again.
Where's the curve in the Black Swan? Where's the horizon in the Black Swan? Is it A, B, or C?
So are you talking about the optical or the physical horizon?
Where do you see the horizon in this image?
Which horizon? Which type of horizon are you talking about?
Apparent location where the sky meets the earth, the actual definition of the horizon.
So in the picture that you posted is behind the second oil rig. And now take the second picture of the Black Swan, where the second oil rig is behind the horizon. And now try to explain that without addressing what I just said. Point is, the horizon changes with refraction. That's that's reality. That's the two Black Swan pictures, the one that you posted and the alternative picture that is also posted several times in the Flat Earth channels. These are two images, two pictures from different days of the same two oil rigs from the same location.
Yeah, I'm gonna show you the video that refutes it. Okay.
So can you just address what I say, or?
Yeah, on one day it looks like the oil rigs are behind the curve of the Earth, right?
Right. So the horizon is different in reality on different days.
They look magnified? Why do they look bigger? Why do they look bigger when they're behind the curve?
I don't think they look. Regardless, they may look bigger or not. Even though I don't think they look bigger, they just look different. They have different distortion compared to the other picture. But even if they would look bigger, what's your point? That's exactly the video that I just posted. It shows the same thing.
Magnification is a product of refraction. That's my point.
Yes, refraction. That's the whole point.
Yeah, so when things are magnified, or when things are being refracted, they're magnified.
Not necessarily, but maybe sometimes not.
Not necessarily, but generally in nature, when you see things that are refracted, they're magnified.
Okay, so you may.
There's a video for you to watch right there. And then I'm going to give you another video.
So why can't you just talk, and why do you have to show videos?
Because I have to give you demonstrations, because you literally are in cognitive dissonance and you will not listen to anything I have to say. So we have to come to a common ground.
Your videos are showing exactly the same thing that my video is showing. If you disagree, just explain what is different in my video compared to your videos. Why do you disagree with my Fitness Ball coin video? And why do you keep posting Black Swan?
Because you are not demonstrating reality. You're creating extreme observations to fit what your view is.
The Fitness Ball video shows exactly the same like the different Black Swan images.
No, it doesn't. Are you using the air to demonstrate curve around the Earth?
It's showing reflected light, regardless of whether it's caused by lens or by air. There's a different cause of refraction. I agree, but the effect of the
Do we put like a lens out in the middle of the ocean in order to look around the curve of the Earth? Is that what we're doing? Put a magnifying glass out there?
Magnifying glass is just a way to show how refraction works.
Right. Okay. So again, number one, you didn't show me the horizon behind the coin like it shows in the Black Swan, like it shows in all the other observations that we have going on.
18 seconds in the video. That's what you're asking for.
18 seconds?
Okay, just look at 17 seconds and then look at 18 seconds.
That's what I looked at.
And then look
at the whole thing. I watched all 24 seconds. I didn't see it. I see the coin pop up in the image, but the horizon is still in front of the coin.
At which time? At 19 seconds, right?
The entire time. I never see the horizon behind the coin.
Okay. 15 seconds, maybe.
I took the screenshot at like 15 seconds or 17 seconds. That's when it's above the ball in the air, not when it drops below and you can't see the coin anymore. Then you have to put the magnifying glass in to see the coin, but the horizon is still in front of the coin.
So the screenshot that you posted actually shows the horizon behind the coin.
But there's no magnifying glass because it's an elevated angle.
Yeah, because it's a different position.
Y'all can't be this dumb when it comes to trying to have a conversation. Like, I give you a flat Earth observation, and you literally will just dismiss it.
So
and I'm using naturally observed phenomena. I'm not creating some special magnifying glass lensing effect.
So you were asking me to show something without a lens, just using the horizon, and show you how refraction works.
Well, use natural conditions. Do you even know how we made bottom-up obstruction occur on a flat surface?
I've seen several videos about that. These are just...
Yeah, what do you think is going on in those videos?
Which videos?
When you see bottom-up obstruction over a flat surface, what do you think is going on in those videos?
So, my opinion is one type of video is that someone is moving a coin on a table from close to camera to further away.
Did you watch the video I sent? I'm not talking about a coin on a table where the lens is down below the table, because y'all like to use that argument, right?
You know, I have to give you props to actually address that point, that the camera is below the table. So that's my argument against this experiment. But I'm happy.
Did you watch the video I sent you with by Skyfree?
I didn't see any video that you posted.
Yeah, by Skyfree. 51 minutes past the hour, Arctic blast home observation.
So I'm seeing a video, Shrinking Mill Optical Illusion Viral Hawk.
Yeah, you can watch that one too. That's a demonstration over an obstructed surface where the mill is magnified due to refraction. And then as you get closer and you observe at it, it actually shrinks as you get closer and closer to it. That's to demonstrate that magnification is a product of refraction.
I'm just looking. So I'm actually not sure what this video is all about. So it's just showing something in the distance which doesn't get in a rate like doesn't get in the same rate smaller than the street in front of the car. So that's just optics. That's not magic.
I didn't say it was magic, I said it was refraction.
It's nothing to do with refraction. It's just you have a thing that is way further away from the things that are closer to you. And if you move forward, then the further away things get smaller in a much smaller way than compared to things that are closer to you.
This is how I know that you aren't actively listening. You're just listening to refute. So go back and watch the video again. If you notice, they're actually traveling at a slight upward slope. And as they approach the berm, the mill is actually below the berm on a, like I don't know how many feet below, 20, 30, 40, 50 feet below. So from the beginning of the video, the entire front door of the mill is completely observable, but that front door is not even above the berm when they get all the way to the edge. It's refraction. Now, I will look forward to your second congratulating me on my props for paying attention. So please, by all means, tell me good job again.
I still don't see the problem, but so with the mill, you are talking about this thing that is right beneath the road sign.
It's beneath the guardrail.
Right. So it's at second.
But when you see it at the beginning of the road, when you see it, you see the front door of the mill at the end of the road, over the guardrail.
I'm just trying to find out what you are talking about. So there's a road sign on the left side of the rail, and behind that, so I'm currently at second 26, and on the right side of that, there's an object, which I think you're talking about when you're talking about a mill, right?
Right. So when you see the mill at the end of when he gets to the end of the road, you see that the mill is actually down below his elevation, right? You're looking down at the mill instead of looking directly at it.
I'm still trying to find out what object you are talking about.
Guardrail? You don't know what a guardrail is?
I do know, but I'm not sure what you are talking about when you mention a mill.
Do you know what a mill is?
So I'm not a native English speaker, so forgive me. I just see.
So a mill is a place where it's like a building where there's a bunch of giant saws and they cut wood all day.
So you're talking about the building.
Yeah, it's a sawmill.
Okay.
MILL.
Okay, so when
feel free to look that word up so that way you can learn some more English while you're here too.
So I know mill, like some kind of stuff that is processing flour.
Flour is a flour mill is another type of mill. A stone mill is another type of mill, but this one's a wood mill. They chop down trees and saw them and cut them down into posts so people can build houses and other things out of wood with them.
Okay, so I don't know how
it's a lumber mill.
Sawmills are generally looking like. So okay, so you're talking about the building.
Yeah.
Okay, so it's when the car is way before the curve, it's appearing much higher than when the car is turning, right? That's what you are saying.
Right.
Okay.
Because the road itself is at a higher elevation than the location of the building. So the building should be completely obstructed. But because of refraction, it's being magnified upward into the air.
So again, in my opinion, this has nothing to do with refraction. That the car is just following the road, and when I look at the road, when the car is still in front of the curve or on the edge of the street, the street is going a bit higher on the curve, so the car is leaning upwards when it goes through the curve. So that the street is definitely not flat. I think we can agree on that.
It has nothing to do with the street.
It absolutely does, because you are saying the building is going down when the car is driving through the curve. And if the car is leaning
upward... You think I'm making a flat Earth observation on this?
I'm just addressing what video that you are posting.
Do you think I'm making a flat Earth argument for this video?
I don't even think it's a flat Earth argument. It's just addressing how.
But do you think I'm making a flat Earth? Do you think I'm making a flat Earth argument?
You are just explaining what you see on a video.
Nice. And you said that this is how perspective works?
Yep. If a
How does
camera is
perspective
pointing
work in this?
upwards, then things that are filmed by the camera are moving downwards. That's just basic perspective.
Yeah, but it's behind the corner of the road. It's at a lower elevation. When you get up to the turn of the road, the building itself is at a lower elevation than the road.
Yeah, it always is.
Right. I'm not disputing that. What I'm telling you is that it's being refracted upward to look like it's at the same elevation of the road.
So
if you go back to the beginning of the video, you'll notice that the front door of the building is actually level with the road at the end of the road.
Yeah. So
right.
I agree. At the beginning of the video, you can see much more of the bottom of the building compared to the end of the video.
Right, because it's being refracted upward.
No, it's not refracted. It's just perspective, because compared to the building, the ceiling is much smaller compared to when you are closer to the ceiling. The ceiling has a much more impact on your vision compared to a further distant away object.
Okay, so that would mean that a farther away object, when you're at the end of the road, the bottom of the building should not be observable, right?
You mean imaginary? If you put the camera directly on the road and the curve, you wouldn't see the building. Is that your question?
This isn't about the road itself. It's at the end of the road where the cliff is. So it's not the curve of the road, it's the cliff. The fucking mountain that the road is on top of, and at the base of the mountain is where the sawmill is.
Yeah, and that building is still a distance away from the camera, even when the car is driving through the
Right,
curve.
so it's below the top of the cliff at the end of the road.
Yeah. And it was also
right. So why can I see the bottom of the building at the end of the road when the top of the building isn't even with the cliff? When you drive around the corner, you notice the entire building is below the cliff.
So I don't know. I can explain to you with a real daily life experiment. So you can take 2 bottles of water, one being 10 inches away from you, one being 5 inches away from you. If you look from 5 inches away from the first bottle, you can see probably most of the second bottle. But the closer you go to the first bottle, the more the first bottle hides the second bottle. And that's the same effect.
So what building is in front of the sawmill that's making me see more of the building in the back?
It's the ceiling.
What ceiling?
Can we die on another hill? Because this is going around in circles and it's going nowhere. Because you're trying to explain an optical phenomenon to this guy, and either he's too dense to understand what it is that you're saying, or he's being purposely obtuse and avoiding following along. So let's get something else going on.
So, okay, you decide that if you want to go on with that topic.
Have you ever seen curvature of the Earth?
Yep, definitely.
When? Where? How?
When I was at the sea and observed ships.
Okay. How far away were the ships? And
I didn't use a tape measure to know how far away
so
they
then you're
were
just
exactly.
saying. So then you're just saying the boats in the distance are disappearing bottom up, and that's Earth curve, okay? Right?
That's what I've seen, yeah.
Okay, so then that should be geometrically measurable, correct?
No. Incorrect.
Incorrect. Okay, so what do you think I mean by geometric?
I don't know.
Is it the Earth that's causing the boat to disappear, or is it something not the Earth causing the boat to disappear?
So you are asking me what I think you think geometrically means. Why don't you tell me?
I'm defining it with my follow-up. Do you think it's the Earth causing the disappearance of the boat, or is it something not the Earth causing the disappearance of the boat?
It's definitely
Geometric meaning
the Earth.
the Earth shape is causing the thing to disappear.
It's definitely the Earth that is obstructing things.
What is the distance to the horizon where the geometric shape of the Earth would be causing the obstruction?
You are asking me what is the distance to the horizon?
Yes. What's the distance to that geometric horizon that's causing the boat to disappear?
Well, you may know it depends on your elevation. It depends on the actual refraction index at that day, at that weather situation.
All right. 1 foot.
That's
How far
very-
away is the horizon at 1 foot from the water? Above the water, 1 foot. How far away is the horizon?
The geometric or the optical horizon?
The geometric. The thing that's supposed to be the shape of the Earth causing the disappearance of your boat.
So I guess it's 1.2 miles.
You guess? Or is that the math, the geometric shape?
I watched several Quantum Eraser videos, and I think that's what he said several times. So I trust him.
Okay, well, it's not just him. Go ahead and ask Google if 1.2 times the square root of the observation height in feet is a valid equation for measuring the distance to the horizon.
Yep.
It says yes, it's valid.
Geometrical horizon. Yep.
All right. So, why is it that you don't know the distance to the boat?
Because I do not see the geometrical horizon, because I'm using my eyes, and my eyes are using optical. They are using receiving light, and light follows optics and not follow geometric straight lines.
So your base belief is belief. The reason you don't believe you can see the geometric horizon is because you believe there's other things other than the shape of the Earth that's causing this boat to obstruct. But at the beginning of the conversation, you said it's the Earth that's causing the disappearance of this boat.
Yep, I still admit. What I'm saying is you cannot see the geometric horizon because we have air that we are looking at or through when we are looking at an object, and air is affected by refraction. And refraction happens all the day. You cannot deny that.
Sure. Which is what he was trying to talk about. But so why do you believe that you can't see the thing that should be there if you don't have proof that the thing that should be there is there? Because you can never see the proof. Why do you believe that?
I'm actually not sure what you're asking at the moment.
Okay. I'll rephrase it. The Earth is supposed to be obstructing the boat bottom up. You're telling me that you can't see that. You see something else. So you believe it's still the thing. Why do you disbelieve your senses?
I can see boats being obstructed bottom first. Just not at the location where you assume or where the calculated geometric horizon is, but much further away. And the reason for that is that light is bending, and it's bending behind the curve, and that's why the light hitting my eyes are showing where the band light hits the surface.
Okay.
It's that simple.
So you're assuming the Earth's a ball, and you're admitting that you're seeing farther than the geometry tells you.
So if I would assume the Earth is flat, then I'm still looking for an explanation why things would be obstructed bottom first in the first place.
Yes, which is why I posed the dichotomy at the beginning. Is it the Earth's shape, or is it something else? Obviously, if the Earth's flat, and it's not the ground obstructing the object, then it's something else.
Yeah, if you have a viable explanation for that something else, feel free
is what you're saying it is. You're saying I can't see the geometric horizon. The only reason I can see farther is because it's optic. You're putting to death your geometric claim and substituting for a belief system in optics.
So I think it's not a belief system. Optical laws are very well established in optical device manufacturing and everything else. So if you have an explanation of why things disappear bottom first on a flat Earth, feel free to explain.
That is why we have this argument, is because you're saying that it's supposed to be the ground that's making the obstruction. And you're saying all of these optic laws exist, right?
Mm-hmm.
The way to know the difference between it being a physical obstruction and an optical phenomenon is to identify the distance to the horizon and compare it to the claim that's being made. If the observation is showing the horizon at a farther distance than what the math is telling you it should be, then you're not looking at that geometric claim.
No, but that's exactly the problem that I'm trying to address.
That the optics is making up for that geometric claim. You're not seeing the geometric claim. You're just asserting that the geometric thing is there, but I don't see it.
I see the geometric thing, but I'm combining geometry and optics.
If you're seeing farther than where the math says the horizon should be, you are not looking at the geometric thing.
Yes, that's what I'm saying all the time, because you cannot just pick geometry and just ignore everything else. Nature is doing several effects happening at the same time. One effect being geometry, and the other effect is optics.
So is the horizon geometric?
Reality trumps belief.
Does that mean the horizon's not geometric, Alminator?
So if you ask me, that question doesn't make any sense, because the horizon is what we see optically.
Right. So is there any geometric
What we're trying to do is measure the distance to the horizon, which would be the distance, and where we stop seeing things is where it's beginning to drop off. So
Sorry, you're breaking out.
Yeah, we're determining where the sphere edge horizon is that limits what you can see.
So do you think any one that explains the globe to you thinks that what you can see is the physical horizon?
All right. So Alminator, wait a minute. So hold on. It's sporadic. So he's been
just explained why.
Have you been listening, sporadic? Have you been listening to this conversation?
Past
so
5
Sheepdog
minutes.
was talking to him. Okay, Sheepdog was talking to him for I don't know, maybe 20 minutes. And then Tactical's been talking to him. So he's saying he is not going to believe that things can disappear from the bottom up unless there's another explanation given.
Okay,
right?
So when do we have things disappearing bottom up?
I was asking for an explanation.
He's talking about both.
Yeah. Show me an example of a. Show me a bottom-up disappearance, and I can give you any explanation you want.
So, if you have a viable explanation on a flat Earth, just post it. I will.
I need you to provide an example, because I don't know what you're talking about.
I'm asking you to provide a viable explanation of how things.
Why do I have to explain something that I don't believe is occurring?
On a flat Earth. I think that's what you're believing in.
No, nothing's disappearing bottom up the way you think it is.
That's what we see.
No, it isn't. Show me an example. I want you to show me an example of curvature, blocking things bottom up.
We were talking about things disappearing bottom first.
Oh, wait, so let me guess. If I have a fence that blocks me from the waist down, therefore from the bottom up, is that the curvature of the Earth?
Sorry?
If I have a wave in the foreground blocking a boat that's 30 miles away bottom up, is that curvature of the Earth?
A wave is not curvature of the Earth, no.
No, of course not. Or how about a standing wave like shoaling? Or how about a successive series of tides that are so small that you can't make them out individually, but together form a wall of water blocking things in the distance? Or how about a marine layer of heavy turbulence because of a massive air temperature differential between the surface of the water and the air above it, blocking things bottom up? I mean, that's not the curvature of the Earth either. So how many explanations have I given you? Maybe 3 or 4 so far? I can keep going.
So I've given you a fourth explanation. So
well, where's the curvature of the Earth then? Because if you can never actually see it, then why would you assume it's there?
Where's the standing wave?
It's called shoaling. SHOALING.
Where's the standing wave? So you are asking me to provide you where's the curvature. I'm asking you one of your
an example of shoaling? Okay, I'll pull up a Wikipedia page on shoaling if you want to see what shoaling is.
I can show you an example of Earth curvature.
Oh, great. Do that, please. I want to see Earth curvature. I've never seen it before.
I'm sure you did.
No, I never have. If I did and it was true, I wouldn't be here.
So I'm pretty sure whatever I post here, that's called fake. And
you don't really sound confident in your own evidence.
I'm absolutely confident. I just
okay,
know
great.
I've talked
like he's poisoning the well.
How about you post it? Okay, I'm going to put you on mute until you do it. Yeah, keep laughing. I'm waiting for you to post your evidence.
So you know he doesn't have image frames.
Oh, how funny. Well, he can DM it. Well, he can't DM it to me because I don't accept just anybody. Well,
that's fine. He can DM me if he wants.
Yeah, he can DM any. He can post a link. You know, it's like, I bet you've seen this before. Well, if we have, then how come you are not listening to what we say about it? Yep, so he still hasn't posted anything. Should we play the Jeopardy theme song, or can it be here all night?
Yeah. Not only that, but I had like a 20-minute conversation about like atmospheric conditions that could cause refraction, and he didn't even want to go down that rabbit. That was the whole point of me explaining the shrinking mill and refraction works. Is a product of refraction is magnification. That's what lensing generally does. There's special conditions where it doesn't do that, but most of the time it's just going to produce anything that seems to be refracted will appear to be magnified, and so that's how you tell if there's refraction. If something's magnified behind the curve, and then when it's in front of the curve, it's not magnified. Guess what? I tend to believe that's a little bit more refraction going on.
I would even challenge that personally, so I wouldn't go down that route.
That's fine. I'm all about it, but I'm actually in a bad location, so I can't really. We'll get into it one day, sporadic.
No, like really. There are other explanations that you can get into without calling it that.
Oh, I know there are. I'm just saying this is just one example, and I use magnification as the byproduct for refraction. I posted several videos in the side chat.
I don't think the air acts like that at all.
So basically, back to this guy, because he's the guy who's in contention right now, right? So he's basically stating that light bends downwards and allows us to see over the curvature of the Earth, no matter what, and makes the curve invisible to us, right? Not perceivable whatsoever. that it automatically does this. So we could either see further than we're supposed to, or we're going to see less, right? And yeah, none of it really makes any sense because it's like a blanket statement, right? It says hand waves dismiss. Hand wave dismiss all laser observations, saying lasers are doing the same thing. Technically, is
right.
what
It sets it up to be unfalsifiable, right? It's wholly unfalsifiable when you say those things, Alminator. Right? Because you're claiming now that any time that you see too far, that is further evidence for how much Earth is obstructing things in the distance with its own curvature. See how silly that sounds?
Hey, by the way, he posted the blue marble for his evidence of curvature.
Oh, for crying out loud, dude.
And I posted a rebuttal.
The 1970, the 1970 alleged government space.
That's right. He had to go to an Apollo mission.
No, it's not even. It's the Robert Simon one. It's the composite. It's not even the freaking. Not even the freaking photograph. Oh my God, that's even funnier.
No, that is a 1972 one.
Oh, is it the 72 one?
Okay, yeah. So that was supposed to be an actual photograph.
We got no evidence outside of this.
How can a misrepresentation of reality supersedes reality?
Oh, don't worry. He just dismissed every long distance observation, every laser test, and said, "Oh no, it's because light bends." I don't know how it works, but it does. That's the way it works. So you can't convince this guy because he's already made up his mind that no matter if you shoot a laser, like a $30,000 laser over the surface of the Earth, it's going to curve down and make it look like the Earth is completely flat.
He called it perspective. He said refraction is due to perspective. That's what he said.
He's here in bad faith, obviously, then. Yep, he's gone. I tossed him. 59 hour ban. Gonna have time to deal with this. Can't even use people like this for a good exposition.
I put on a clinic for 20 minutes. I had a little bit of fun.
Yeah, so he was trying to bait over fences, trying to get her riled up. So then she wound up asking me, "Oh, is he unmuted?" Blah 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 blah. Then he finally starts yapping, and he's just waiting for his opportunity to do the same dumb junk that he does every single time. So I think DJ spent a good period of time talking to him on several occasions. I know a bunch of us have. So
Same here. I was disappointed to hear him yak.
Yeah. So, at least you ended it. So let's move forward. Let's not give him any more airtime talking about him anymore.
That's pretty ballsy of him to do, to post a Wikipedia entry to Blue Marble and say, "There it is. There's my proof of curvature that you've been waiting for the past 2 hours with me," or whatever. The past 2 weeks he's been in here. Yeah.
Still can't validate the radius value because he accepts that he's looking for the geometric value, but he can't find the geometric value because the optic value is hiding it.
Right. So the more it's hiding the geometric value, the more he's emboldened to say it has to be there. The less you see it, the more it's there. We know how much Earth curves by how much it looks flat, guys.
They will say, they'll give this observation, right, where they put a coin on a ball, and then they lower the camera, and then they use a magnifying glass to bring the coin back up into view. That's fine, but I want to see the horizon behind the coin. That's what I want to see. I know refraction, you can bend things up with refraction. I'm fine with that, but I want the horizon to be bent up too.
Did I robot out? Bending actually occurs. I mean, I see.
He doesn't care. It doesn't.
I see stretching and
you already heard him say it.
Turbulent warbling, but
if somebody tells you that no matter what you show me, I'm not going to believe what is actually happening, then how could you take them seriously? But they're going to believe a photograph and believe that a space agency did all of these Apollo missions all in one presidential administration and never after that one presidential administration. I mean, it's crazy. You're going to tell me you're that much of a skeptic, but that much of a believer at the same time. It's kind of nuts. Do we have anybody in here who's on the Globe side that has any questions? Anybody who has any questions on the Globe side or any Globe evidence that they'd like to present? Anyway, sorry if I cut you off sporadic. Good on everybody on the panel that's here on the flat Earth side. Good on you guys. You're all having a great day or evening or morning.
yeah, thanks. Likewise. Thank you, John, for holding things down. Sheepdog too. Tactical Droid, you guys are friends.
Yeah, no, it's sorry, I meant to say thank you also, but no, it's one of my favorite conversations. Like I want to see people give me this demonstration of the horizon behind the object over a curved surface, right? Because that's what we see in the Black Swan. We see the horizon behind the shit that's not supposed to be there.
Because if what they're saying is true about the geometry of the path of light, then it's the same as if you, the observer, were lifted up by the amount that is proportional to what should be behind the curvature of the Earth. So if you're seeing the bottom of oil rigs on a globe Earth due to what they claim is some kind of crazy refraction, then the angle of view that you would have from your feet all the way to the bottom posts of that boat should be similar to the angle that would be if you were 66 feet up off the ground, lifted up, looking down. The whole plane of vision should rotate. And that's not what's happening at all. Like they would need, in my opinion, they would need more than just a simple curve in that path of light. They need more complex curves going on. You know, and they'd need it also in a way that retains image fidelity.
And really, if you think about it, all we need is about a 1.33 degree deflection. And that's probably what's going to create the illusion of a surface.
Like if you take Skunk Bay, you know, it looks like a hot mess of turbulent effects. The images are being stretched and smudged and compressed. The more there is some kind of impedance between the far field and the near field in your vision, the more things tend to lose fidelity. But, you know, these people come in and claim that there's an increase due to those same kinds of effects at play. Right. And the other thing that's missing is, like what you mentioned, Sheepdog, is basically the rotation. You need to see more of the surface of things, more of the tops of things. So in addition to seeing the ground itself kind of rotated up so that you have a wider angular field of view to all things on the ground from your feet off to the horizon, we should be able to see the tops of distant objects that you were once looking more obliquely at a glancing angle at should now be opened up a bit and rotated too. And that is not portrayed at all by Skunk Bay as an example, or any other example that's ever been provided. It's a consequence of what they claim is refraction. And I'm not going to get too bent out of shape about that term. It does seem like this field needs to do a better job defining things, because they'll call the law of refraction something in a very specific sense and then apply it more generally beyond that. And it causes confusion. Big deal. So what?
Yeah, I like refraction. I don't have a problem with refraction.
I think it's important in many contexts to point out, because it's almost like it's being used as a very sloppy word that can open up for multiple meanings and therefore abuse of definitions and terms in order to suit agendas for certain arguments that normally wouldn't stand a scrutiny. I mean, like, even worse than that is like, it's about as bad as gravity, but K-factor, right? The entire thing of what K-factor embodies. I mean, there's just so much slop built into this. It's disgusting. And everybody knows it.
But it's not just that. There's like my thing is like, here is a demonstration by a wonderful account on YouTube called Skyfree, where they use naturally occurring conditions to demonstrate bottom-up obstruction on a flat surface.
Yeah.
And so I have no problem with that, because we're observing natural phenomena. Right? And I don't know what's going off in the distance over 10 miles, 20 miles. Like, sure, there could be a temperature inversion at some point. I don't know. I'm not going to say that is the cause. I'm just saying, here's a demonstration on a scaled down version of a flat surface with bottom-up obstruction using naturally occurring phenomena.
Yeah, exactly. The only thing that they modify in the room is the heat. is the temperature in the room. That's all they're doing. Right? So whatever we're seeing, exactly. So whatever we're seeing is a result of the change in temperature, affecting the the light bouncing off the object back to the viewer, the camera. So the only thing they're manipulating is the temperature. And they actually have like a thermometer on the ground, they've got like different levels showing the changes as well. It's like they've got like a multi-level thermometer happening when they do this.
Yeah, mad respect for them for like going out, doing that. Like I got a girl. There's a girl I know on X. She wants to start doing that too because she is starting to think that is the main cause for bottom-up obstruction. So she wants to put together science experiments. And I trust that she's going to try to do the right thing because she's a PhD student. So her PhD is on the line also. You know what I mean?
And I think it's important to point out that the obstruction is really, I guess, in a sense, that the light is smudging and colliding with itself.
That, or just even if there's a deflection upward, it's going to push the image of the object down. And what happens when it gets pushed down from that location? It's going to appear to be going over some physical thing.
It's so much about this brings to mind like how they cherry pick, right? In this case, what they're doing, they're leaving out the time component. They'll show you like an image of this happening, and they'll leave out things like the conditions, the actual conditions. They'll leave out what happened before and after to make that image possible. Because you go out on different days and you'll see different things. It's just like with the sulfahexafluoride, they pour gas into a box. And I'm reminded of when my Omaha steaks came. They came in the frozen ice, the frozen like oxygen or whatever that was, nitrogen. And I was telling people yesterday, I put the big bags in the sink and I tore the bags open. I was watching it sublimate, like just totally turn from solid into gas right in my sink and disperse. And I come back later and it's all gone. Like it's all been completely diffused, completely dispersed within the air. But they'll leave out the time component. So they cherry pick, right? And they'll show you like a guy pouring the gas in and say, see, look at that. Look at that. Gotcha. But guess what? It's freezing freaking cold. So it's got a higher density, which is displacing the lesser density medium around it. And, as it warms up, it's coming to equilibrium. It's, in a sense, also cooling the environment down around it. And that gas is going everywhere. Like it's going everywhere. You can't like scoop it in your hands. So it starts off slow. You can like see it. It's still fairly condensed because it has an opacity to it. It's white compared to everything else in the room. And it starts to just fizzle out and randomly in all directions, except of course the ground. Because the ground is super dense. But they don't want to point that out. They don't want to show you the full take. They only want to show you a select few frames of that take. So they'll cherry pick the power lines. They won't show you what it looked like that morning or that evening. They'll cherry pick the sulfahexafluoride and won't show you what happened for the sulfahexafluoride to get into the container in the first place, let alone what happens 30 minutes later after it's been poured into an open container. It's such like the dishonesty to me is so disgusting by grown-ups. Like these are the kinds of stupid tricks that I'd expect. I shouldn't say it. But you know what I'm trying to say. Who do they think we are?
What is the seminar about?
Hello.
Hi.
Sorry, yes, what is this about? We were just talking about evidence and the lack of it for a globe.
Excuse me? Can you repeat that?
Yeah, we're just talking about the lack of evidence for the globe.
Oh, about Laos. I see. Is it why nobody can talk?
Okay, we got some people at work, some people just getting off of work. We run a pretty well-organized room with good discipline.
Wait, you're into something.
What is going on?
I don't know, Jedi.
Oh, you heard that. Fair enough.
I'm hearing English, but it's not making sense.
Kinda crazy.
So, for the new person, the reason 20 odd people don't all talk at once is you won't be able to hear a thing. So, it's much easier if they just speak one at a time. So, if you have any questions you'd like to put forward to the panel, please do so.
Well, cool.
Look, Bev, some Bevite just pinged me and said, send in Sporadic Echo. He's next on the QE chopping block. I had better things to do with my time than to sit there on mute.
Yeah, I wouldn't mind it, excuse me, if he didn't mute people in there and let them have their say, but the fact he just wants to grind through the video and just have a one-sided blast and not let them have their say, that's weak. I'm sorry, but yeah, I listened to it for about 15 minutes. DJ was just red flagged, and I'm just sitting there going, well, at least let him respond or show that you've taken it out of context, which I could quite clearly see that he had. But yeah, that was me. I just went, yeah, nah, I'm out.
I'm shocked that somebody finds me important enough to talk about.
I'm shocked any of this is actually taking place.
Not that you need to throw gas on the flames, but it'd be funny to release all of the complaining that QE did in everybody's DMs, how he was banned from the place he's now deeming the land of mystic toys, or misfit toys. He's saying that we are now the land of misfit toys, the place he was begging to be let back into.
Hold on. Land of Misfit Toys, that's Earth Awakenings.
No, we are it now.
No.
It's the name of his new video.
No, see, now that's disappointed me. I don't think he'd at least come up, because he's really colourful, they'd at least come up with another name, not the Land of Misfit Toys, that was used.
Yeah, I mean, he's not that creative, I guess.
I'm really disappointed. That's a shame.
This is Quantum Eraser. What happened with him?
If you duck on over to FED, you can find out for yourself.
Yeah. You'd have to ask QE what happened, I think. It's just, I don't even know anymore.
For some reason, he chose DJ to pick a fight with. I can't understand that.
I do.
Oh, yeah, he said refraction. And
yeah, the reason for it is DJ actually very calmly goes through and explains all these effects quite clearly to anyone that asks about it. Whereas QE, here's Snell's law, choke on it, shut up and get out of my way. See the difference?
Yeah.
That's why it gets in his face, is because he doesn't have...
There are too many people, see?
Okay, I'll have 2, please, before you go. Oh.
I came here again because everyone is Indian. No idea why. I just came to the server and I couldn't find anywhere else to talk.
Oh.
You're going to find it hard talking, isn't you? You're going to interrupt conversations.
Hint.
There's no Indian.
Hi, anyway. How are you? We'll put a pin in that, mate.
I'm bad, bro. As I was saying.
I don't think this will take long anyway.
I don't understand you. No, your accent.
You don't understand what he's saying because of his accent? What? I understand you and you have an accent. You understand me?
I understand you, but not Jedi.
Something tells me you've had a run-in with the Jedi before.
I don't know who is Jedi. I mean...
I think he's telling you that you're not speaking English, Jedi.
Yeah, I think I understood that.
He has a good accent. That's what I'm saying.
Good. So what
the
do you
most
want?
English person here, and you don't understand his English.
Yeah, for sure. He's the most English.
Yep. Yep, most definitely.
I'll try my best to understand.
Okay. What do you want? How can we help you?
Just chatting. I needed to chat.
About what?
About anything, but not about Indians' politics.
Okay. In this room that's titled the 24/7 Flat Earth Room, we talk about the Earth being flat and how it's not a ball in space orbiting the sun.
But you guys are serious.
Yes, very serious. No tone of voice.
So, what is the evidence?
Well, the water doesn't lie.
Yeah. Did you ask what is the evidence? The evidence is the surface of the Earth being measured to lay horizontally. Water, that's apparently 70% of the surface of the Earth, lays horizontally. So if the Earth was a sphere, that would mean that the waters would curve over distance, because that would be the surface of a sphere. It would curve. But the surface of the Earth doesn't do that. It measures to lay horizontal. So it can't be a sphere. It's measured flat.
But it's a long distance, so...
All distances. At all distances, the surface of the Earth mean sea level is measured as a horizontal reference datum. It's horizontal.
Isn't it close to horizontal?
No, horizontal. If it was close to horizontal, it wouldn't be horizontal. It would have a rate of change of slope. The Earth's surface doesn't have a rate of change of slope. Its orientation is horizontal, perpendicular to vertical.
Well, alright, but what do you think about gravity? I mean, the force between subjects.
The force between...
In smallest terms, like...
Yeah, no, these are just concepts that make the world go round, to coin a phrase. It's mathematics that's associated with the Earth being a sphere and explanations why things don't fly off of it and appear to go downwards. So it's a made-up story. It's only relevant to a sphere. The Earth isn't a sphere. Things go up and down because of their relative density. Why they work along this vector of up and down, I don't know.
What can we know about the this downward vector? I mean, like, regardless of the shape of the Earth, if you just assume negative 9.81 meters per second squared, that math is what we base a lot of stuff off of. So that has to be something, whether or not it's mass attracting mass, it's something.
Yeah, I mean, look, like I said, right? From a flat Earth point of view, we can only observe the observation. We can measure the rate of fall of solid objects, for example, but that doesn't mean that we can assert a cause other than the things that we can vary and manipulate. And the things that we can vary and manipulate only make the objects move in this up or downwards direction. What causes that? I don't know.
Sure, but I don't think it's right to say it's relative density, because
scientifically,
why can't it just be a downward force?
Well, scientifically, that's what you're going to be observing and manipulating. The object that's relative to the medium that it's in and their densities to each other. Because of their relative densities to each other, things will work up or down.
Why do things fall in a vacuum?
I don't know. Do all things fall in a vacuum?
Yeah. Okay.
What happens if I put gas into the vacuum? Does the gas fall into the floor?
It will. I mean, if the energy leaves the gas.
No, the gas will have temperature. That means it's always going to move, which means it's always going to have collisions, which means it's always going to expand until it reaches the expansion or the limit of its volume. The gas isn't going to stop.
When the gas cools off, it'll fall to the floor.
When the gas cools off, it'll fall to the floor. No, when a gas cools off, no. If we have one gas, excuse me, if we have one gas that's reducing in temperature, it's not going to fall to the ground. It's going to stop moving as much and become denser.
But all those gas particles are still objects subject to whatever this downward force is. So
no, not observably, they're not. Gas has the power of indefinite expansion. Robert Clark Maxwell.
I don't know. We can observe gases falling to the like. Have you ever put I think there was a science experiment when I was in school where we tried putting dry ice inside, and he had a vacuum bell, right? And the smoke from the dry ice still fell to the bottom of the container, even though it was in a vacuum.
Because it's more dense than the medium it's in.
Right, but the medium, if there's no medium, like if there's nothing in...
That's right, there's no medium. So it stacks itself, it layers itself. That's all that's happening. Every single claim that you make about gravity, whichever form you take, can be quite comfortably explained away with buoyancy and density. Without even trying.
So
at the moment, with your example, you had your vacuum chamber and the smoke just went to the bottom. Why? Because there was no medium to hold it up.
Yeah. So, but okay, I guess something that is confusing me is like, why can't we just call that a force? Why can't we just say, like, there's a force associated with the downward direction that all objects...
There's no downward direction.
And not all objects follow it.
All objects do. All objects are subject.
Sorry, no, your floating gas does, but it doesn't do what you're saying it does. Gas expands.
So gas is not subject to gravity.
But you're saying that it is, but observably it isn't.
So no matter the density of the gas, it's going to go up.
Density? How do you cause density of a gas?
Gases have different weights.
They're different atomic weights. That doesn't mean that when you put them on a scale, they're going to press down. That means their atomic structure.
Very, very sensitive scale, yes.
No, not a very, very sensitive scale. Gases move and have collisions. What will happen is the gas will press upon and fuck off. But the atomic weight, that's the amount of its structure, the amount of electrons.
In chemical engineering, we use it as the mass of the gas.
I understand, but you're not listening to what I'm saying.
So how about this? Let's say you've got a tank.
Mass is an
that's empty. That's got a vacuum, and then you put a gas and you weigh this tank to see what its weight is, and you put a heavy gas in there, into that tank. You can measure it
gas isn't going to stop the heavy gas from expanding. The reason why it's not expanding is because you've got to. I actually fucking let you get to the end of your point.
Okay, sorry.
So we're asking you how you keep the gas from expanding into available volumes. You've put it in a container that restricts its expansion, and then you put it on a scale and say, look, all the gas inside the container that's moving freely and randomly in all directions, having collisions with itself, is all going down. That's not true. The gas inside the container is moving freely and randomly in all directions and only limited by the container, because if you open the container, it's going to start reaching equilibrium. If there's high pressure in a container, it's going to leave. If there's high pressure outside, it's going to enter.
Yeah. I mean that's what's going to happen in the case of like a tank.
That's the law of nature. So that's what's going to happen all of the time.
Like the gas pressure laws that we're working with here, they're derived from
law of thermodynamics.
What did you say?
Second law of thermodynamics.
Yeah, I mean, yeah. The gas pressure laws that we are.
There's a monkey. Thank you.
The gas pressure laws that we're working with are derived from molecular interactions, gas particles.
Experiments.
What do you say?
They're derived from experiments.
Yeah, no, you're right. So we can get the same gas pressure laws from experiments, the same laws that we can derive using only the physical interactions of molecules. I had a professor that went through this whole derivation where he started with, okay, you're assuming some amount of gas particles. Here's the number of collisions that they have with each other. You can reach the same gas laws that we use every day by deriving it from the ground up with these molecular interactions with each other.
Okay. Within the gas laws, what's the cause of pressure?
So pressure is when a lot of gas molecules are bouncing off of each other, and the cumulative number of collisions they have with the material around it, the material that's containing it, as you would point out.
Yeah.
The cumulative interactions it has with that wall is pressure.
Yeah. So the amount of collisions that the temperature has with the walls of its container. So you require a physical container for gas pressure. So you require a physical container for gas pressure.
When there's no container, what you're left with is still just a bunch of molecules that all are still subject to the downward force.
No, that's an imaginary idea that you keep bringing up. When you open the container, the gas that's got energy given to it by temperature has free and random collisions. The power of indefinite expansion, being as now the system is open and outside isn't available volume to fill, the gas is going to fill it.
Yes. No. And it, like in pretty much all examples in daily life, that's what we will see.
But in all examples of daily life, because this is a natural law.
What happens when a gas is opened up, when you open up a container and it flies all over the place, that is a result of more basic fundamental laws about objects being subject to forces and colliding with each other.
Entropy, dude. No energy has been imparted to the system when you open a container with pressure within and less pressure without. It's no energy change, it's a change in entropy.
I'm losing
gas fills the space. The mixing of ideal gases, gas expansion into a vacuum, entropy. It's
Yeah,
a law of nature that happens all of the time.
The behavior of gases is not the fundamental cause. What the fundamental cause of all this is that it's a bunch of objects with mass, molecules that are interacting with each other, and it just what we've been able to establish common like
because the little molecules of gas have got mass that the gas doesn't expand.
The gas okay, I'm not disagreeing with you that the gas does expand. What I'm saying is that the reason it expands is because of more fundamental laws about what objects do when they're interacting with each other and subject to forces. Not that
within
gas
equals nRT, it's because of the gas collisions, because of that constant motion given to them by temperature. Temperature gives them the energy to move, so they move. The reason why they change direction is because they have a physical collision. The reason that they expand is because of the amount of physical collisions and the amount of volume they fill. The reason why they don't expand is because there's something physical containing them. When you open this thermodynamic system that has got energy and particle matter within it, and you open it, the gas that's got energy expands.
I'm with you. But I'm with you. But obviously, what we're talking about really is how this is possible on the Earth, right?
Yeah, we've got a vacuum and we've got gas pressure.
The reason that I was trying to explain that ultimately the cause of all these gas pressure laws is the more fundamental interactions. When you look at when you say, okay, if there was this force called gravity, and if gas molecules are just particles of mass, what would they do? All of them would still be subject to this force towards the Earth, and it would, no matter how much energy, threw them up. There's a ton of energy. I mean, the atmosphere is very tall. There's a ton of energy bouncing them around, but it's not like they're being pulled up. Nothing is pulling them up. They're hitting each other and pushing each other up. But at the top, there's going to be just fewer and fewer balls bouncing.
More space to fill.
But vacuums.
You're trying to shut up. It's like no one said pulling up. Don't know where you started building this bloody straw man from. Like the sky is pulling the gas up. No, I told you at length that the gas that's got the temperature, it's got kinetic energy, is going to move. Now, the only reason why it changes its path is after a physical collision. Otherwise, a gas molecule that's left the surface of the Earth and moves upwards and doesn't have any physical collisions isn't going to fucking come back unless it has a physical collision with something restricting the volume, like a container.
But a gas particle, under the Earth model, again, this is making a lot of assumptions. What I'm trying to establish is that under the globe model that it would work. It would work. Under the globe model and with gravity and stuff, the gas particles would eventually come back to Earth because those gas particles are subject to gravity.
What's gravity?
Gravity is this force that's we have discovered that where mass attracts mass.
Okay. All right.
We can talk about gravity, but do we want to try to wrap up with the gas particle stuff?
No, from a strictly scientific point of view, no, it's not mass attracting mass. I mean, you've heard of Einstein, right? And general and special relativity and the bending and warping of space-time and that stuff. Yeah, that's what they talk about nowadays because the mass attracting mass, that was superseded in 1915. There's no science for this magic at a distance. I mean, all I have to do is ask you, how does mass attract mass, this instantaneous action at a distance? What's the mechanism? You'll splutter like everybody else, and then you'll start talking about Einstein, who described the mechanism as the bending and warping of space-time.
We have evidence of mass attracting mass. We've found we can calculate a consistent coefficient of mass attracting mass.
Really? Can you provide me a scientific experiment, please?
Yeah, I mean, look up I'm sure you know of it, the Cavendish experiment.
Okay. So the Cavendish experiment. So this was done how many years before?
Huh?
The Cavendish experiment. This was done how many years before Einstein came along and ripped this apart because mass attracting mass, even with your circus fucking show that isn't a scientific experiment, is instantaneous action at a distance. It violates special relativity, which takes the speed of light to act.
Well, the experiment is just it's setting up an observation. Like Einstein has a different explanation for how gravity works, but Einstein, it's not like Einstein is going against the results of the Cavendish experiment.
Yes, he is. Did you not listen to
what's wrong? Because we have
you require citation.
Can you repeat your?
Do you require citation that backs up my claim that mass attracting mass violates special relativity because of the time coordinate? It's not the same. Like, let me emphasize.
My position. Let me
emphasize. No, let me emphasize. Okay. Newtonian physics works in three-dimensional space. You might start understanding that Einstein, that's got a time coordinate. That's four-dimensional pseudo-Riemannian space. They don't even happen when explaining the phenomena within the same geometry. It's completely different mathematical conceptions. They're not the same thing.
Okay, I'm losing you a little bit, but basically, what my understanding is, so the Cavendish experiment, it's been replicated many times. I saw people do it in my engineering courses.
Same results.
It's a set of it's an experiment. It doesn't say anything about what. Can you? What were you saying?
With exactly the same results.
If you do it well, you can get consistent results across many different mediums, and yeah.
No. You kind of must understand as soon as you said, well, if you do it correctly, all right, if you get the results you're supposed to get, then you
can do an experiment badly or well. You can do it.
You get varying results. You get three different types of results. One is no motion or oscillation on the axis. Two is a vibration away. One is an attraction, or described as an attraction to.
Yo, hello there. Hello there, guys.
So this is one of the things about the Cavendish. It falls apart on all four steps of the scientific method. Doesn't have an observable natural phenomena. The independent variable isn't physical, it's conceptual. That's mass. The experiment isn't a scientific experiment because it's not based on a true hypothesis. And the repeating and validation of
I'm in Antarctica, guys. I'm in Antarctica.
Thank you. The step 4, the repeating and verification of the experiment, you get varying results. Like I said, if you get the thing to work. So no, it's not an experiment. That's why they moved away from it.
Can I go through those? But can you remind me just like of the first one?
Naturally observed phenomena. That's a phenomena happening in the world. The thing you see.
I mean, I would argue that the natural phenomena that we're observing is an acceleration imparted to objects when they're nearby a mass, an object of mass.
Without all of the fluff,
direction and distance of that mass.
Without all of the fluff, and acceleration, what?
An acceleration imparted on an object that it corresponds with the direction and size of a mass.
Mass, okay. You'll need R for that, which will be the Earth being a sphere, but I'll sidestep that. This acceleration is that in the vector down, perpendicular to horizontal.
So the natural phenomena that the Cavendish tries to observe is when you put a massive object near another, smaller object, how much acceleration in the direction of that larger one does the small one experience?
Not a lot. Sometimes quite a bit. Sometimes it doesn't move.
I agree. I agree.
Sometimes it doesn't work.
And can I explain kind of like why I think it's okay that we get different results?
No, because every time that I boil water, being as that the pressure's the same, it's not going to not boil water sometimes.
Okay, so the Cavendish experiment is very sensitive. It's trying to observe a very, very weak force, right? We know we think of it as a weak force. I mean, it's trying to observe something very weak. If you take a bunch of first year engineering students, which this experiment is often done because it's good at separating the wheat from the chaff a little bit. Some of them are not going to be able to control the variables that they need to control in order to actually be able to see the acceleration from the noise, from the oscillation.
Yeah, no, I've done it.
Oh yeah? Well, how did it go? What did you see?
Not very well. I mean, we had a very expensive science laboratory at our school. Ours was a grammar school, different grammar school to Americans. This is where the high educated kids go. So we had quite a few of these experiments. I mean, after a few years, they kind of just got left to the side, to be honest with you. My personal experience is you have to be very, very careful to get any type of result. Any.
I agree.
Yeah.
But what happens, the reason that I think it's valid,
which is a problem.
So if we accept that the Cavendish is...
Get this right. Only going to circle the results that appeal to you.
So, but if we find a method that is very precise and where we are able to eliminate a ton of noise, and we consistently get the same value, which is what we've seen, then we're measuring something real.
No, we don't get a consistent value, which is what I'm trying to point out to you.
We do.
We don't.
Yeah, we and with their. I mean, I don't want to appeal to.
You get a consistent value when it works, all right, and you can circle the results that you like, and you do the experiment correctly. Yeah.
Well, okay, so let's get rid of this concept of big G, right? And we're not even trying to calculate big G. We're just trying to see mass attracting mass, regardless of how strong it is.
Okay.
You can see videos of people doing the Cavendish experiment where it's very clearly there's an attractive force between them. Huh?
What's mass?
What's mass? Mass is like it's like the how much an object resists a change in velocity.
Yeah.
When force is applied to it.
Okay. So how much something is hard to move?
Huh?
How much something is hard to move?
Yeah, basically.
So,
yeah. How hard is it?
So how much something is hard to move attracts something is how much is hard to move?
So the definition.
No, bro. Address that, bro. How hard it is for something to move attracts how hard something it is to move. Is that right?
Okay. Yes. Are you
fucking kidding? Excuse my language.
The property that makes something hard to move corresponds to.
Oh no! So now it's not the amount that it moves. It's not its restriction to motion, or its restriction to resistance to motion. Right? Not that.
Sorry, I missed the beginning of that.
So it's the property that gives it that ability. Make up your mind what mass is, bro.
I think that mass is it is both the property of an object that makes it hard to move and a property that is attracted to other mass.
All right.
So, yeah, and what the Cavendish gives us is that when you do it well, and you may not believe that we can get consistent results, but when you plug in the value, when you've done the Cavendish many times and you found a consistent result, you can plug that in, and you can change the mass, meaning, okay, how hard is this to move? And it matches up with the force, with the resulting acceleration. And we do this.
It's mass physics.
You can then plug that into the model of the solar system and all of that matches up perfectly too.
Oh shit! You're using that word perfectly again. Describing mass attracting mass physics to the fucking universe. Shit, that's a problem.
Yeah.
Yeah, that's a big leap. And no, it doesn't. That's why Einstein stepped in. Hello.
But Einstein changes what we. Einstein changes the prediction.
You said matches it perfectly. All right. Does it perfectly predict the motion of Mercury? Does it perfectly match the motion of Mercury?
Perfectly is not the good word here.
Okay. So now it's not perfectly. Right. Okay.
I concede it's not perfect. I concede, but the model for predicting the motions of the planets is extremely accurate. Extremely.
Time. Which one? Newtonian physics that breaks down at the solar and galactic level. Einstein. Because we have the distortion of time in space, don't we? As well as the three-dimensional time between objects. Because of the displacement of mass within that four-dimensional pseudo-Riemannian coordinate system, mass no longer attracts mass, it bends space-time.
Okay. I'm fine with that. I mean,
so let's get to mass then. So I posted a citation in the side chat because everyone seems to be very confused what the term mass was. So I'll get one for you. There's a few. I'll start at the beginning.
I think there's a lot of evidence. I mean, Einstein's understanding of gravity makes sense to me. I don't see what the issue is.
Einstein's model of gravity makes sense to you, yet you're standing here trying to defend Newtonian physics, which violates what Einstein speaks about it. Special relativity, like I said, for maybe the fifth time now, could be fourth, but probably the fifth, violates special relativity because of the action of the speed of light. Instantaneous action of mass.
Okay, we can talk about the semantics of
semantics. So words mean things.
Yeah. Okay.
And I'm telling you what they mean.
Newtonian physics, regardless of what Einstein did, Newtonian physics is still incredibly accurate as a model of reality, and that's the. It's easier to talk about because you don't have to couch things in the special Einstein language, but it's describing the same things. It's describing it's a model of the same
of the observed phenomena.
Huh?
Yeah. Different causes, same phenomena. So which is the real gravity if you've got different models that propose different causes?
Well, it's a model. It's a model.
Yeah, so which one's it's like you didn't listen to the question. I'll give it to you again. You've got two models that say that the causes are two different things for the same phenomena. So which model is the true cause?
Einstein's model is more accurate. So it's likely that. But I mean, but neither Einstein nor Newton, they don't really put forward a reason why this happens. Like we're getting into the why question.
Cause. Now, don't put forward the reason why it happens. That would be a cause of the phenomena. Yes, they fucking do.
Gravity.
Shut up. Dude, don't lie to my face. You've literally been here defending it for the last half an hour. The cause being mass attracting mass. You've just turned around and said, don't give a reason. Well, I'm not talking to you anymore, dude. Wow.
What we observe is mass attracting mass. And both Newton and Einstein...
No, we don't. Go and let a helium balloon go.
Huh?
Go and let go of a helium balloon. Mass attracting mass. That would be mass fucking off away from mass.
So,
gas.
Let's go through.
It also goes away from mass. Bro, you're inserting your cause into the observation.
How so? Should I do the balloon thing?
All you observe is motion. And then you go, well, that's mass attracting mass. I'm observing it, declaring the cause.
I can come back to the balloon thing, but what the Cavendish shows is that there's motion, there's an acceleration specifically that is measurable specifically when you place a mass next to the test objects.
So what you're claiming is your gravity is just a mathematical formula.
No, gravity is a force.
Yes, because that's what you're using to explain it. Listen quite carefully, my friend. You need to understand this bit. Listen, science to date does not know what the causational mechanism of down is. Newton, mass attracting mass. It's a formula. Einstein, the bending of space-time, mathematical formula. That's all they are. They are a mathematical formula to describe shit going down. They don't know what the causational mechanism is. You're claiming it's mass attracting mass. It was just a formula. That's all.
So, okay.
Throw some numbers at it. That's about it. Now, if you go back in history and your Cavendish quote-unquote experiment, you'll probably find they were looking for something else.
Probably. Science.
Yeah, maybe you should go and look that up, mate.
So, I mean, science comes into winding path. We find useful experiments that maybe they weren't intending to do okay, but let me respond to this thing about like gravity being like equations.
You don't get it. There is no gravity, mate. What you claim is gravity is just a descriptor for things going down in the medium of air. That is all. Measured at 9.8 meters per second squared, approximately.
Okay, so what you're saying to me is that neither Newton or Einstein are providing a cause explanation for why.
Excellent, he gets it.
Right. Okay. I think I agree with you, but the way I understand it is that when I say mass attracting mass, this is like it's hard to give another explanation for this phenomena that we describe. Right?
Oh, the bending and warping of space-time, that's what Einstein did. It's like you're not listening.
Okay, but I'm just trying to speak English here, right? Like I'm just trying to explain, okay, there's...
what language you speak, you need to make sense.
Why are you trying to explain something what is science? You need to make
I mean, I know we're fighting your ideas, dude, but I've put citations in the side chat that show that you're just wrong.
What how do you see this?
I'll read them out to you. So Newton's classical mechanics were superseded in the early 20th century when Albert Einstein developed his special and general theory of relativity. The mathematical equations of Einstein's general theory of relativity, tested time and again, are currently the most accurate way to predict gravitational interactions, replacing those developed by Isaac Newton several centuries previous. Newton's two crowning achievements, I love this one, the laws of motion and the laws of gravitation that had reigned supreme since published in the Principia in 1687 were toppled from the throne by Einstein. So these citations, that one was Douglas Klein, professor of physics at Chem Libertex. So wow. In 1916, Albert Einstein published his general theory of relativity in full mathematical detail. That opened a window on a radically new framework for physics, abolishing established notions of space and time and replacing Newton's fundamental formulations of the laws of gravity. So the gravity that you're talking about has been superseded, replaced, toppled from the throne by Albert Einstein more than 100 years ago.
Einstein's gravity explains things that Newton's gravity does not. And so Newton's gravity does not work as a model.
Does mass attract mass?
Okay, how about this? Let me take another angle. Why can't I describe mass attracting mass? Why can't Einstein also be describing mass attracting mass?
Because he's describing that the mass isn't actually acting over distance on each other. The mass is sitting in a four-dimensional fabric, and because of the amount of mass, that space and time is distorted and curved. So another body of mass that is also distorting space and time, when they get closer together, their straight paths now become curved, so they appear to attract, but there's no actual attraction between them.
Okay, I'm not. what you're saying makes sense, but it just seems so superfluous. I mean, like, we're talking about the phenomenon of objects
this is all bollocks,
towards each other.
I'll tell you why, because this is all conceptual. It's probably why you're finding it hard to understand. It's all conceptual. It's all made up bollocks. Space and time aren't actual physical things. I posted earlier that mass is only conceptual. Right, it only really takes place in mathematical formula, but mass in of itself is not a physical entity that has power. So all of this is conceptual. None of this falls into the realm of natural science. There's no science here. Like I said, I've cited everything that I've said, including the remark about mass. That's conceptual, it's not physical.
I agreed with your citation. I agree that Einstein has a better model of gravity than Newton does. It's just not my. But that doesn't get rid of the fact that we have this force of gravity. That Newton and Einstein both have models for how this force works.
Yeah, who cares? Neither is scientifically validated.
They both are.
And every single one, when you mention the Cavendish experiment that were trying to find out the density or the weight or the mass of the Earth, had a radius value, which gives the Earth a spherical shape. You're going to need the Earth to be a sphere to talk about Cavendish, dude.
This is a different argument. I mean, we're talking about
trying to figure out the weight of the Earth. Cavendish, you brought it up. That's the Earth, a definite size with a radius value, a sphere.
Right, but we're talking about like, if the globe model is true, if the globe model is it internally consistent?
Then there would be a radius value.
So proving curvature is a different argument.
Well, you're going to need curvature for the R, for the mass of the Earth, when you're doing your Cavendish experiment to find G.
Actually, no. You don't need...
you don't need the mass of the Earth? That's not what Cavendish was trying to figure out?
I think I see what you're saying. I think he was trying to find the weight of the Earth. But the reason that that we're doing the Cavendish experiment now to find the weight of the Earth is... it's very difficult to get a mass value from just a radius because you don't know what the density is going to be of the Earth.
Exactly.
And so
you've got a radius, though, haven't you?
If you find
got a radius,
big G value, then
you need R before you get G.
Sorry, what did you say?
You need R before you get G.
You don't.
Really, you don't need the radius of the Earth.
The radius of the Earth is independent of the mass of the Earth.
Really?
Yeah.
Seriously?
You're wrong.
You can have very large.
So a smaller radius would give you a more dense item, and a larger radius would give you a less dense item. But the radius doesn't matter.
The radius. So if you're talking about the mass, I'm not talking about the density. I'm talking about the mass. If all you have is the radius of an object
in science, mass has no definition.
Huh?
Exactly, dude.
In science, mass has no definition. It is not defined because it's such a broad spread word. It can be used in multiple instances.
Mass.
That's why they don't use it.
When you get into string theory, crazy quantum stuff, you can get in lots of...
Oh, how about you go back to the basics instead of string theory and quantum crazy stuff? How about you just get us an R value to start off with?
An R value? What I'm saying is that the R value of the Earth doesn't matter for the Cavendish.
Cavendish is just a parlor trick. For some reason, you can't see past that.
I've seen a lot of evidence for the Cavendish, though.
What you've seen is the Cavendish experiment, quote unquote, and I love when they call it an experiment. What you've seen is that parlor trick set up, if you do it correctly. Now, what happens if you've got a rod suspended and one side is heavier than the other? What happens?
I'm sorry to leave right now, but thank you. See you guys.
Oh, thank God.
He had to bow out.
My God.
He couldn't handle that. His whole paradigm just falling apart right in front of him. He's like, I gotta go. I can't handle this.
But again, I will find interesting. You will explain all atoms, molecules, gas laws, space, forces, everything. But to see the horizon on 10 miles, no. You are not capable to do that. That's too. No, we are not speaking now about the curvature. I want to explain something. Gravity.
Yeah, he wants to argue gravity. Meanwhile, he probably knows nothing about it. I mean, you guys are schooling him on like every freaking thing, but he's in here arguing about it. It's insane to me. Insane.
I wanted to bring up the fact that gravity is known as a pseudo force or fictitious force. So it's not even a force at all. It's not a cause. It's not the cause. And that even Einstein has stated that gravity has to be caused, right? So, like, there's going to be a G-force if you run your car into a wall, right? You'll be able to measure, an amount of force, per square inch or something like that. Because it's mass over acceleration, right? That makes the force. So gravity's not causing anything. It's not the causational mechanism. And yeah, that kid just wasn't getting it. He wasn't getting it. He had to bail.
But you can ask him, let's see that what you're trying to explain, like a force or not force, whatever, let's see, is that really affecting the surface of the Earth? Because if it's really working in a way how you're explaining, then surface of the Earth must be curved. Finished. If surface of the Earth is not curved, that means that mechanics of that force is not doing that what he explaining.
Like right here, it's Newton is even saying that, you can't have just inanimate brute matter and this other inanimate brute matter. They're not going to act upon each other for no reason, right? So he's saying that basically ultimately he's saying mass doesn't attract mass, right? And not even Einstein says that mass attracts mass, so it's all out the window.
Yeah, it's par for the course. It's like they come in and you got to explain to them their arguments. Then you got to explain to them the priests of their religion and what they actually were saying and what they were actually trying to prove during certain experiments that they like to cite. It's insane. They don't know anything about what they're trying to prove. It's just the hardest part to listen to when they're coming in arguing, and then it's like you have to stop your rebuts to their arguments to explain to them their arguments. It's insane. I've never seen anything like it.
That's what a lifelong of indoctrination will do, man. I get so stuck in this, and that they've heard these things on repeat their entire lives, and it's a psychological thing to hear something enough times and believe that it's true, right? And so, but they believe it without ever testing it, studying up on it, figuring out what it's all about, and yeah, it's pretty crazy.
A question for you. If I prove you that two masses attract each other, you will believe in a sphere?
Nah, because I know the water's fun.
Oh, that mean what? Why I'm telling you about these masses?
It doesn't matter because the water's still flat.
Okay, that mean doesn't matter if I'm telling you this about forces, not forces, whatever. You will not. Okay.
They try to talk as if they're like in a master class level or a PhD level, and yet they're not even at the first, second, and third chapter as far as like we could go all the way back to the history of how this heliocentric debacle religion was created in the first place, and they don't even know the first thing about those things.
I think it's like in school, like they don't believe in gravity. If I show them that gravity exists, they will change the idea, because they don't believe in gravity. If I show you the gravity exists, that means you don't have point. But that's not the point. We don't care about gravity.
Yeah, they want to jump to GPS. Well, GPS works, and we can go to the very beginning. What is GPS using? Oh, latitude and longitude, and explain to them that those are flat Earth measurements. And then they go, no, you're changing the subject. We don't want to talk about that. We want to talk about the 10th chapter, not the first one. Like they forget all about the beginning, the fundamentals. That was hilarious, that last part where he's like, Jedi was trying to explain to him, you need the R value. Like, and then he's like saying, you don't need the R value. Like, let's put this in a logical, like a statement. So in other words, you're supposedly measuring a ball or a sphere, and then you're telling us at the same time, oh, the size of the sphere doesn't matter? Unbelievable.
Somehow, Sonny, it doesn't matter if you have a sphere in the hands. You know that ball what they are throwing, in athletics. That ball, it's heavy, and basketball, it's not so heavy. That means that ball, it's more dense, and have more, it's more weight, no mass. I don't know what a mass is.
Yeah. Then why don't they use a 3-foot diameter basketball then? If the size doesn't matter.
Size does matter because you can make you can measure the drop over distance from basketball, and you can measure it precisely. It will be in centimeters because basketball is small, but there it is for sure. On 10 centimeters, there is. I can say 3 centimeters will drop for sure.
I don't need the radius. I just need we're trying to figure out the mass. What? You tell you burst in this bubble. Hey, mass doesn't really have a definition. It's like, well, I have to go. I have a really important thing I forgot about. I have to leave, guys. I'm sorry. I'll talk to you later.
He's back, but let's say you shoot a basket with a pool ball, if size doesn't matter.
Huh?
Let's try to calculate the mass of the Earth, or try to measure 5 miles of the distance. What is more easier?
I don't know. We could talk about whichever.
We can put the Earth on the weight and see how much is weight, or we can measure 5 miles of distance. Is that difficult?
I mean, I think that I can do both, but obviously we're gonna disagree there.
And what if on 5 miles of distance, if is there nothing happening? If you see the 5 miles of flatness, what then?
Yeah, the whole horizon arguments. It's difficult because
not horizon, man. The surface.
Have videos. We're both
the surface, not
each other.
Not the horizon. The surface.
The surface, yeah.
Yeah, if you see the surface on 10 miles, how you will call that surface?
So if I'm not sure if I understand, but
if you see the surface of the water on 10 miles, how you will call that surface?
I mean, it depends on how high you are, how high the observer is.
2 meter height.
2 meter. I mean, this is so tough because. Okay,
I'm asking you this: if you are 2 meter height and I'm 150 meter height, if you are 2 meter height and I'm 1.5 meter height, and we are standing together on the beach, and if we see the surface of the water on 10 miles, how we will call that surface?
No, I understand the argument. I just we're both going to have.
I will call that I will call that surface flat. Honestly,
know what we want, and it's just not as it's not as interesting because like I can show you videos of like shipping containers where you can clearly see that they are obstructed from the bottom up.
What you cannot show me, and you will never show me, it's this. Okay, this boat, it's covered up on the 10 miles with the observer height of the 10 meters, 7 meters. Distance is that, and drop is that. You will never ever give me that. You will only say, look, the boat, it's disappearing bottom up. Is that correct?
I mean, these specific examples, obviously, it's going to be.
Can I repeat again? You will never ever give me this. The boat disappearing on the 10 miles with the observer height 10 meters and drop is like say 66 foot. Let's say. No, you will not say me that. You will say only the boat disappearing bottom up.
What is your explanation for the boat disappearing?
In which distance is that happening?
Foreshortening.
Huh?
Foreshortening. What he's trying to get to, Ant Monk, is when you come in with your quote-unquote videos that show bottom-up disappearance, you never come back and say, this ship is at X miles, this video is taken from X elevation. It's always just, here's a video. Now, normally, all the videos that you guys show us are at an optical zoom that's at its maximum capabilities, and then you are go away, and then you are claiming here's something disappearing bottom up, without even looking into it. It's a thing called foreshortening. It's to do with your elevation, your eye line, and eye level.
So this is
what happens is due to perspective, things disappear as things. Thanks, Sasha. Just hold up a little second, mate.
Okay.
As things get further away, they appear to get smaller. True or false?
That's true.
Excellent. Now, as they get further away, they will uniformly shrink down. Now, the problem is your eye level is not at the center line of the thing that's uniformly shrinking down. It's at the bottom of, it's at the lower portion of it. So as something gets smaller at the bottom, gets smaller at the side, gets smaller at the other side, gets smaller at the top, the bottom hits your eye line first. That's why they appear to disappear bottom up. It's that simple.
Bottom hits your eye line first.
Your eye line, you're 6 foot tall. When you're looking at that exceptionally large tanker, your eye line is only 6 foot from the bottom of something that's 100 foot tall. So as it uniformly shrinks away, naturally the bottom bit that shrinks away is going to hit your eye level first. So your eye level at 6 foot is going to be gone first.
But your height.
You're not looking.
Your height.
You're still thinking that you're relative to the height of the item. No, you're not. Everything still works within perspective.
So your argument is that
it's not an argument. That's what's happening.
And Monk, can I post something for you?
Well, let me respond to this this boat thing.
I want to post something for you because maybe you experience this. Look at this.
Let me.
So with the boat thing, how about this? The next time you bring forward the claim of ships disappear bottom up, how about you bring forward the exact distance and the exact elevation of the camera, and then we'll see if it's going at the right spot.
If we have a boat that's like very clearly visible, like meaning that there's optical effects are unlikely, and it's clearly dipping below the horizon, like the bottom of it is dipping below the horizon. How can you explain that if the water is?
I posted for you, and I said I will post it for you.
Okay,
and you said wait.
You'll never show it. You'll never show that.
I'll show you that video right now. Let me just find it. Okay. Let me look at the one that he posted though, so I can.
Do you see that football field?
Yeah. Let me watch this video real quick.
It's a GIF. It's not a video.
Oh. Am I in the right chat? It's the football field. Okay.
Yeah. Look, the feet are disappearing bottom up.
Yeah. I mean, to me, that looks like that field is curved.
It's curved. Okay. If you are correct, let's say this is like a half field. This is not entire field. Okay. That means that field it's curving about 50 centimeters per half field to the end of the field.
Okay.
Okay. That means that we have football players who are playing football of 50 centimeters of elevation change on the football field.
I mean, it could be a cheap field, not a professional, you know.
You're just making excuses now.
Jesus Christ! Yeah, it could be not professional. It could be 60 yards changing. It could be. Can you imagine? It could be 100 yards. 50 centimeters of curvature.
Sasha, he won't see that. All he's going to make excuses. It could have a bubble in the middle for drainage.
Do you know that on 1 mile? Do you know that on 1 mile you have 2.5 inch of curvature, and there is on the half on the football player there is 50 centimeters of
but I can find the same argument here for me where it's like, okay, this is a GIF. I don't know where it came from. I can't verify if this field.
It's from the football field. It's a flat surface. You can do that on any flat surface. You can do that on your. You can do that in some. If you find some big flat hole, you know, put the camera down, and you will see that your feet will disappear with this.
I just posted this video here. Let me post the link with the actual timestamp. Or actually, I think it is the correct timestamp. Yeah, look at that. Look at that. Did it get? And let me take a screenshot. Am I able? Maybe I'm not able to post media. Oh yeah, I can't. But if you look at that video, about halfway through, you see. You can see the one in the distance, and you can very clearly see that the bottom is obstructed. And my question is, how does that happen if the water is flat?
I explained it to you. You chose not to listen. So anyways, in the side chat, and Monk, in the side chat, see where you just posted your video?
Yeah.
Directly above that, can you see the two cans?
Yes.
Excellent. The top can, you can see it in its entirety. The bottom can, the bottom of it is missing. You can see that?
The metal ring, or...
Okay, let's look at the top image. See the blue band at the bottom of the can. Excellent. Yes. Look at the bottom image. See the blue band is nearly gone?
I see. I know I see it. I've never... So where is the light? Where the light that's hitting that?
Who gives a shit where the light is? I'll give you the data.
What do you mean? Who gives a shit?
22 feet.
That's what this whole thing.
Well, you can have the light swinging off your ears for all I care. It doesn't matter. Now the data's simple. 22 feet. This was taken with a mobile phone on a flat surface. Phone was flipped upside down as to get the camera lower to the surface. This is on a flat surface. So what we're doing here is showing you what you call bottom-up obstruction on a perfectly flat surface. So you claiming now that curvature, you claiming that curvature is the cause of this bottom-up obstruction is now being disproved by a perfectly flat surface.
I don't accept this picture. I mean, I've never seen this occur.
Well, so basically, this is you. I accept the ball-tard picture. Well, I don't accept your picture. So we're equal. Now prove your curvature.
This is why I don't like the refraction debates. Is we just throw videos and
there's not. Hey, no, stop. There's no refraction debate here. You just said I don't accept your picture. I'm saying to you, I don't accept yours. So now prove your curvature.
Okay, let's talk about this can. What's confusing me is so let me explain what I understand and why this can picture it looks so weird to me. If this is a completely flat floor, then what we would expect to see is when you put your there is not going to be anything obstructing the light from the bottom of the can to reach your eyes. If it's perfectly flat, there should be nothing obstructing the light from reaching your eyes.
Shoulda, woulda, coulda. You got a basketball court near your house?
Probably, yeah.
Excellent. One day when there's people not playing basketball there, because I wouldn't want someone to step on you, go and place yourself at one end of the court, go and place yourself a coin. Then walk down the other end, lay your sorry ass down, and have a look across the court.
Oh, yeah.
And you'll notice you won't be able to see the coin.
You probably wouldn't be able to see
Then go and get some more coins and stack them up. See how high, just wait, see how high that coin stack gets until you can see them.
But where does a light ray hitting the one of those coins? So
we're talking about a flat surface. I don't care about light rays. I don't care about refraction. All I'm demonstrating to you is this effect of bottom-up obstruction happens on flat surfaces. That is all I'm demonstrating. You can make excuses for it. I'm not interested. I'm just telling you this effect happens on flat surfaces. I want you to demonstrate that for yourself. Please go to a basketball court, get a friend to help you, get them to stack coins up until you can see them. And you'll probably find that you'll get a couple of them there and you'll just go, I don't understand. Well, that's a new issue.
If I did it with like a piece of paper on my desk, would that satisfy you? Because that I could do right now.
Basketball court, coins, it's to do with distance and it's to do with your angle of resolution or angular resolution.
Why does it, but if the object is small enough, then...
You can try it if you like, but you'll probably find you'll get down really, really low.
Yeah. Let me look here.
So if your desk is only 2 foot wide, it's probably not going to work.
No, I'm long ways on the desk. I'm looking long ways. So, I think...
Where you got the camera position, you got to have your camera positioned to where it's like replicating you being real tiny on the earth, right?
Well, I'm just getting my eye really, really low to close to the edge of the desk.
Cool. Yeah, I've done this before, and you'll be able to see the, what appears to be bottom-up obstruction, right? It's just an optical thing.
I'm not seeing it. I mean, what?
That's why I said go to a basketball court. You're trying to compare a ship. Okay. Now, this is something you've done. In your video, the one that I won't accept, have you given us a distance? Have you given us, number one, the distance to the ship, and number two, the elevation of the camera? Yes or no?
So I think for the argument that I'm making, the distance...
No, so you're not going to answer it.
Because my argument is just, how could this be possible with flat Earth?
No, your argument's not how is this possible. Your argument is quite clear and was very concisely put out. This is caused by curvature, therefore we are on a ball. It was not how does this work on a flat Earth. That was never presented in any way, shape and or form. You clearly put forward this video proves curvature. And if you read the title of the video, Flat Earth Debunked, Ships Over the Horizon. You did not present this as how does this work on a flat Earth? This was, I'm here to prove the globe.
Okay,
so I want you now to go to a basketball court when you can. I'm not saying drop all your shit now and run. Go to a basketball court, take a friend with you. I'm not here to explain stuff. Go to a basketball court, take a friend with you, take a pile of quarters. You lie down at one end, get them to stack them up at the other, and watch how many they take until you can see them. And that is a flat surface.
Okay, so what I posted there at Monk, what I posted from your video, what's that?
Let's see. Okay, I'm looking at the video. While I'm watching this, can you? Okay, I don't want to distract too much.
What's that that I just posted? It's a snapshot from your video. What's going on? What's this?
Is this a video, or I'm trying to find?
Yeah, that's the video you posted, and it says zooming improves angular resolution and can reveal the boat.
No, I understand. I'm trying to find what you posted. It's
at 10 past 10 past the hour. My name is T-Dub.
T-Dub?
10
Okay.
past the hour.
Let's see. Zooming improves resolution and can reveal the boat if it was not visible due to 1, but not 2 or 3. I assume it's referencing.
That's
I didn't
amazing. Hold on. Can we time out for a second? Because you, sir, posted up that video. That is in the video that you posted to us, and you're having to take a second to read it? Did you even...
Timestamped.
That's amazing. Anyway, continue.
Like I clicked on the link and it went straight to that section of the video. That's the first thing I was saying.
Yep, that's where it took me.
If the guy just posted the single clip, then I would have shown that. But I mean, what I was going for was what I wanted. Just the video.
Okay, so what do you think is happening with that boat right
Like
there?
the ship is in front of the horizon.
Yeah, well, I was going to ask him, do you think that ship's being obstructed from the bottom up? Is that the claim?
Different. So this, what he's trying, what I think he's saying here is that when you zoom in, it can reveal the boat if it was not visible due to unable to be resolved by your eye, meaning it was too far away to be resolved.
So not the curvature of the Earth.
Or I'm not sure what 3 is. So I think what
you were using this as a claim. You quite clearly put that forward as a claim that the ships were being obstructed by the curvature. Well, why is the quote-unquote curvature still behind the ship?
This is not the same video, but what the point of this...
No, stop. That is what you posted for the good panel. Not what we claimed. That is what you posted. That is the timestamp that it went to, showing that quite clearly. As you can see, how are you going to explain now your claim of ship's obstruction bottom up due to curvature, when in fact you can still see the horizon beyond the ship?
But this is probably my explanation for that is that this ship is not far enough. This ship is not far enough to be obstructed by the horizon.
Now do you understand what Sasha was talking about earlier when he said all of the videos that you will show us, or ships disappearing bottom up, will never have their distances, will never have the level of the camera?
Can I explain what the creator of the video...
Hang on. I just watched a little bit more of it, and he says, so... Like, you'll see that the ship's at about 4 or 5 miles out, and it's just too small for you to be able to see. And these cameras are amazing. You zoom in, and you can see it again.
Right.
4 or 5 miles out, is he at like 6 foot observer height? Because that would require your horizon to be at about 3 miles.
Okay, can I try to explain?
He's debunking himself, bro.
I've had people tell me about this slide. Give me a chance to explain it. So what he's saying here is that he's actually making this argument already. He's kind of preempting this argument. He's saying that zooming in can reveal the boat if it was not visible due to the angular resolution, but not due to obstruction. So zooming in can't bring the boat back if it was obstructed. It can bring the boat back into view if it was too small in the optical, too small in your field of view to see, but not if it was obstructed. That's what this is saying. So the example that he's showing there is a boat that can be brought back because it's not obstructed. It was just not visible due to it was too small in your field of view. But if it was, it can be brought back.
How high is the observation video? How high?
That doesn't matter to my argument. My argument is how is that?
It does.
If the water is flat, how can light from hitting the bottom of that shipping container? What is blocking the light hitting the bottom of the shipping container?
What?
How is it possible? What is the light that's hitting the bottom of that shipping container being blocked by?
What are you looking through?
Huh?
What are you looking through?
A camera, I guess. I'm not sure what. I mean, some kind of camera that was used to take this video.
The distance between you and the object is filled with air, isn't it?
Why is the light being blocked by the air?
Isn't transparent.
Huh?
because gas isn't transparent, especially over increased distances.
But why is the light from the top of the boat getting to your eye fine?
Oh, this is slightly different. This would be angular perspective.
Huh?
Huh? The boat in your example, has it gone over the horizon or not?
Yes, it's.
Okay, what's the horizon?
Huh? Sorry, I did you say something else?
Is the horizon? When you're observing the horizon, what is it?
Say huh again one more time, motherfucker.
I'm trying to be a good interlocutor and clarify when I don't hear things correctly. Okay, the horizon is the edge of the edge of your vision, the edge of the of what you can see when you look around a large sphere.
Yeah.
Is it a line of sight tangent? Line of sight tangent?
Yes.
Right.
Yes.
Okay, so it's a limit of vision. Why is the vision limited?
Because where there's earth or water, light is blocked, and so as you raise your eye line, eventually there's not going to be earth or water.
Vision is limited because of the angular size.
Well, the horizon is because there's an object, the Earth, that is blocking half of your.
The horizon is the limitation of your ability to resolve the surface at distance. Eventually, imagine that surface of water was a chessboard. It makes the example easier. You notice that the horizontal lines and vertical lines get closer with distance and to the horizon, right? So this can be represented in angles. Right, with distance, you'll notice that you won't be able to resolve the black and white squares from each other because the angles are too small. Eventually, those angles become so small that you can't resolve them anymore. This extinction limit...
Totally make out the different shipping containers. You can see that clearly.
So I try. I won't bother again.
My question stands. Where is the light that's hitting the bottom of the shipping container going? What's blocking it?
It's not going anywhere. It's just you can't resolve it because it's so small.
But it's the same distance as the rest of the boat.
This is why I brought up the horizon, right? Because, yes.
The horizon is important here.
Right, okay, it's again... I mean, look, it is quite complicated, so forgive me if I sound long-winded, but if you want to understand, then you're going to have to pay attention.
Okay, give it to me.
Just the way it's got to be, dude, if you want to know.
Let me get some paper. I've got it.
I don't need you to be facetious either. I just need you to open your ears.
Sorry, that was snarky. Okay, go ahead.
Yeah, I mean, right, anyway. Reason why I brought up the horizon is because it's angles, right? You understand that things with distance reduce in angular size. When you look across a surface with distance, the surface reduces in angular size. Eventually, you're not going to be able to resolve it anymore. This will be the extinction limit of your view. That will be the horizon, where the surface that you can no longer resolve appears to meet the sky. Now, you're talking about an object sitting on that surface beyond the horizon. The bottom of that object is probably in that angle that you can't resolve because it's on that surface. As it sails away, the bottom of that object that's in that angle is going to keep descending into that angle. The reason why the boat appears to go down is just angular perspective, angular reduction at distance, so the top appears to get lower downwards to the midpoint of your view. Also, if you're a 6-foot observer and you're observing a boat that's 60 foot tall, for example, you'll understand that there's more of the boat above your eye line than below your eye line. That means those things that are below your eye line are going to start disappearing faster than those above your eye line because there's more of it above your eye line.
All right, let me respond here. So, what I think is happening in this video is that the horizon is defined. So in my model, in my understanding of this, the water is curving, and the lights from the water, the light is being blocked by the water. Like the light is being obstructed by this bulge of water, essentially. But so the horizon is not like this optical effect. The horizon is literally the furthest distance that you can see on Earth. So it's you can still get angular resolution. Yeah. But okay, let me
may I jump in at this point?
Let me finish this one thing. So, but I see what you're saying about the horizon being this optical limit if you're on a completely flat plane and if you can't zoom in, right? You can't increase your angular resolution. But here we can increase our angular resolution with the camera, and we can still resolve things clearly beyond that horizon. And why would we be able to resolve things above the horizon and not be able to resolve them below? Because perspective depends on distance, not on height.
And well, no, it does depend on the height of your eye in comparison to the object that you're observing. Like I mentioned, if you've got more of the angular size of the object above your eye line and less of the angular size of the object below your eye line, the bottom of the object
that far away, your height doesn't matter. It's so small in your field of view. Like it's tiny in your field of view. Your height where you are vertically does not factor into the perspective there.
Oh, it will. When you're looking across the surface, for example, if you change your altitude, you're going to be able to see more across the surface because you've changed your angle to the surface.
But you're changing it by a fraction of a fraction. Right. When if you sit down or you stand up or like you're changing your angle or like even from a boat.
Yeah.
If you're changing your angle towards the object by such a small degree. Like it's tiny. There's no way that could have could make the whole bottom of the boat disappear.
All right, so bro, there's going to be more than just that involved, right? We're not going to commit a single cause fallacy. Now, you just before you go, DJ. Sorry, man. Earlier, you said I could show you where it's clear, right? And there's clearly no distortion. Well, this is from your video, bro. All right, where he's trying to show an example. Now, to the right of this, he's panned over and there's like some sort of little sailboat or something. You can only see the top of it, right?
Okay.
And then he pans over while he's dissing flat earthers to this other object on the left. And you can clearly see some miraging. Yeah, okay, right. So where's the clear imagery that you were talking about where there's clearly no miraging going on?
I agree. I see miraging there. But that's not enough. That's not enough.
Hand over to DJ
to account for the whole bottom of the boat.
And Monk, right? Let's go over a nice clear observation where we have all of the variables and everything that we need. Okay. All right. So this is
my argument again is that we have all the variables we need here.
No, you don't have the observer. You don't have the observer height. You don't have a distance marker to the ship or the horizon or anything like that. You haven't taken readings of the temperature in the air, right? So you don't know what type of miraging effects are taking place from point A to point B. But I have a very, very nice observation to share with you right now, which will debunk your observation. Okay, so let's go over it. I can easily, right? I can just say that you haven't accounted. So even just according to your own side, right? Just according to your own side. Okay, this isn't accounted for here, right? So here's Oxford. Okay, Oxford sinking. Okay, so what is sinking? Right, a refraction effect in which an object normally visible on the geographical horizon apparently sinks beneath it. Okay, so according to your own side, right, so this is something that can happen, right, and it's something that wasn't accounted for in this particular observation. So
wait, so on your own side, there's another reason why, and you're asking us why?
You didn't tell me at the meeting. Okay, I want to learn more about this. Where can I learn more about this?
I can teach you more about it because I've studied it a bit, right? So I'll send you some more links though, because I don't expect you to just listen to me. Okay. But this is just me parroting the mainstream, like your own side.
Right, because I've never heard of this.
Yeah, so sinking, something, right? So sometimes, have you seen those images where it looks like there's floating boats?
Yes, I have.
Right. So sometimes you can get the opposite of that, right? Where it looks like there's sinking boats, right? It's called sinking. Yeah. It's like the opposite of looming, according to the mainstream. I just want to point that out, right? So, okay. So yeah. So sometimes if you have those particular effects at play, it can look like something that's normally visible on the horizon is sinking behind the horizon.
Yeah.
So I can show you examples where in the morning.
What refraction can also cause to happen? I'm sure you know what I'm saying. It can cause things to loom as well, meaning
yeah, that's what I just said. I just said that.
Okay, this is why I don't like this. Is because we're just going to throw images and videos back and forth, and we're not going to get anywhere because both of us are going to see refraction or some property of light. I don't like to have these arguments.
Yeah, but you can't make the same rebuttal with what I'm about to show you. That's the thing, because it doesn't fit any of those mainstream reasons. So just let me present this one. Right, so this is Dr. John D. Okay, he's a PhD. His PhD is in the field of optics as well. Right, so he's from England, and he set out originally to debunk flat Earth, doing different types of observations and laser tests and things like that. Right, so this is him setting up his camera at 3.5 foot height.
Yeah.
Right, and he's got a wind farm out in the ocean. Okay, so that's called Rampion Wind Farm. And the closest windmill tower is on the left. It's 8 miles away. And the furthest one on the right is 11.2 miles away.
Okay.
All right. So remember what you said earlier, right? So here's a diagram just to reinforce what you claimed earlier. Right. This is what the horizon would be. Okay. So a man standing on a sphere would observe the physical geometric horizon at a certain distance, which on the diagram is represented by the red-yellow circle. The physical geometric horizon is the maximum distance, right, that the sky can be observed to meet geometrically, physically, according to the geometry of the globe, right?
Yeah. You don't have to go through all this.
So let's just go over the math. Let's go over the math really quickly.
I'll just plug it into the calculator.
No, I got I got a screenshot right here of the calculator for you. Okay, so we put in the eye height level, 3.5 foot, distance to horizon, 2.29 miles. Okay, obstructed object part, which would be the 11.2 mile windmill, 52 foot. Okay, so we don't have the horizon at 2.29 miles, right? We can see the water far beyond far beyond where the geometric horizon must be, and far beyond the wind farms. Okay, we don't see any visible miraging effects whatsoever, and we can also see a boat at 14 miles away that we've tracked on the radar that should be completely hidden behind the curvature of the Earth, but we see the whole boat. Okay, so we don't see any obstruction of the wind farms, we don't see any sign of the geometric horizon, and we don't see any signs of any miraging effects at all in this entire observation.
Well, those the towers look squashed.
No, they're not squashed, and luckily Dr. John D is a very smart guy, right? So he this is from an 1.5 hour long video where he goes over everything, right? Every single rebuttal that you could possibly have. Okay, so here's a close-up of what the here's a close-up.
Look squashed, and
no, it's not squashed, right? So here's a close-up, right? You got to remember the wind farms that you're looking at in the observation are 11 miles away.
That's the question.
Who was that?
I plugged it in, and I agree. That's pretty wild.
Yeah,
I agree that there'd have to be, like, in order for me to account for it, there'd have to be some pretty significant refractive effects.
Yeah,
but
so if the Earth were a globe,
I think that my video would also require some pretty significant refracting effects to account for it on your side, and thus we're at a stalemate.
No, it's not at a stalemate because there are no refractive effects that can account for this, right? We can see a refractive effect. Like, firstly, we don't know the observer height. We don't know the distance to the horizon, and we have literally an Oxford citation saying that there's a refraction effect where something that's normally visible on the horizon, right, could be sinking beneath the horizon.
Our claim of geometry isn't dependent on these observations. It is for you.
But
you're claiming that these observations confirm the geometry of the surface of the Earth. We're not claiming that.
If we're we got to get it. I mean, I'm down to look at this like bottom up thing, but I've never heard of it before, so I need to learn.
Right. So I can explain more about that if you need to. But look, let's say, okay, now we can determine that your ships over the horizon argument isn't necessarily a valid argument unless you can account for the meteorological conditions that may be causing that sinking effect, right? Yeah. And the ocean swells, right? The ocean swells is another thing. Because when you zoomed right out, ocean swells look like when you zoomed right in, on something out in the ocean swells become uniform and you can't tell that they're there. But if you zoom right out again, right, sometimes you can see there's like 6-foot waves in the foreground, but when you zoom out, they become very, very uniform and it just looks like a flat surface. I can show you examples of that, where you see giant waves and then the person zooms in and it just looks like a flat, calm ocean, but obviously those swells are causing those 8-foot waves, 6-foot waves or whatever, right? So there's not one observation from the globe side that shows a boat going over the horizon that accounts for the meteorological conditions or the ocean swells and also has, right, obviously distance markers, right, or tracking radar for the ship. So we know exactly how far away the ship is, exactly how far away the horizon should be based off the observer height and all of that. And preferably we would like the water temperature and the air temperature so we can tell what type of refractive index would be present approximately.
Yeah, I agree that there's a lot of unknowns, but when I look at that video, when I look at that video, I just don't see how a ocean swells can
but sinking it can be a combination of things. Like I got a perfect example to show you right now. So this one is good. This will get you to at least understand where I'm coming from with the argument. Okay, have a look at this ship, right? So this is just a Google picture of the ship. Okay. This is the ship that's on the tracking radar here. It's called the Mandarin Arrow. Okay, so in the tracking radar, so I'm going to show you an observation of this ship. Okay, so it's 12.4 nautical miles away, which is, I think it's about 15 miles, right, regular miles. Okay, so this person, he goes to the shoreline in the morning, right, and he takes he zooms in on this ship. Okay, it's anchored. It says in the tracking thing there that it's anchored. Okay, so 9:30 a.m. This is when sinking, according to the mainstream definition of sinking, it's more likely to occur during the night or in the morning when the water is still warmer than the ambient air temperature above the water. But we can get into that after, right? So just have a look, right? 9:30 a.m. He zooms in, and it looks like the ship's hidden behind the horizon, right?
Yeah.
Okay, so this is all out of a video that I'm going to share as well. Okay, so 4 hours later,
definitely you can definitely see the visual effect too. It's pretty pronounced.
You can see a tiny little bit of
like in the one you
mirroring
shared.
effect. Yeah, this guy's got an amazing camera. Hold on, Berserker. Yeah, sorry, Berserker. I'm just going to remove that just so he can concentrate on this one. Okay, so this is the exact same ship here. Okay, so this is just 4 hours later so this is me skipping from the start of the video to the end of the video. He shows in the video the gradual process of the ship becoming more and more visible. And the only thing that's changing is that the day is getting warmer and the weather conditions are warming up. And then 4 hours later, right, he can see the entire ship, right? Now we have a little bit of the opposite effect. Okay, where it maybe looks like it's looming a little bit. But
I see what you're saying, but the visual effect on that ship is so pronounced. And when you look at if you in the video I posted, when you look at
you can see that too.
4 minutes.
I showed you. It's in yours as well.
Well, look at 4 minutes. Look at you don't get that huge slice of the like vertical. You have like just a ton of obvious mirroring. But in the video I show, when you're looking at this boat, you look close down to the bottom of the visible like stacks, and you don't see the same visual pattern.
Yeah, let me just explain that really quickly. So according to that Oxford reference citation that I gave you, right, that's sinking, and sinking according to the mainstream, right? I'm not making these claims. This is the mainstream making these claims, not me. Okay, so they say that sinking is just it's like a mild form of an inferior mirage. Okay, so an inferior mirage, right? You'll get the mirroring effect. Okay, so in between sinking and a mirroring mirage, you'll get a tiny bit of that. It's called total internal reflection, which is the mirroring effect. Okay, so you can see a tiny little bit of it sort of going from sinking into like a full-blown inferior mirage, because you can start to see that little bit of the mirroring effect.
Sinking, because I still don't know.
Yeah, sure. Okay, so it happens when you have warmer water, usually, right? Warmer water, basically a warmer layer of air closer to the surface of the water, and then it gets cooler as you go up in altitude. That's why it usually happens during the night or in the morning, because the air temperature gets cooler during the night, but the water temperature stays pretty uniform, right? And then in the morning it's still cold, but the water temperature is still warmer, right? And then as the day goes on, you can see it changes, right? You get an inversion because the air temperature gets warmer than the water temperature. So you'll have because you have warmer surface, right? It's gonna warm up a little layer of air above the surface, and then it's gonna have a gradient where it's gonna cool down slowly. So according to the mainstream, right, the light's going to bend towards the higher refractive index, right, towards the denser medium. Okay, so the light rays, or the light, whatever you want to call them, light waves, light rays, they're going to bend upward, and it's going to make the object in the distance look like it's displaced downwards. Okay, that's the opposite of when you get.
I'm having trouble finding this.
Yeah, so I'm going to give you. No, I'm going to give you citations right now. I'll give you citations right now.
And for the guy that's asking the questions, all this information that DJ is giving you, is this new to you, or did you know about this before?
I haven't heard of this sinking thing. I had not heard of the sinking thing.
All right. Do you know what mirages are?
Yes.
All right. So he's basically talking about what that is, and specifically, sinking is a type of a miraging effect. So he's probably going to tell you more, but that's what it is. So it's nothing like the flat earthers. Nothing that flat earthers are saying that is like super profound. It's something that everybody should be able to look up for themselves. I'm just expounding on what he's saying.
I'm with you there. I wanted to see. I want to see some pictures of it, because obviously we don't have the actual distances to work with, but if I want to see examples of this sinking, so I can just visually compare it.
Yeah. I mean, I'm pretty sure did you put some images in the text, DJ?
Absolutely.
Oh, DJ, did you?
So I can show you examples of it, and that was an example of it because we knew the distance to the ship, right? So at 15 miles, just hold on a second, right? So at 15 miles, that ship, you shouldn't have been able to see any of that ship. But regardless of that, right? So this is the American Meteorological Society, right? So any of these definitions that go into this database that's been running for over 60 years, right? This is basically expert meteorologists, okay? So any of the citations that they have on the American Meteorological Society, it's basically peer-reviewed by meteorologists that all agree that this is the correct definition of sinking. Okay, so here it says, just what I was telling you, right? So sinking is a mirage, right, in which the image of a distant object is displaced downward, right, like the boat, right? So it's displaced downward. Okay, so because the displacement increases with distance, a horizontal surface such as that of a body of water, right, appears to bend downward. Okay, so I'll let you read over. I don't want to read over the whole thing
like in
because that'll be
Pontchartrain.
boring. Yeah, so you,
thinking is the thing. What I just want to know is like I'm just having trouble finding like pictures, like examples of this occurring because obviously there's
he posted some in the text chat, sir.
yeah. So you posted it. You posted an example, which is your ship appearing to sink beneath the horizon.
Right.
Yeah, every time. Yeah, hold on real quick. Yeah, hold on real quick. So usually when people,
details,
sir,
right.
Can you hear, sir?
Yeah, oh, sorry. Go ahead.
Usually when people start posting things in the text chat, it's a very good thing to do to look to the text chat. I don't know if you know where the text chat is. I think maybe you're lost with that.
No, he does. He posted a video in there.
All right, so you know where the text chat is. So when you see the examples there, and you, DJ was saying that you also posted an example, then I don't know where the disconnect is. How can we help you understand something that we're showing you and also that you posted? Is there some way that we can help you connect those dots?
No, I'm with you. I was looking at his definition, and my problem isn't with the definition or that this is a real thing, but it's like with refraction, you can get into the details of how big of a visual effect can you expect it to have. That's what I was looking for.
But refraction, we're talking about the effect of miraging, right? And so with the refractive index, being what it is, and as meteorologists apply it to like the ambient air temperature outside, then it's going to cause those types of miraging effects. So when they say that this is classified as a sinking mirage, they're actually giving all the variables that would have that occur. Now, you're not just disputing the fact that we're saying this to you based on the information that's given to you. You're saying that you're not agreeing with it based on a confirmation bias that you have towards the idea that the Earth is a globe. Now, you can't make something be something that it's not, right? So we're showing you examples of how this is miraging effects. Now, you have to be able to dispute that from the standpoint of it not being that. Now, that's on you going against meteorologists, not just us. Is that something you can understand?
Right. You have. That's why I wanted to come in on, because you have to stand on your claim that what you're seeing is the result of Earth curvature, and that you have a tangent line of sight, tangent to the edge of the sphere.
Right. So I need to. So I agree with you. I need to give some reason why I think this isn't an example of sinking, basically.
Yes, but, correct. And your reputation.
I need to learn.
Your reputation has to be. Yeah, your reputation has to be backed up with, at least some citations of you saying that this is not the sinking effect, miraging effect. You have to at least do that much. And if you can't support it, then you don't have anything to stand on. It would remain, such as the meteorologist would say, on a horizontal surface, this miraging effect occurs, and these are the examples. You cannot dispute that unless you have a valid claim and or citation to do that with.
Yeah, I mean, you can appreciate the fact that I just learned about this particular sinking effect.
Yes.
The only evidence that I can give you at the present moment without doing research on this is that when I look at the base, when I look at the bottom of those stacks, I don't see the same visual effects that like you see in some of these images.
Right. I get what you're saying, but if something is being shown to you and it's also classified as a mirage, then you can't dispute that unless, once again, you're able to bring some sort of citation against what you're seeing. So any image, right? You can dispute it, but you have to have grounds to dispute. And if you don't have any grounds, it's just going to be your bias.
Yeah. This is where these picture flinging, video flinging arguments always end up. That's why I'm not a big fan of them.
Well, I mean that being the case, there are miraging effects that occur that are classified that when they are seen, this is the type of thing that people see. So we're not okay. So the images that we're showing you are not without merit. They're not just like some flat earther on the internet saying, well, this is not Earth curve based on miraging effect. That these are backed up by people that have studied these effects. So this is something that you need to take into consideration.
Yeah. I just what happens with these is like, so you should the example with the windmills, that's pretty wild. I plugged it into the calculator and I had to bump the refraction up like to like very high, like extreme levels in order to account for that. That's pretty wild. I accept that that's pretty. I need to figure out. I need to learn more about that example. But also, I think that you're in the same boat where I provided a piece of evidence, and you need to find these other factors.
No. Wait. Time out. Time out. You provided some images, right? Is that what you provided? The images of the windmills?
Video. The video of the boats going over the horizon.
Okay, going over the horizon. There's a lot of things that are being as put down as a foregone conclusion. How do you know something's going over something else, like the horizon being the leading edge of the sphere that you think you live on? Now you have to, in some way, give some sort of example that you understand what you're saying. So, can you show us in any way that you know that the boat is going over something, like a horizon, like the leading edge of a sphere? Is there any demonstration that you could show us that you know what you're talking about, other than you just having an idea that you think you live on a globe?
I mean, that's what I think the video does.
Yeah, I know. That's your video flinging kind of argument that you said that you didn't like people doing is what you're doing yourself.
Yeah.
Okay. That's what you said. What you said. You don't like people doing. You're doing it yourself.
But I was pulled into this because I tried to avoid this argument earlier. But
well, I mean, okay. So now that we're down to the nuts and bolts, are you going to be able to provide evidence that video is sufficient with any data that you can back up that it is the edge of the sphere that you think you're seeing?
I mean, that's the argument that I've been making. That
I know, that's great.
The only way to account for. Well, let me respond. My argument is that the only way to account for the bottom-up obstruction in a way that makes sense with visually what the video looks like is if the Earth is curved and the water in that bulge of the Earth is what's obstructing the light from the bottom of the shipping container.
That's great. That's great. I know you. It gives you the warm and fuzzy feelings, right? We live on a globe. Look at that curve. We don't see. Hold on a minute. You're getting excited. So what we go by here is with data. You need to support the information that you're showing us with the observation height, with the distance to the thing and the target, like which would be the horizon. And then we need to know the distance between the observer and the horizon so that we can get at least some kind of detail to know that you know what you're talking about with data. And if you don't have that, it's just your bias.
Weather conditions, surface of the water conditions, temperatures.
Height of the optic.
I think that some of those pieces of data can be implicit and in the video. So like.
No. Wait.
Implied.
Yeah. Wait a minute. Wait.
Clarity of the image.
No, you can't. These things are not. Hold on a minute. These things are not known. You have to present them as something. Let's say you walked into a room presenting something to people and saying, "Hey, this is Earth curve." You don't just declare it. You have to back it up with information to substantiate it. Now, this is what I'm asking. This is what I'm asking of you. Instead of you saying, it's Earth curve. I don't want to hear that. I'd rather hear you demonstrate how you're going to support it with the data. Can you do that, sir?
So, okay, what the data that I'm bringing is this video.
No, sorry, no, sorry, no. The video isn't data.
Height of the optic.
So my contention is that the height of the optic, as long as it's within reasonable parameters, like it's a person. That there's enough of the
reasonable parameter.
Code. My contention is that the height of the observer doesn't matter for this particular observation.
You're not giving us information. You're not giving us information, sir. You need to support it.
There's no height of the observer.
Sorry, the height of the observer is going to change the distance to the horizon.
My contention is that there's no height that the observer could be at that would explain why the bottom of the boat is being obstructed.
You really don't know what you're talking about.
Sorry, obstructed by what?
Well, by water. That's,
by the horizon? That would change with distance depending on the observer's eye height. So forgive me, but it would be literally the first place we would start. How high was the optic above the surface of the water?
Exactly, because if it doesn't match the geometry claim, we can throw it out.
This video is because I don't think you can explain.
No, wait a minute. No, you can't say that. Stop. You can't say we can explain. You haven't explained. You haven't done the necessary detail that you should if you're presenting information such as you thinking it's Earth curve. You need to present the eye height. You haven't done that, and you're trying to get us to turn it around to make us seem like we need to do it. No, you need to do it. It was your video that you presented. You need to come with the data. Simple.
I mean, you can choose, put whatever eye height you want. I don't.
No, sir. No, that's not. No. We can't do that. And the reason why Jedi was saying so is because when you raise or lower the eye height, it changes the distance to the horizon. Did you know that?
Because, for example, Ant Monk, okay, so let's say that the observer's 6 foot, and we find out that horizon is 10 miles away.
Yeah.
That doesn't match your geometry claim. It should be at 3 miles.
But this is
why it's important. That would throw your claim into the garbage, and you'd have to find another explanation.
My argument is that the result, the visual result of that video, is not possible on a flat Earth. It's only
sorry. You can't say that. You cannot say that because there was an example when DJ was talking to you that it is a Miragian effect called sinking, and you hand-wave dismissed it because you said, "Nuh-uh, it's my globe." No, we can't do that.
Isn't that an appeal to incredulity?
I did make an argument for why I don't think. In the example that he provided, there was like a lot of visual distortion right at the edge.
Some mirage.
At the water
Let's show you one that hasn't got any then. What the hell?
And we don't see that in the video that I
did. He did. He showed us one.
Huh?
You showed us an example of sinking where there's no apparent, or no significant amount of mirroring taking place.
I did. With the video?
Yes, the one you're claiming is the result of Earth curvature and not some kind of optical or other effect like swells in the ocean, for example. This is why the data that you're being pressed for by AV is important. You can't just declare that this, because it suits my bias, I like it, I like how it looks, it must be what I think it is. Data is important. Because like I said, if it doesn't match your geometry, then we can throw your geometry claim in the bin.
I'd accept that. I'd accept that the argument that I'm making is not for a particular size of Earth. The argument that I'm making is that it's impossible if there isn't
it already goes hand in hand, bro.
That
goes hand in hand with your claim.
That's a logical fallacy. That's a logical fallacy, and I think Jedi was describing what fallacy that is.
It's an appeal to incredulity.
Yep.
Just because you can't think of a reason why it doesn't mean that it's not happening. For example, I can demonstrate the phenomena of an object disappearing from the bottom up on a known flat surface. Can I explain why it happens? No, but I can show you it.
Can you explain how my argument is an appeal to, or like what I just said?
Because you're basically just saying that you can't think of a reason or an explanation of why this phenomena would take place. It's not an argument, dude. It's just like, what? You just can't think of a reason. Okay.
My reason is my explanation for what this happened, for the result here is that the water is curved.
Yes.
Yeah, but
Yeah, but that means that you would need a geometric horizon at 1.225 multiplied by the square root of the observer's height in feet, which would be the physical obstruction distance for the boat. It has to go over the horizon at this distance for it to be physical Earth curvature. If the horizon isn't observed in its geometric position, then I'm sorry, it's not a geometric horizon.
But I'm not trying to prove with this example because I don't.
You just said again, you've done this before. You've literally just said to me.
Because I don't have the specifics, I accept that I won't be able to prove a specific curvature. What I'm providing is that there is curvature, and that is
no, there isn't. You didn't prove that. That's what we're waiting for. We're waiting for you to actually demonstrate that curvature is present with the data. The data would be sufficient to then give a predictable distance away from the observer to the horizon, where you'd be able to say, I know there's Earth curvature. This is the data. And you could follow up by anybody going out there and checking for themselves. You didn't do that. So your video, basically, you can't replicate it. Nobody can go back out there and do the same thing from the observer's position to the distance to the horizon. You cannot demonstrate what you're saying is true. Therefore, it is just your feelings that you think that there is an Earth curve there. That's it. So it's just your feelings.
What I think is that based on the video, the only explanation that makes sense for the results.
No, that's wrong.
Given the results,
that's wrong. I'm sorry, but that's wrong. That's wrong because we've shown you that. No, wait a minute. I know you don't think. That's the problem. You're not thinking, sir. In this discussion, you haven't been thinking. But when DJ was going through it with you, he was showing you that the Miragean effect called sinking is a possibility that this is an occurrence. And you hand-wave dismissed it and said, no, I think the explanation of it being Earth curve is what it is. That's all you've been doing.
So my dismissal of the sinking was that in the examples of sinking that we saw, there was clear visual distortion that was much greater than the visual distortion.
How did you make that? Hold on a second. How did you make the distinction of what it is if you just heard what it is? You even declared it. This is news to me. I just heard it right now. I'm just learning about it. I've never heard this before. And I clarified by asking you, sir, hold on a minute. Just hold on a second. I clarified too, and I asked you, basically, have you ever heard this before? And you said, no, I've never heard this before. This is the first time I'm hearing it. So you, being somebody who's never heard this before, became an instant expert, and now are telling us that's not the case. It is not the sinking Miragean effect that's occurring because you've already analyzed that. How did you do that within the amount of like maybe 20 minutes that you've been here, sir? And you've been only talking. You haven't looked and researched this. This is amazing.
Provided in the examples that were provided for sinking. So you're right. You're right. I didn't know about this before, but that's why I asked for examples of it. And when I was shown the examples, they all have a visible distortion at the level at the level of the horizon that we don't see in the example I provided. So I don't.
How did you make the distinction? Yeah, no, it's not. We're not going about what you think. You're just somebody who just learned about this today. We're not going based on you. So your word right now as to whether this is or is not sinking is not admissible at this point because you haven't researched it. You haven't appealed to anybody that could refute this. So we're not looking to you to find out whether it is or is not sinking. You haven't done any research on this, sir. So the problem is right now, you're just telling us, and everybody can hear it, is that it's just your bias that it's a globe. That is all you're doing from this point forward. You haven't analyzed it as whether it is or is not sinking, sir.
I'll have to go in a minute. I got a work message, but I know that you'll assume that I'm giving up or that I'm rattled, but that's fine.
No, we're not saying that. It doesn't matter. You can do whatever you want. We're 24/7.
Just come back with proof. Come back with evidence that's the physical geometric curvature of the Earth blocking your view.
And please don't appeal to incredulity.
The summary of this argument about this video is that I don't see any
I know you've already said that, sir. We don't need to hear it as you're leaving.
He's doing it, Jedi.
You want to make your. You're just self-soothing right now. You're self-soothing. You just want to make yourself. Okay, I want to say this before I leave. It's a globe. Okay, bye, guys. Yeah, you don't have to, dude. We already know you think it's a globe. Just go on your merry way. So skip along, dude. We don't need to hear you say it again.
Sorry, no, I should. I
Skip along with no proof, just like all the others. Yeah, we're used to it. No worries.
I've got to read this out. Sorry, I really have to. So, an appeal to incredulity is a formal logical fallacy where someone claims a statement is false because they find it difficult to believe or understand, or claims a statement is true because they find the alternative hard to imagine. The fallacy mistakenly assumes that if one cannot personally imagine how something could be true or false, then it must not be so in reality. He's literally been doing that for the last, what?
Yeah, that's his. He was actually living that logical fallacy out for the past 30, 40 minutes or however long he's been here.
Yeah, man.
He was wearing it like a cheap suit, bro. Like, hey, check me out. Like, we already know you have that feeling towards the glow. Like, we don't need to hear you. He's like, oh, before I leave, I just like to say that I can't see any reason why.
I mean, you can probably hear me smiling because whilst he was talking, I was like, this sounds like an appeal to incredulity. And then I said it, and then when I found the definition, and then I was just like, yeah, this is this guy, like 100% right now. Good times. Is DJ still here?
Yeah, I think we stole
yeah. No,
sorry, man.
I was loving it. No, dude, you guys, that was great. I was listening. That was awesome.
That citation that was read out where it takes place on the horizontal water was awesome. He should have just all stopped there.
Bro, you just told him that this was a sinking miraging effect, and he'd never heard it before, and all of a sudden he's like, "Wow, I just can't believe with all these other pictures that it could be sinking." I mean, look at the distortion. Like, what are you doing, bro? You just heard about what it is, and they show you demonstrations of it, like with these images and such, and now you're dismissing it as if that's not it. Like, how do you know that? How did you arbitrate that, man? Like, it's funny, dude. These guys are like, just, man, it is. I don't know. And that's the reason why when I first started with him, I was like, I want to know if he actually knows what he's talking about or if he doesn't know. It's like, nah, I just barely heard about it right now. Like, really? And now he's saying that that's not the case. Amazing, dude.
Yeah, dude. We teach them about something. And then they become instant experts at it when they admit they never had heard about it like 30 seconds earlier. But now they know more than us about it.
Yeah, CB brings that up. Phantom expert syndrome.
Exactly.
Phantom expert syndrome is when they appeal to some phantom expert. He wasn't doing that. He was the expert himself.
Oh, he was.
Yeah, he was the expert. Well, not only, but like, what was it? 5 minutes after DJ told him, he was already saying, looking at the images, and he's like, "Nah, it's not sinking. This is not sinking." Like, how do you know that, bro? You just learned it right now. You hadn't even researched it. I'm taken back sometimes by these things, guys. Like, I don't know about you guys. I'm just like, I mean, the hard press for like thinking that the Earth is a globe, it like cooks your mind. Like, it just, sheesh, man.
Yeah, it must be a globe. That means I gotta argue for things I don't even know of. Whee!
Yeah, it couldn't possibly be sinking based on my hollow answer with nothing to contrary that with. Nothing at all. Like, I'm just basing it on just like AV said. It couldn't possibly be sinking based on my non-existence of my knowledge on the topic.
Yeah, he couldn't find a reason. Like, I can't find a reason. I mean, I just can't find a reason why this could be, sinking. Like, So cool, man.
He might as well just come out and say it like straightforward instead of beating around the bush. It couldn't possibly, it couldn't possibly be a flat Earth because I can't think of any reason why it would be.
I think he was saying that, but not in those words. He was basically just saying, "Yeah, I just can't have. I don't see a reason why it wouldn't be Earth curve." You know, like.
Mm-hmm.
Anyways, it's already dinner time. I'll catch you guys in a little bit.
See you later.
Catch you later. Catch you later, man.
Later, bro.
That was the hors d'oeuvre.
Yeah, he has a reason why he's like that. That observation can be made, right? Okay, cool. Right, you have a reason. You're proposing a reason. You're saying could be the curvature of the Earth. Could the Earth could be curving, right? You can't conclude from the observation that the Earth is curving, though. That would be illogical. You must now demonstrate the Earth to be curving, and then you have validated or confirmed your reason for the observation. And even then, you might not have. Like, in their own freaking, like DJ pointed out, their own side gives other reasons for this observation. And I just loved, because I was waiting, like I'm waiting to get to the part where he'll say, we show him an observation, another observation, and he says, well, now my line of sight is not a tangent to the sphere. Like he already claimed, specifically claimed that the horizon is the result of the limit of your view of the surface before it's curving down and away from you, being a physical geometric tangent point, your line of sight.
Yeah, something I just thought of a little while ago when Sasha was talking about, like, you can look at the distance, okay, and we talk often about the horizon itself, but I think sometimes what is missed in the mix there, like with this guy, what about the condition of the water up to the horizon? How is that presenting? Because that's a key point. Because on a ball, you would not have the water rising up in your visual range all the way to the horizon. So, so they're like right there. Like there's no way the flat surface, if it was curving, if the surface was curving, there'd be no way that the entire range of the water from your feet, let's say, all the way to the horizon would be presenting as a level plane rising up in your visual range. It's just the way optics work. Like if it was a curved surface, you can imagine the water doesn't look anything. If the water was curving, it wouldn't look anything like that. It wouldn't do any of the things that it actually does in nature. Like when I go out to the harbor, or I'm up on a hill looking at the water in the harbor, how that water spreads out in front of me, going out and higher up as it goes farther out. Yep. That's key. It's almost like what DJ was saying also about, okay, so this supposed tangent from your eyesight to the tangent of a ball. So they want to talk about things like bridges. Well, okay, so the bridge is curving. Okay, great. So is the water curving underneath the bridge? And they want to ignore that part completely.
Yeah.
This guy was
Yeah,
doing
that
the
is-
same. Sorry, this guy was doing the same thing with the eye height as he was doing previously about the radius not mattering. Like it doesn't matter. So he went to the same thing with this. Well, I can't see any eye height that would make any difference in this thing that I don't know what I'm talking about.
Yeah, he wants it to be a battle of explanations rather than him standing solidly on the claim that it's the result of the Earth being curvature. He wants to compare explanations. Well, mine's saying like argument from, well, that'd be more of an argument from credulity, which is more believable, right? Comparison. Two reasons why you make this observation, and then based on why, just reasons, right? Oh, it doesn't look fuzzy enough. It doesn't look distorted enough for me to accept this other explanation, right? No, just stand solidly on your explanation alone. Can it hold together under scrutiny? You don't need a comparison. If what you're saying is true, then let it be demonstrated to be true.
Yeah, I think at this point the Globers are just absolutely lost. Like they're spiraling. They if this is the best they got, it's really pathetic. I was talking with somebody the other day, and I'm like, literally, I think like one of the best proofs that Earth is flat and stationary and contained is the answers we get from the Globers. I mean, if you listen to them for 4, 5, 6, 8 years, telling us all these stories, and we ask the experts, we have PhDs, masters, doctorates, like in all these different fields. And of course, they don't have any experts really that have anything to do with what Earth is. They're in all these different things like astronomy, which is focusing on the sky, not the surface of Earth. So, of course, they don't have the answer. But none of these so-called experts have the answer. They just kick the can down the road. Oh, somebody else knows. So what I think is really brilliant is how Indio asks them, how do you know the Earth is a globe? Not how you think someone else knows. How do you actually know? And is what you think you have, is that actually knowledge? Or is that just some sort of an appeal to somebody else?
Are you guys talking?
Nah, just have a moment of silence.
Oh, Callus, you found it here. I'm so glad.
Oh, I've been here all day since I drove into work. I'm driving home from work now.
Great. Yeah, because did you tell the other guys how you didn't know we were here and then you were looking for us in politics? So that's great that you were here today. How'd it go?
Oh, I know. I was in here last night too.
Oh, good. How's it been here today?
It seems like a lot of Indian round earthers today.
Yeah. It's different here than the politics. You notice that?
Yeah, I've been in 3 different servers now, it seems like.
Yeah. Which one do you like the best? You don't have to have a favorite. I just wondered if you did.
I haven't noticed anything to choose a favorite yet.
Yeah, that's okay. You don't have to.
It's like the one where I met you on Woman's Night seemed to have like a lot more. Like I found that place without like needing an invite. You know what I mean?
Yeah.
What's up, Dandelion?
Too much. I just got back from taking my children to their violin and cello lessons, so I'm just hanging around. It's been a long day. I had to go to the Secretary of State, the DMV today. Although it's actually not as bad as it used to be, because now at least in Michigan, they make you have an appointment. They won't even let you go there, wait in line. So I actually got in and out of there really fast. It was nice.
That's cool.
How are you?
I'm good. I got a little pinched nerve in my neck, but other than that, I'm doing all right. Good day at work so far.
Good. Yeah, when you get home, you can ask your wife to massage it, don't you think?
She's got to work. She works at night, unfortunately. So.
No overlap.
No. What I'll probably do is I got a foam roller I can roll on. Maybe I might get a tennis ball, depending if it'll reach my neck. It's right in the curve of my neck. I can't retract it or anything.
Yeah, ask a Glober how you should do that. Next one that comes in.
Hey, did you hear my silly new my silly new refraction argument against the globe Earth when they talk about celestial navigation?
Let's hear it.
I mean, it's not a whole lot, but like you could definitely string this out, because when they hear it for the first time, they're going to be like, "What?" And then, of course, you can like stretch out the meaning of it once I tell it to you. So, celestial navigation uses triangles, right? You're going to have 3 straight lines. Globers claim that what they're doing is they're drawing a tangent from their line of sight to the horizon and then beyond the horizon, correct?
Seems like I've heard them say that, yeah.
Yeah. And this is the fun part about it, right? Like when we have these conversations. What's that?
I was just saying the last guy, that's exactly what he said. Why I asked him specifically, is that what you're saying? That, the horizon is a tangent, line of sight.
Right.
A line of sight tangent, right. Point.
Right. And when they claim celestial navigation and the stars and how we navigate the Earth, because the Earth's a ball, and all that, latitude, longitude, and all that. And then when they do the celestial navigation, what they're doing is they're drawing their baseline of the triangle to the horizon and then extending it beyond the horizon. And it's just a tangent line. It's not the base of the Earth or anything like that. And I like steelmanning their argument, because then it shows that we actually know what the heck they're saying and why it's wrong. So here's my joke about it. So that tangent line to the horizon is actually a curved line also, because that horizon is being refracted upward. And so you're drawing a tangent line not to the 3-mile horizon from a 6-foot observer height, but to the 20-mile horizon behind it. And so if it weren't for refraction, you'd be drawing a curved line to the 20-mile line. So celestial navigation doesn't work on a ball. What y'all think? Oh my gosh, one person at a time, okay? Did y'all hear me at all? Did I cut out? Fences will tell me if I cut out or not. Hopefully he heard me.
No, you didn't cut out.
Okay. Maybe it's a little bit to process because you know, I don't even know if we've ever come across that argument in a while, but it just dawned on me one day. It's like, all right, if the tangent line to the horizon is from your eyes to a 3-mile horizon, that wouldn't make sense if the horizon was 10, 15, 20, 30 miles away, because now your line of sight's going to the refracted horizon, which is even further than the physical geometric horizon that you're supposed to be doing your tangent baseline on. So therefore, you now have a curved tangent and you no longer have a triangle again. I know Jenna is loving it. Is Jenna even here? Did she hear that? No, she didn't. Oh yeah, she did. Jenna, you heard that. I know you heard that. You liked it. That's a joke that's right up your alley. Did you Fences, did you show that to CB? CB will fucking love that. Excuse my language, I'm so sorry. I'm bad with language. Oh, you stole it from him? That's even better. But yeah, this pinched nerve, man. How'd you get it? Oh, I was rolling around doing jujitsu. Oh, well, don't do jujitsu. Like, don't go hang out with the guys. Like, come on, man. You got to go hang out with the guys.
So to comment, because I couldn't comment at the time, Sheepdog. But yeah, okay. So that's basically what they're saying. So Andrew Thomas Young says that you have a curved line of sight when you consider refraction simply. I'll post it. I've got it saved here. The page on the home server. Just gonna go memes. Refraction assumed. Box saved it for me.
Yeah, so I think that's a great point. They're going to have to redo all of their calculations with a curved line of sight in every instance.
A curved tangent. Yeah, a curved tangent is
not only a curved tangent.
Contradiction.
That's the same thing. I mean, right? That'd be the line of sight would have to be curved.
So they're large O. So in that image there, they're large O, and they're the large O to large H, right? That's the curved line of sight. The little H, so the big O to the little O, or the little G. Sorry. Wait a sec. I can't see the letter. The big G. So the big O to the big G, the dotted line, that's supposed to be your tangent line of sight to the sphere edge, right? That's your tangent. So now they're saying that because the way that the light behaves, now you have a curved line of sight. You're actually seeing H, you're not seeing G. Yeah. That's what they claim. That's what the claim is.
This is a huge killer argument for the globe side, right? When we have these people saying, right, 7/6R and things like that, right? Because when we're showing these observations where we can see 21 miles over a body of water and there's no horizon present at all over that entire distance from 5 foot height. Right, they claimed like the meteorological conditions that would have to be present to allow for that crazy K factor, right, to exist. It's just impossible to exist. It's like the ultimate hostile witness that destroys the globe. Right, 7/6R. What's that like? Like what he's showing in his diagram here. If you account for quote unquote refraction. Right, it's just a little bit further. What's like 7/6R is like 16%. Right, most experts will say that's extreme refraction, according to the Glober's version of refraction or whatever you want to call it. Right, what we're seeing is like some crazy condition where you would have to have almost like this super red ducting condition when we just have a crystal clear observation over 21 miles. Or Dr. John Dee's one. So yeah, this is it's a killer argument to the globe. It makes it impossible for them to explain their long distance observations by saying refraction. It's a hostile witness. We don't have to make any claims about it being correct or anything like that. We can just use it as a hostile witness.
Yeah, there's the old saying, right? Like every good liar uses the truth to manipulate it. There's a little bit of truth in every lie. It has to be. It can't sound absurd. And then for some of the things, they're like, no, there's no way that story could be true. That's probably the more truer story. Like truth is stranger than fiction, right? So when it comes to good lies, there's usually a little bit of truth sprinkled, and that's where the hostile witness comes from.
Yeah, man. And welcome to anybody new that's come in.
Okay, so question regarding that diagram that I posted, right?
Yeah.
So the horizon that you'd be seeing, right, would lie at, in a straight line, like an imaginary dotted line that you could draw, right? Now, where could you draw it to meet the apparent, like the displaced position of H, right? Where's H appearing in your field of view? So that you could draw an imaginary dotted line, because you can't draw it optically, because that thick black line, that curved arch, that's representing the travel of the photons, right? So you can't use that. So if you were to use an imaginary dotted line, right, to that point, where is it in your field of view on that? Because it has to lie somewhere on that line, on that black line. So where is it? Where in your field of view does it appear? At the highest point between, between O and H in a straight line, or somewhere else? I mean, it's going to have to appear higher in your field of view than G would, right? So whereabouts does it appear? According to that, like I don't know how you'd figure that out.
It's ludicrous. It's a crazy claim. Doesn't make any sense.
Sorry, I interrupted your.
No, you didn't. Right, like they say that, like standard refraction, right? And this is the Globers that say this. I'm not saying this. They say that standard refraction is a K factor of 0.13 to 0.17, which is like 8 to 10% or something like that. And 8 to 10% means that you would be able to see that the globe essentially is 8 to 10% larger.